Hello everyone. I welcome you all to the live session on Python for Data Science full course by Intellipaat.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Now let's see the agenda of the day. Firstly, we will begin with Introduction to Python. In that, we will be explaining you what is Python and why do we need it, followed by basic topics of Python like Python tokens, statements, functions, data types, indexing, slicing, Python pandas and lot more. Post that, we will tell you what is data manipulation and Python NumPy. After that, we will tell you how to create NumPy arrays, followed by the difference between pandas and NumPy. Then we will be moving on to Introduction to Data Science. Post that, we will tell you Python packages for data science and also tell you why Python for data science. Then finally, we have covered hands-on demo on book recommendation system. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
What is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C# or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this. And Python is open source, if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. We've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. There are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much probably equivalents to putting out an output which gives out hello world. You can at least take a guess and understand, but then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, basically Apple's operating system, and you can use any of your favorite operating systems. In fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the number one language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. Let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. Now, I've broken it down to a couple of steps, and let's go with it together, right? So step one is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows. So we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with this screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Just before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now. And this will ask me for my admin password, because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. And I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install. And step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do a equal to 1, b equal to 2, c equal to 3 and so much more, right? So let us create a new variable d and then probably add a and b to it. So let me just quickly do this. We can print d. Well, d is 3. Let's multiply, you know what, let's create another variable, call it e, multiply d and c. Let us print e. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3 and so much more. To just get out of the console, you will have to type quit followed by parentheses and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotlib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
What is basically a data manipulation? Okay, so Python actually consists of a lot of libraries, okay, built in. That is what makes Python so much powerful, and that has increased the popularity of Python in these days. Okay, and lot many people are using Python for various tasks, not just data science, not just ML, or not just this AI, but Python has been used in other programming languages, other domains also for various other tasks like web development and something like that, and software development also. So this thing is called data manipulation. So data manipulation is possible with the use of Python libraries. There are very powerful, very brilliant Python libraries which are available for you. You can just simply install them, and there is a lot of code already written in those packages. So you don't need to write all of your code from the scratch. You can just simply go on and use those code to make your program much more capable of doing a lot many things. Okay, so what is basically a data manipulation? So NumPy that we are going to study today, NumPy is basically a data manipulation. So data manipulation in the most basic sense is we have to convert whatever data we have collected, we have to convert it into a manner so that it is much more organized and it is much more easy to process. So that is the basic explanation of data manipulation. So what are the steps basically? So you know that whenever you are making any data science project, whenever you have to start making any ML project, you have to get some data. Without data, you cannot do anything. You cannot start any data science project. So you have to get that data. So how you extract the data? So if you have heard about the concept of API, basically when we collect data, when we acquire data from multiple resources, from multiple sources, API would be one more thing apart from what. So those are also the ways, like we have flat files, we have databases, we have CSV files, and we what other thing is there, we also scrap some websites. Okay, we scrape some websites to get whatever data we want, and we store those into some flat files like CSV. Okay, and when we acquired those data, what we have to do is we will be manipulating that data. So why does we need to manipulate the data? Why do we need to manipulate the data? Why can't we simply get the data and start working on it? Okay, so why there is a need to manipulate data is whenever you collect data, it is not going to be perfect. It is not going to be pure because you are collecting data from multiple sources. Okay, you are not just collecting from all the CSV files. You are using some Excel sheets, you are using CSV files, you are using databases, you are using APIs, you are using web scraping. So all from all the places we have got some data, and when you started working on your project, you have a lot of different data. So in those data, the data, whatever data that you have collected will not be consistent, will not be exactly same. Okay. Yes, data cleaning is needed to fix the errors. Right. So for that purpose, to make the data, whatever data we have collected till this point, to make it consistent, okay, with each other, whatever data we have collected, to make it consistent, to make it basically pure, so that we can start working on it. So with that, we can start applying our algorithms, we can start applying our data analysis, whatever we have to do that thing. So for that purpose, we have to manipulate the data. Okay. Or maybe it is not in the format that you wanted, so you have to you can do that also, you can change their format also. So that also comes in the concept of manipulating data. Okay, so what happens when you have done the manipulation of the data? You get some organized and readable information. Okay, till this point, whatever data you have collected, it is rarely going to be, in real world, it is rarely going to be very much organized and readable. A lot of things would be just simply missing, or maybe not correct type is a type of data is there in some of the columns. Maybe some data is inconsistent. Maybe some of the units are not equal, like somewhere it is Celsius, somewhere it is Kelvin, somewhere it is Fahrenheit. So these are the things that could be there. So we need to make them consistent. So this is the thing. So for doing this data manipulation, we have a lot of libraries. The first one that we are going to cover today is Numpy. After that, we have Pandas. This is also a very powerful library. Then we have SciPy, and then we have Matplotlib. So Matplotlib is basically used for visualization purposes. Okay. So why do we actually need to do the data manipulation? So as I told you that as a data scientist, you will be gathering data from various resources. So when you are gathering data from various resources, from various sources, what is going to happen? The data will rarely be consistent. So there could be multiple problems. Like if you see what is the problem that we have to tackle if you're doing data manipulation, is basically these four problems you are going to tackle. There would be missing values. Okay, and why would be there missing values? So when you or maybe anyone in the company is collecting data, they might be doing some surveys, they might be collecting data from somewhere, and it is possible that when we were collecting that data, the equipment might not be available. Okay, so if we are just going on doing surveys, if you want to collect some measurements, for that measurements, maybe equipment is not available. Or in some cases, user is not willing to share the data. Okay, so suppose if a bank has gone to collect some data from all of its users. So what can happen in that case? If they are asking about the income that the company that complete family generates, whatever income is being generated by the company, so they want to know that information. So what can happen is in many cases, the bank can see that they are just telling some part of information. They are not telling, for various reasons, they are not telling whatever data acquire, they need to acquire. Okay, so in those cases, in those columns, or maybe there are some families who do not want to share their income data at all. Okay, so at that places, the data is simply missing. So that could be one case. What could be another case? We could have incorrect format of data. So what could be incorrect format of data? So when we have collected the data, so what can happen is the date format could be different, the format of currency could be different. So in some places you have collected the prices maybe for any of the things. So somewhere it could be in dollars, somewhere the dollar is simply not written. So that could be the thing that adds to the complexity. So that both of the data, if you see 10,000 and if it is written $10,000, so both of the data is not equal. Okay, you need to make both of the data in correct format, in consistent format. Okay, so what other thing could happen? We could have a different units. So we have collected good data, but the unit is not same. Okay, so what could be the thing? We could have this unit difference like Celsius, Kelvin, Fahrenheit. If it is about distance, it could be miles and kilometers. And then we have some unnecessary data. Okay, so for this unnecessary data, why unnecessary data is coming? Okay, so if you can just understand that whoever was collecting that data, or maybe you as a data analyst were collecting data from various sources. So what was happening that you thought that this thing is going to be useful for me. Okay, I need to collect data based on these many points, these many attributes. Okay, but when you started to make a project, you have various projects for which you are going to use the data that you have collected. So suppose one project you are using, in that you found out that the data, the complete data that we have collected is not going to be helpful. I don't need the complete columns or the complete things I have collected. I just need a part of it. I just need to know about these points only. I just need to know about these features only. Okay, I don't need to get the whole data. So in those cases, what you have done is you have just simply collected unnecessary data, or for that project, that would be considered unnecessary data. Okay, so yeah, this is the thing. So for example, if you have unique ID columns, which is basically not important. So if some data is showing you some ID column, some ID row is there, 1, 2, 3, 4, it is written. It is not going to be any use to you. Okay. So basically that is what? That is just an index number. Okay. So we can simply get rid of that thing, and just we are going to be okay with it. We have not lost any important data. So let's start understanding what NumPy basically is. So this was the basic of why we need to do data manipulation and what is basically data manipulation. So these are the things. And let us see the first tool which is available for the purpose of data manipulation. Okay. So the first thing that we are going to study today is NumPy. So first thing, let's start with NumPy. Okay, so what is NumPy basically? So till this point, you have not interacted with any library. You just have written the code, whatever code you wanted to write. You just use conditionals, you use loops, and use just basic data types, which is available in Python. You did not interact with any package, any library. So this is the first interaction of yours with a library that is present inside of Python. Okay, what type of data are there and we deal with in real world. So you'll get to know that what kind of data is there. Okay, I'll show you examples. With examples, you'll understand. Okay, don't worry about that. Okay, so what does a NumPy basically means? It stands for numerical Python, and it is one core library which is going to be used for a lot of numerical computations. So as you know that if you are working with any machine learning, with any data science project, you have to do numerical computations. Okay, because this mathematics and statistics is part of NumPy. Okay, so you have to do that task using NumPy. So if you don't have this NumPy package for you to use, what you have to do is, if you have to do any mathematical calculation, you will be writing code for that. And in some cases, in most of the cases, what will happen, it will take longer time for you to think the logic of that and just write the code again and again for a lot of things. So what developers has done is they have written a lot of functions inside of NumPy. So what they do, so all those functions have basically simple task of theirs. So what they will do, if you want to just add something, so for that there is a function available in this NumPy package. If you simply want to do any other operation like divide, or if you want to find some statistical information, like if you want to find the mean, median, anything, so, or maybe what is the minimum value in any row. So for that purpose, we have NumPy. Okay, right. So why do we need NumPy? So it provides functionalities so that we can make multi-dimensional arrays. So where multi-dimensional arrays are used, so I guess you are comfortable with the concept of arrays. Okay, arrays are basically a data structure which consists of same type of data. Okay, so that will consist of, if you can simply make all the data of integer type, you can make an array of all the float type, you can simply make the data of strings. Okay, so that you can make inside of here Python, and that all is possible with the use of NumPy. NumPy makes it much more easier for you to make multi-dimensional arrays. So you must be thinking that if you have read about the concept of list, you can make multi-dimensional list also. So why do we need actually NumPy? Why do we need another library? Why do we need to learn about a new concept? What is the advantage of it? right? You must be asking that. So this is the basic thing. If I want to make something, if I want to make a multi-dimensional uh, array, that I can do basically with the list also. Okay, so I can make multi-dimensional list, and list also basically looks like much like an array itself. Okay, so I'll show you what is the advantage of it. You will see that what is the basic advantage of it. Okay, so if you understand, if I tell you in basic terms, NumPy is completely memory efficient. It is a hell lot memory efficient than any other data type which is present by default inside of your NumPy. And it is much more faster than those data types. It is much more convenient and has a lot of functionalities to do a lot of tasks. Okay, and I'll show you numerous examples. So how things are different here, how things are different in NumPy compared to other concepts. Okay, so NumPy, if you can see why NumPy is much more faster than other concepts of Python. NumPy is basically built on C language. Okay, and as you all know, if you have studied about C language, C++ language, so they are much more closer to the memory of the system. Okay, Python is not that closer to the memory of the system. So the execution of Python when compared to C or C++ would be slower. Okay, so that is the difference. So what has happened is NumPy is based on C language. So that is one functionality that makes NumPy so much faster than all of the data types which is present inside of our Python package, right? So NumPy, inside of it, NumPy basically consists of integers, some floating point, and also it consists some of the data types, which is list and dictionary, for faster mathematical calculation. So you have seen that lists are a way more flexible thing. Okay, so if you have studied about the concept of lists, you can see that we could do a lot many things with list also. And but what happens with NumPy is it just makes everything faster, make every calculation, and it also makes it much more memory efficient. So these are the kind of array that we have to understand. This is 1D array. Okay, so array, if you have, you must have some basic understanding of array. So this is an array. This is a 2D array, and this is a 3D array. So this is just a diagrammatic representation of how an array basically looks like. Okay, so to start to do anything with the NumPy package, what you have is you have to import that package. Okay, you till this point, I don't think you have imported anything. You have not imported any of the packages till this point. So this thing must be new for you. Am I right? Have you imported anything? Do you know about this thing called import? So this is something new. So let me tell you what a package is. Okay, what a package basically is. I guess that you have understood or have heard about the concept of module, which is there related to function, which is somewhat related to function. In Python, we have modules. So what a module is and what is the task that a module does and what are the things. So module is basically a Python file. Okay, so basically in most basic terms, module is a Python file that you have made. Okay, and what are the things you are going to put into that Python file? You will be, suppose if you are working in a company and you see that these are the tasks that I am doing it again and again. This kind of thing, this kind of code I'm writing again and again. So what you can do, instead of just again and again writing code in various other projects that you're working in, what you can do is you can make a bigger file. Let me show you with one example that what happens with modules. Okay, so you can think of module as something like this. So this is one big file where what you have is you have made one file, and inside of it, what you have put? You have put some of the functions. Okay, what you have put is some of the functions that you need to use again and again. Okay, you know that whenever I am working on any project, I am using these many things again and again. So what you can do, you can simply make a file of that. You can simply make a file of it. And what you will be able to do, you will be able to import functions from that. Okay, so what is importing means you will not have to write this function in your Python file. If you just call this, if you just import this module into the Python file, what will happen is, if suppose there are 20 functions written into your module, you have written 20 functions, and you need to use 10 functions from this module. So what you will have to do, you can simply call these functions directly from this another file. Okay, this is another file that you have written, and suppose this is the current file that you're working on. So here what you have to do is, you just have to import that module, and what will you be able to do? You will be able to use all the functions that is there inside of this module, and that is what makes the concept of module so much more powerful. It is very simple to a Python file. It is just a Python file. Yes, module is basically, you can say, it is a collection of functions, and apart from function, it will consist of other things also, other variables or something like that. Yeah, it will have the extension with Py Shiba. Yes. Okay, so if you let me show you some example like Py math module in Python.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is one module which is used a lot. So what is the thing there inside of a module is, let me show you those things. So this is one module, and what are the things which is present inside of this module is, you see, we have the ceil function inside of here, we have factorial function inside of here. So I think that you all know what factorials are, and you must have written about this code at some point. If you have worked on other programming languages, you would have worked with this factorial function. You would have written a program that calculates factorial of any value. You would take one value and it will just give you the factorial. So for that, if you remember, you would have written 7 to 8 lines of code basically. Okay. Or maybe if you make it efficient, you would write 3 to 4 lines of code. Okay, whatever it could be, you would have written some bunch of code, some line of code to perform this operation. So if you are seeing that we are using a lot, see, there is one is square root, okay, and there is mod, and there is a lot of things that you can just simply go onto this website and you can see that what other things we have. Okay, we have to do the exponential, we have to calculate the log of it, we have to simply do the square root of any bigger number. We don't have to write any program for it. This is completely available inside of your math module. So what you have to do, you have to simply import this module, and how you will be using this function, which is present inside of this math module, you will be calling this function using its name. Okay, you just have to write math.sqrt, and whatever number you will be writing here, it will just simply calculate for that. Is there math class name or a file name? Name of the file. Okay, math module. So this is the name of the file, math.py. Basically, it will consist of this name. Okay, and you have to import this module for you to simply work on. Okay, so when you import this, you can start working and you can use all of these functions which has been pre-made for you. You don't need to write the code for factorial. You can just use this factorial function and start working directly. So till this point, you have already seen that why do we use function? It makes our task easier. If we have to repeat some concept again and again, what we can do? We can simply make a function, and inside of that, we will just write that code, and we don't need to write that function again. We just need to use the name of the function. And whenever we call that function, we pass some values. It will just give us the result, whatever we wanted to do. Okay, so that made your task very easier. That made your life very easier. What more you can do? When you use module, you don't need to write that Python also into your file. It will be saved into another file. You just have to import that file and you will be able to work with it. Okay, so there is one concept of module. Then comes the concept of package. What is package? Or you can say library also. What is a package? So as you have seen that, so let me make you understand what is the difference between a basic module and what is the difference with this package. Okay, what is a package basically? So here you have one file. Okay, in a package, what you will be having is, instead of having just one file, you will be having more than one files. Okay, so package will basically consist of more than one file, and what they do is they have some code written inside of it. Okay, so whatever task people usually do, whatever task developer usually do, that everything will be written inside of this files, okay, which comes inside of a package. So NumPy is similarly a package which consists of some file, which is similar to the concept of module. So what is the advantage of it? Suppose you are working on a task, you are working on a project. What you can do, you don't have to write whatever code has been written in these files. What you can do is simply just start to import this thing. You will simply call this complete library, which is NumPy. If you just call this NumPy library, what are you going to get? You will get access to all of the files together. Okay, you will get all of the files which is there inside of NumPy, and you can start importing whatever function is present inside of this, and your task becomes even more easier. You don't need to write a single line of code. You just have to import this library and use their functions. So the way you have called your functions, similarly you will be calling these functions, but the only thing that has changed is you need to first import this library. That way your Python understands that this is the thing that is happening in the background. Okay, right, let's see more of it. So understand what will happen if we have imported this package, this NumPy package inside of our current Python file. This is what going to happen. Now let me show you one example. Let me show you how much memory efficient and how much faster a NumPy array is compared to a data type inside of a Python. So why do we actually need to use Python? Why it is so much popular? Why do we have a complete package which has been used by a lot many people in lot many domains? Okay, so what is the advantage of it? Let's see. First, we will be doing the memory comparison of a list, and we will be doing the memory comparison of an array. Okay, so before moving forward, let me just refresh you some of the concept of list. What basically is a list? So you understand that what is a list? List is basically a data type which is there inside of Python. In this list, you can save some elements. Okay, and what kind of elements you can put? You can put strings also, you can put integers also, you can put float values also. Okay, so list consists of all of the things. It is much more flexible. Okay, and we can do a lot of things. We can store whatever we want to store here. So whatever is there inside of NumPy, you will be getting access to that when when you just write this thing, when you just simply write import NumPy as NP. Okay, so what we are doing is, for this is the thing, this is import NumPy, and this thing whatever I'm writing is I'm just renaming this package. Okay, so what happens in, there are a lot of libraries like matplotlib. If you talk about matplotlib is a bigger name. So wherever I want to use this NumPy and I want to call some functions on it, I will have to write NumPy again and again. I don't want to write this big name. I don't want to write matplotlib, a bigger name, again and again. So I can convert it into a smaller thing. Okay, I can rename it. So this is the way, this is the thing, you are importing NumPy as NP. Okay, so this is just a renaming. This is just an alias of it. Okay. Okay, so you don't need to import NumPy. You don't need to download NumPy. Okay, if you are using this Anaconda, if you are using Jupyter here, you don't. It comes pre-installed with it. Okay, so that is why it is recommended to use Jupyter. It has a lot of libraries. Whatever thing you want to do, there is a possibility that it is already installed. It is already been given inside of your Jupyter or Anaconda package. So what is the advantage of using Jupyter? You can write C. We have written notes also. We are writing programs also, so that everything you can do in one place. Okay. And if you're using Visual Code, you'll have to comment it out. Whatever statement if you have to write, you'll have to comment it out. So that doesn't look much more beautiful, and that makes it a little more confusing. Okay, so for this purpose only, we have something like this. Okay, now we will see how a list work actually. So if you want to make a multi-dimensional list, what you can do? If you are making a simple list, this is the way you are making a simple list. Okay, let me just show you. If you want to make any list, what you can do is simply make this square brackets inside of this, whatever elements you want to put, or you want to put the strings also, you can put string here. If you want to put another list inside of it, that also is possible if you want to do that. Okay, so you can just simply write. So this is also possible. Inside of it, there is something called tuple if you have studied about it. So tuple also you can put inside of it. Okay, so this is very powerful. This is very flexible. Okay, and this is one dimensional list. If you want to make multi-dimensional list, how you can make it? You just have to do the nesting of it. Okay, so if I just make second list, and I'll show you that how we can make a multi-dimensional list. So this is a way. Okay, you make a list. Inside of it, you will be writing one list and comma another list. Okay, so if you want to make any number of lists, you can do that. This basically makes your list multi-dimensional. So it makes it two-dimensional. Okay, and if you want to make it three-dimensional, you can simply make another list here. So what we are doing is we are just nesting list inside of list, list inside of list. So this is changing the dimension of the list. It is much more capable than using just a simple module. Okay, so this is a way we can make multi-dimensional list. Okay, you just have to intend list inside of list inside of list. So what it has given us, we have made three-dimensional list here. Okay, so this is the thing. If you want to put any values, this is the way you make a list. Okay, so how do you add two lists together? Okay, why I am showing you this, I'll be comparing it with NumPy. So when we use NumPy to do all of these operations that we are seeing in this, how in comparison, how much faster it is and how much convenient it is. For that comparison, I'm just showing you these examples. Okay, so you have basically two lists here. Okay, and you have just put some values. If you use this extend function, what you will be able to do, extend method does is, when you write the name of this first list and then dot extend, you write the name of your second list. What it will do, it will start to add the elements of this two lists together. So you can see it has made one bigger list, 1, 2, 3, 4, 5, and 6. So this one list consists of now both the values. So this is the thing. This is how you add two lists together. Okay, and you can just simply use plus this symbol. If you just simply write lst1 lst2, you will be able to add both of these things. Okay, so this is just about adding the all the elements of two lists together. But if I want to suppose sum these values 1 and 5, 2 and 6, 3 and 7, 4 and 8, if I want to sum both of these values, so for that what I'll have to do, I'll have to perform this operation. I'll have to write this kind of code. So what is this code? I've made two lists, very basic two list I've made. And then I have made an empty list. Why I have made an empty list? I'll be adding some values to it. What values? I'll be adding these values and I'll start to put values inside of my empty list. Okay, if you just use plus operator, or there is not any other operator which simply adds both of these, both of the elements inside of this two list. It will not simply add 1 and 4, 2 and 5. If you are using plus, it will just add the elements 1, 2, 3, 4, and then 4, 5, 6, 7. It will just put them together. It is just doing a basic concatenation of that. But you don't want that. You want the addition of both of the elements. So in that case, you will have to write a logic. Okay. So what I'm doing is I'm just running my loop 4 times. Why 4 times? Because I have to do this addition operation 4 times. Okay. And what I'm doing is I'm taking list I and then list to I. So what is the value of I? In the first time, it will take the value as 0. It has to run 4 times. You understand? This code is going to run 4 times. After that, what will happen is, in the first instance, it will take value as 0, then 1, then 2, then 3. This is the value it is going to take one after the other. So for first time, what is going to happen? The first index values from both of the lists is going to be added. 1 plus 4. Okay, so this operation happened for the first time. So when this operation happened, what I'm saying is that I'm not just doing this operation, I'm also adding Okay, I'm just adding this element to my empty list. Okay, why I'm doing this? So that I get a new list which consists of the addition of both of the elements together. So this is why I have to write this code. Okay, then it goes to the first place in both of the lists, then it goes to the second place, then it goes to the third index values. Exactly. So this is one way. You can't simply just use plus and add the elements of two lists together. Okay. No, it is not possible without loop, because using plus, it does the concatenation. Okay, and I'll show you that if I want to do the addition inside of NumPy, is it possible if I use just simply plus symbol? Is it able to do the addition like what we wanted? Okay, so this is the concept list slicing and list. I'll tell you this concept list slicing also. Let's first go and see more of it. Okay, so now you understand that we have something called list and we are going to study something called array. Okay, so now what I'm doing is, just don't worry about this code. Just see that what is the thing I'm going to show you. I'm just doing a memory comparison. I'll explain you what these things are. Just see that code, what.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
What comparison I'm doing and how much difference I'm talking about, how much advantage NumPy basically has over other packages or other data types that we have inside of my Python. Okay, so let me show you first. So this is a list. Okay, I'm making a list that consists of 100 elements. Okay, and I'm making an array, which is my NumPy array, that consists of 100 elements. Okay, I've made two lists that consist. One is a list and second is my array, which is my NumPy array. Okay, so I made these two elements. Now, if I'm checking the size, how much size one element is taking inside of this list, and how much size one value takes inside of an array. So let me show you that. If this is the thing, this is one module that is there and it has some functionality. Okay, you can see it later. Don't worry about this code. Just see the things that I'm doing. Okay, so what I've done is I've made one basic variable, okay, which consists of some number. And if I check the size of it, it is showing me that it is taking 28 bytes. Okay, it is taking a huge memory. It is taking a lot memory. And if I talk about, if I make a list, if I put in other values also, and if I run this thing again, it shows you that it is taking lot much value or a lot more memory than simply variables. Okay, so this is about list. It is taking lot memory that we have understood. We have just used three elements and it is taking so much of memory. Okay, now if I check the size for similarly for the size of the arrays, how much size it is taking, how much size the arrays are taking. Okay, so if I check the size of it, I'm checking the size for 100 elements inside of array. Okay, it is showing me that it is taking 904 bytes. And if I check for one single item, how many bytes it is taking, it is occupying only 4 bytes. Okay, compared to this 28 bytes, we have made one variable. If I'm checking for one simple item, it is showing me that it only takes 4 bytes. In the cases of list, level of some level of the efficiency is being done, some level of things are happening, which basically does the memory efficiency. Okay, it will not keep taking a lot more space. Okay, just a minute. It will not simply take a lot many space if we have more elements. It will not keep taking 28 memory every single time. It is doing a little bit of efficiency in the background. But what is the thing? If you are checking for an item, it will be 4 bytes every single time. Okay, in the case of arrays, if you check for 100 elements, okay, in here 100 elements we have, and here if you check, it is taking only 400 bytes. Okay, so if I compare it to you, okay, sorry, I told you that this is an NumPy array. This is my list array, which consists of this 100 elements. And for this, if I'm checking the size of it, it is showing me 904 bytes it is taking. And similarly, compared to that, my NumPy array is taking only 400 bytes. So this was one example how much difference it makes. And if I take more values, so in real world, you will not be interacting with only 100 values or 200 values. You will be interacting with millions, sometimes 10 million, sometimes 100 million values. So in that case, this number, this difference is going to be huge. Okay, you can see that it is more than double if we are talking about 10,000 elements. Okay, so now we can see the real difference. Okay, so this was about memory, how much efficient NumPy arrays are compared to lists. Now, if I show you how faster it is compared to a list. So what I'm doing is I'm just making a list, and what I'm doing is I'm doing the square of every single element, and I'm making a new list of all the square of all the list elements. So it will start from 0, it will go till 999. Okay, it will start from basically 0 till 999. And what it will do? It will do the square of every single element, and it will start to put inside of a new list. Okay. So for this operation, if I check the time it is taking, this is one way you check the time of any operation. So if you are checking the time that my Python is taking to run this operation, it is showing me that 323 microseconds it is taking, plus minus 2.78 it is taking. Okay, so this is the thing, this you have seen the figure of it. Now for the same thing, if I'm doing for NumPy arrays, if I'm taking 100 elements, 0 to 999, and if I'm doing the square of it, what is the time it is going to take? So you can see that it is taking only 2.505 microseconds. So you can see that it is the difference of more than 200, basically 150. Okay, and this is the huge difference. This is a very huge difference. You can see we are just talking about 100,000 elements here. If this number was much more greater than this, so you can understand the time it would take to execute basic commands, basic functions. It will take a huge lot time. Okay, so this is the advantage. This is the advantage that NumPy arrays have compared to list. That is why NumPy is used for every single mathematical computation. Whatever computation you have to do inside of a Python, the NumPy library is going to be your preferred choice every single time if you have to do any operation. And there are much more functionalities. We'll see what more things are present inside of NumPy, which makes our life easier. Okay. So if you have to create a NumPy array, what you can do is you can simply take a list. Okay. So I am taking this list one, and whatever way you make a list, you can just simply make any single list. And what you have to do is you have to just write, you have to just make a NumPy array out of it. So in this case, what will you be passing? This is the way you have to use this thing. So you have written this thing. What will happen is if I just print this, see, it has converted this list of ours, this another data type we have had. This is converted into a NumPy array by just simply using np.array. So this is the first way. This is the first way we create NumPy arrays. Okay. What more ways we have to create NumPy array? We can convert a tuple also. So this is our tuple. If you want to convert my tuple into a NumPy array, we just have to create one tuple, and I'll be passing that tuple directly. Okay. And this way it has converted tuple also into this. Okay. But what is the thing? You can use other thing inside of list also. So if I write this thing to, and if I make a list that consists of string also, okay. So if I'm making this thing and it consists of 1 and then 1.2 and then 3. Okay, so this is one list, and when I convert it into my NumPy array, will it be able to give us this? Will it be able to convert it into NumPy array? Let's see that. Okay. So we are checking this thing, ARR, and then we have this list. Okay. So you can see that it has converted this also into a NumPy array. But is it correct? If you have studied about the concept of arrays or whatever I told you, so is it the correct way? Should we do this thing? Okay, it is happening in the background. If we are doing this operation, it is being allowed by the Python. But is it logically correct? Should we do this thing? Okay. So Bhagyarekha, you said no. So would you like to give some reason why should we not do this thing? So when we are talking about this concept of arrays, even if it is allowing us to take different type of elements, we should not do it, because what will happen? It will simply defeat the purpose. It will simply nullify the purpose that the array has. Why do we use array? It consists of same data type, and when we have same data types, we can perform a lot more calculation operations. So suppose what will happen if I have made this array, this one, and another list also consists of some values. If I want to add two lists, it will not be able to do that, because if at this place, suppose Python is there, and at this place another list is there, which is consisting of, like, let me show you, consisting of 1, 2, 3, and 4. Okay, so this string and this integer value cannot be added, or it cannot be multiplied also, it cannot be divided also. So it will simply defeat the whole purpose of using arrays. Okay, so that is why we have to just make sure that whenever we are making a NumPy array, it consists of similar type of data. You have to, if you want to make a array of all the strings, that is completely fine, but you need to make sure that you put strings only, no integers, no float values. That is the thing. Okay, now here what we have done is we have made one list, and we simply pass this variable. This variable consists of this list values, and we have passed this variable here. But instead of that, if I want to simply pass my list here, that also we can do. Okay, and if you have lesser element, you can simply do this thing also. But if you have a bigger list that consists of 50 elements, 100 elements, so you will not go on writing that thing together directly here. So in that case, what you can do is you can just simply make a list with whatever logic you are making a list. If you have a list, you can simply pass that variable here. Like we have this list variable, you can simply pass it on here inside of here. So you are making np dot array you have here, and if you want to pass simply a list, you can pass that also, and you can pass whatever is the name of the list. If I write the name of the list, that you can directly pass. So that both way is possible, both way are correct. Okay, now there are some methods that we can use on NumPy arrays. Okay, and these methods tell us something, they give us some information. Okay, so inside of it, if we want to check the dimension of the array, okay, so what we can do, if I want to check the dimension, I have made this array. So by seeing this array, you can tell me that what is the dimension. If you can tell me what, by just seeing this one array that we have made, all the arrays, be it this one, be it this one, be it this one, what is the dimension of this array? 1D. Okay, you can simply see it and just verify that it is one dimensional array. Okay, it consists of only one row and some column elements there. Now, if I want to check the dimension, you have to just write the name of your array, whatever array you have made. We have made here a array. So that with this, if I write dot endim, okay, after endim, you don't need to write any bracket, anything like that. Just write end dimension. So what it will give you, it will give you whatever is the dimension of your array that you have created. If you want to check the shape of your array, okay, if you want to check the shape of it, it will check you the shape of, tell you the shape also. So what shape tells you that how many rows, how many columns are there. So here it is showing me 4 comma. So what this comma means? Okay, what kind of data type it is showing us? If you remember from the previous concept, if you have read about lists, tuples, strings, so what kind of data is this? 4 and comma. Okay, yes, I understand that this is row and column. So what kind of data? Yeah, exactly. So this is a kind of tuple. If you have made tuple, you know that if you are putting single values inside of a tuple, if you are making one tuple, and if you are having just one element. So in that case, what you have to do is you have to write that element name. After that, you have to put a comma. Okay, and if you have more elements, if you have suppose more than one element, in the end, in that case, you don't need to put a comma. But if you have just one single element, then you will be putting a comma. So from this, what we can understand is whatever output it is giving us, it is in the form of a tuple. Okay, so this is the information it is giving it to us. Okay, so whatever we are studying, we will be using the concept that you have studied till this point. Before this session, whatever concept you have studied, we will be using that in some small manner. Okay, so that is why the Python basics you have been taught, that is what the purpose of it, right? Now we have created our 1D array. Now we have to create our 2D array. How can we make our 2D array? So to make a 2D array, if I'm making 2D ARR, if I have to do this thing, what will I be doing? I can make a 2D list also and simply pass that 2D list directly here. Okay, sorry. This, you cannot start the name of a variable with number that you already know. Okay, so if I want to make a 2D array, I can take a two-dimensional list. How a two-dimensional list? I've told you that if you put list inside of a list, then you have two-dimensional array. If you put a list inside of another list, inside of another list, so that way what you have is you have three-dimensional list, and you can simply convert this into a array. Okay, so what we'll be doing here is that you try it out, try that part, make a 2D list and just try to pass it here, the name of it, try to pass it here. But what we'll be doing is we'll be using this raw method. What I'm going to make is I'm going to make this thing. Let's see that how it works. So I'll just put 1 2 here, and I'll make another list that consists of 3 and 4, and I have to just put it inside of another list. Okay, so this is what I told you about two-dimensional list. I pass two-dimensional list directly here, and if I see this D2 ARR.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
D2 ARR. Then it is going to show us that it has made us now two-dimensional array. So you can see that we have 2 rows and 2 columns. It is now two-dimensional. So this way also you can see that we have made this two-dimensional array. This is very simple. You just need to give it two-dimensional values and it will able to convert it into 2 dimension. Okay. Okay, lambda function is a very powerful, very useful function. You can do a lot of things with it. Okay, so I guess I'll move forward. Right. So you've made this two-dimensional array. This is the way you make a two-dimensional array. You can simply pass a two-dimensional list, or you can make a two-dimensional list directly here. When you check the dimension of it, it will show you that it is 2, which means it is two-dimensional. Now, if you check the shape of it, this B we are talking about, if you check the shape of it, it is showing you that we have 2 rows and then we have 3 columns that you can simply see. This is the thing it is going to show us. Okay, 2, 3, 2 rows and 3 columns. Now, if we want to create a 3D array, how can we make a 3D array? Like I showed you that if you want to make a 3D list, how can you make a 3D list? You just have to do the nesting. One list you made, and inside of it, you make 2 simple lists. Okay, and inside of it, again, you make 2 lists here, here, and then in this one list. Okay, this is one list. We have list, we have then 2 smaller lists, and then inside of it, we have comma, and then we have one list here. So you can see that I have put 2 lists inside of one bigger list, and then this complete list is inside of another bigger list. So 3 level of nesting we have done. So this is the way you make a 3-dimensional list or an array. So very similar to that, you can simply just make a 3-dimensional. You can just simply pass a 3-dimensional list, or you can make a 3-dimensional list like how you make a list. Okay, and then you can pass the name of that list. So what it will do the same exact thing. Now, when you see the dimension of it, you can simply understand that it is 3-dimensional. Here, it will show you something different. Okay, it will not give you just 2 rows, 2 columns, and there is some other thing. What this is telling us is we have 2, length 2, breadth 2, and depth 2. Okay, so this looks similar to this one. So this is how 3-dimensional array is made. It will have some length, it will have some breadth, and it will have some depth. Okay, so this will give you 3 things in your shape, right? So 1D array is called vector. So whenever you hear this term being used inside of anywhere inside of data science, you can just simply understand vector is 1D array and 2D array is a matrix. And after 2D, be it 3D, be it 4D, be it 5D array, whatever array is there, whatever dimension of array which is there after 2D array will be called tensor. Okay, so these are the names that you will be hearing. So if you hear these names, don't get confused. So, okay, 2D array is a matrix. This will be used a lot many times. 2D array and this dimension. All of these arrays are being used based on whatever is the requirement of it. Okay, so these are the names, just basically names for these arrays. Now, what we have done till this point, we have done the manual creation of arrays. So we have manually created arrays. How we did it? We use some list, we use some tuples, or we just pass directly some list inside of np.array, and we were able to create our arrays, numpy array. Now there are some functions available. We just can use those functions and we can get along with making our complete array. Okay, we don't need to write the complete thing. So what is the first function? This is the first function. This is called np.arrange. Okay, np.arrange. So when you have studied the concept of for loop, there you have heard about this word called range function. So inside of range, you would have given some values if you wanted to run this for like 10 times. So this is the thing you would have seen. Okay, remember this range function inside of for loop. Do you remember this range function? Have you used this range function in for loop? This has some functionality, this range function. Yes, okay. So very similar to that, this arrange function is just a basic extension of this range function. It does similar tasks, but when being used in NP, it is called a range. Just apart, instead of calling it range, it is called a range. So inside of it, whatever value you give, it will give you that many elements, starting from 0, going till n minus 1. It will not give you 10, it will stop one place before it. So that is the case that you have seen in almost all of the things. Then indexing will always start from 0 when you're talking in Python. Indexing will always start with 0 in, and it will stop one place before the whatever is the highest point you have given. Till this point, it will not give you 10. It will stop one place before it. Okay. Now, this range function also consisted of something called, what will be the start value, what is the end value that you want to put, and what is the skip value, what is the step value you want to put. Okay, by default, the step value is 1. Okay, if you're talking about range function or arrange function, you can put first value, which will be your start value. The second value will be your end value, wherever you want to end. And then the skip, if you don't write this third thing, if you don't write this third value, what it will do, it will take by default as 1. But if you want to skip more values, if you want to skip by 2, 3, any number of skip you can do. So what it will do, it will just skip those many elements and it will give you whatever thing that is left after it. So this is the thing. It is similar in range function also, and it is similar in arrange function also. Okay, so this is one thing. Now, if you want to create an array of linearly spaced out values, okay, and this linearly spaced out values can be in any range. It can start from 0 to 100. You can start from 0 to 5 also, 0 to 6. So let me show you. If I go from 0 to 5, you can see that from 0 to 100, it gave me 6 values. Okay, so why 6 values it gave us? We gave how many points we want. We said to the Python that using this linspace function, give me linearly spaced out values. So you can see the difference between them is 20, 20 points, 20, 20, 20. What it has done, starting point would be 0, end point was my 100, and the number of points would be whatever number of points I mentioned here. Okay, so what I want to do is from 0 to 5, I want to take 10 points. So if you write this from 0 to 5, what it will give you is, it will give you linearly spaced out values. Okay, and anything you can put 50 also here. You can, this number of points could be anything if you want to take 10 number of points. So what it will give you, it has given you a function with which what you can do, you can make some linearly spaced out array. Okay, you don't need to write these values. If you want to get a value something like this, this is what it is going to give you. Okay, so this is what the concept of lin space. It will give you linearly spaced out values. Okay, so let's see what more is there. Now there is something called np.ones. This ones module is np.zeros and np.ones. Why do we use it? If you want to initialize some array, okay, if you want to initialize with some array with little bit of it, y is not increasing by 5. Here it is not increasing by 5. Okay, so this is doing whatever it is doing in the background. Okay, we can't control it, we can't just do anything about it. So if you see that from going from 0 to 5, it is now giving us 5 points, which is linearly spaced out. Okay, so write out whatever is your confusion, try it out. So as you can see that if you have given from 0 to 5, and if you have told me that, if you told Python that give me 5 points which are linearly spaced out, in some cases it might show you some different value, but it will not be very different. It will be very similar or very close to it. Linearly spaced means the spacing between all of these elements will be same. Okay, so if I just, for simplicity, if I just start with the first example, what we had was, I want 6 elements. Starting from 0, I want to go till 100. I want 6 elements. And these 6 elements should be linearly spaced out. Means here you can see the difference is 20. Here also the difference is 20. Here also the difference is 20. Here also the difference is 20. And simply if I make it 10, what it is going to give us is 0, 11 point. I don't know why it is doing this thing, but it should give you 0 to 10, then 20, then 30. It should give us in that manner itself, 0, 1. This basically does linearly spacing out. There is some problem, I don't know. I'll check it out why it is showing something like that, because in some cases it is working perfectly fine. In some cases it is showing you some different values. Okay, I'll check you and let you know. No worries about that. Means equal part. Yes, Robin, equal parts. Okay, so the difference between the elements should be equal. Okay, so for just simplicity, let it be. Now, till this point, what we have done was we have created some arrays, okay, with some point. Now I don't know from the start when I'm making an array, I don't know what elements or what values I want to put inside of my array. So what I can do, I can initialize with some default value. Okay, I can initialize an array with a default value. For that, we have np.ones and then we have np.zeros. These are two things which is present for us so that we can initialize our array. So what will be the initial value? At every place, this will just put 1 and 1 for whatever dimension if I put. If I put 4 by 4, so it will give us for that dimension 1 and 1. Okay, and these all values are float value. As you can see, it is 1 point. Okay, so this is a float value. All of the points which will be there inside of it, it will be float values. Okay, by default, it is float values. Yes, the output is always in float. When you use np.ones, by default, whatever value it is giving to you, it is float. Okay, 1.0 it does not write, it is just writing 1 point. Okay, 1 point. So that basically means 1.0. Now you simply similar to that np.ones, if you use np.zeros, so what it will give you, whatever dimension you put it here, by default it will give you all zeros. Okay, so what will happen after it? So if you have initialized some array, what you can do at later stage, you can change their values with whatever value you want to put it. You can change their values. I'll show you how we change the values inside of a array. Okay, let's see what more is there. We have something called np.full. So in this case, what will we do is, first parameter is my 3 and 3. So this is telling me the dimension of it, and second value is my 5. Okay, so before moving forward, you must be getting confused that how do I know that what values I should put inside of it? Somewhere it is just simply dimension, writing the dimension. Somewhere here you can see that I have put dimension and then I have put the numbers, some value I have put. So to clear that confusion, what we can do is we can simply search for what we were studying, np.full or np.full. Let's search for. So always if you're getting confused about something, because you will not be able to remember every single thing here. These are very small methods, small functions. So you don't need to remember them also. By working, if you have worked on lot many projects, it will become a second nature to you. But if you have missed out, if you are not able to remember it, you can just simply search for this thing. np.full, if you write, you'll go onto this documentation. And inside of it, you can simply see that what are the values it is showing you. Reading the documentation is what makes you a much better programmer compared to other programmers. Whoever is out there, they are just following whatever someone has told them. They are not seeing that what is happening in the background, what are the values we can put, what are the things we can do. So for that, just just for a reference, just one go through the documentation of it, and it will tell you everything, whatever you wanted to know. Just search for it. So in this case, you can see that the first parameter that we can write is shape. So shape of the new array, it could be something like that. It could be simple too. So that we have done first thing. Then what is there? Fill value. Okay, so this is the second thing that we have had, fill value. So in this fill value, you can have one single number also. We can have array also. So here what we have done, similar thing. We just saw this documentation. You don't need to write every single parameter which is there inside of it. If you want to do this thing, this one or two first parameters will be useful for you, or maybe you will be using them in most of the cases. So this shape I understood, and this fill value I have to put. Okay, so this is the exact thing what I've done here. The shape could be in the manner of 3 by 3, or simply I could write 3. And this number, whatever number I want to fill it with, I have written it here. So if I want to fill it with 10, that also I have written it here. Now we have np.full, we have seen, we have np.I. In this case, what will be there? If you want to see about np.I, just do a simple Google search of it. And where you have to go, you'll see this first website, which will say numpy.org. So this is the official website. There only you have to go. It will show you other results also. But go onto this website. It will give you the documentation in very detailed manner. So there you have to go to refer whatever you have to see. Right. So np.I. So in this, whatever is it is showing you, whatever thing you have to put it here, it will show you in the documentation. Just see the documentation and it will tell you what things you can put here. So what I'm saying it to do is, what I'm saying is np.I and 3. So what it will do, it will make a 3 cross 3 dimension. Okay, it will make 3 cross 3 dimension, 3 rows and 3 columns. And in the diagonal, it will pull all the one values. Only one it will pull. Right. So np.I is this. If you want to change the dimension, by default, if you just keep one value, it will make related to that. If I write np.4, so you can see that 4 cross 4 it is making. But if you want to change the column, change the number of columns, so for that you will be writing whatever columns you want. If you want 4 cross 2, simply write 4 cross 2. So in that manner, whatever diagonal it will find at that place, it will simply put 1. Okay, at that place. So you can see that it has only found two diagonal places. So here at only two places, it will put 1. As you can see, this is very similar to that. At only diagonal places, it will put 1. Now, if you want to keep some other values at diagonal place, for that you will not be using np.I, you will be using something called np.diag. Inside of it, whatever list you give, whatever values you give, it will just make a list of that dimension. Okay, an array of that dimension. So you have given 1, 2, 3. So it has C. It has by default, it has changed the dimension to keep these values only at diagonal places. Okay, you can see that what it is doing. Now for this thing, you have made this thing. If you want to extract the diagonal value, suppose from any array you have made, you want to extract the diagonal value. Okay, so if you just use np.diag, give the name of the array, and it will just extract the diagonal value from it. Okay, so from here, if I run again now, will show you that it has fetched the diagonal values and kept it into another array. So it has made us another array for us. So if you are not assigning it to any variable, it is not permanent. If I assign it to it, now it is permanent. But if I don't assign it to any other variable, it is just showing you on a temporary basis. Okay, so if you want to keep any value permanent, you have to assign it to any variable, whatever name you want to put it. You can just say that name, you can just write that name, and with using that name, it will save it value for permanent. Okay, very similar to that, we have seen np.diag. Similar to that, we have something called random.rand. So this will give you something in this manner. It will give you random values. Okay, and these are not just any random values. They are statistical values. Okay, based on some statistical values, it is giving you these random numbers. Okay, so there is something called random.rand. If you give only one, it will give you it will give you an array in this manner. So 4 elements we have inside of one-dimensional array. If you want to give the dimension, complete dimension you want, or you have something in your mind, if you have another dimension you can in your mind, you can just simply put the dimension here. So what it will do is it will make 4 cross 4 matrix consisting of all the random values. Okay, so you can take it one step further. So what is happening here? It is making now 3-dimensional matrix, 3-dimensional array for us. So this is the thing that you can put here. Now after that, we have something called np.random.rand. So this is another thing. So inside of it, what is the thing? It consists of standard normal distribution. Okay, don't worry about this concept. When I explain you the statistics part, there you will be able to understand what is standard normal distribution and what is the value it is keeping. But for now, for simplicity part, you can see that it is taking some random numbers and it is just putting inside of your array. Okay, so you can think of it as array initialization also. Okay, so where these things will be used, these things will be used a lot, and you will understand when you are making projects, you will be encountered with something like this. You will be making all of these things. Okay, nothing, whatever you have studied here, it will not go in vain. Every concept, every single concept you will use in whatever conditions. Okay, in some condition, this random function will be used. In some condition, this diag will be used. In some condition, np.zeros, np.1 will be used. So you will do this thing whenever you are doing practical. You will meet with one of these concepts. Okay, so we have seen that how we can do the creation of the arrays. Now let's see that what are the type of data that we have inside of our numpy array. So to be clear, an array can be list, tuple, dictionary. Yes, an array can be anything. If you pass it a list, it will create with that elements only. If you pass it a tuple, it will create with that only, that elements only. For dictionary, you have to do something different. Okay, because with the concept of dictionary, you know that it does not simply consist of only the values. It consists of key value pairs. Okay, so you cannot put both the values together. You have to take the items, means you have to take only the values. You don't have to take the keys. Or if you want to put the keys, and for that you will have to just extract the keys. Okay, and this logic you must have studied in the concept of when you were studying this dictionary, when you were studying this thing. Okay, so the first thing we have is we can see that when we were using np.arrange, whatever values we were getting, this was all integer type. Okay, so this was all integer type, you can see it. Now if I want to convert it into float, I have created this array which is consisting of 10 elements from 0 to till 9. If I want to convert all of these into float, I'll have to just write one another parameter. And how do I know that I can use this thing? Just go on to search about np.arrange. If you search on this thing, this np.arrange you will be using a lot. So you need to know basic things about it. What are the things that is there inside of np.arrange? So if you go to this documentation, you just have to read 1, 2 basic things. It shows you that start, stop, step, these are things you can put. And D type you can put. By default, it is none. And what other things you can do, if you want to convert it into float, if you want to convert it into int, that you have to simply write here. Okay. So this is the thing. Now what is happening? If I give it one extra parameter, what I am telling it to do is convert all these integer values into my float value. Okay, float 64 is just one new name. because most of the systems are now 64-bit. So something similar to that, you can understand float 64 is mentioned. Okay. And if you want to make it integer again, you will be writing N64. If you have some integer values like np.ones, you saw that in np.ones we have all float values. But if I want to convert that into here, that convert it into integer, I just have to pass it another parameter. So if I just np.zeros also I show you, when I have said to my program that convert the data type into integer, so now it is now converting every single data into integer. So this is what is happening. Now, what are some other data types? We are very much familiar with integer and float, but what other data types can exist inside of my NumPy array is this complex number. So this complex number already also you are very familiar with. So inside of an NumPy array, we can also put complex number. If there is some calculation which requires you to use complex number, so you can always make an array of complex numbers also. So that is completely possible inside of your NumPy array. You can make an array of Boolean values also. Boolean values are basically true and false values. So you can make an array consisting of these values only. And what will you do if you have this array? You can pass it somewhere. You can pass it into any loop condition. So whenever it is finding true, it will run that loop. Whenever it is finding that to be false, it will not run that loop. So that experimentation, you can keep doing it. It will increase your programming logic. Okay, right. So after that, what you can do is we can always put string values also. So if you are putting string, all values, we need to make sure that we are putting in string values only. Okay. So these are some of the concepts, what kind of data that we have inside of our. Okay, after that, we have something called indexing and slicing. So what is the concept of indexing and slicing? Okay, indexing and slicing. So what is indexing and slicing? So this concept of indexing and this concept of slicing you have seen in list. Okay, so let me show you that these things you are basically familiar with. So moving forward, if you understand this thing, then you will be able to understand this thing also very easily. So let me show you what is the concept of list slicing. So what does basically slicing do? Can anyone tell me what thing we get when we do the slicing? What is the thing? Why we do slicing? We could just simply use, or we could just simply make another list. Why do we need to do the slicing? So we get a subset of a list. So in the case when we have small list, we can always make many small lists. But when we have bigger number of elements, we have more number of elements. So in that case, we can simply use this small slicing concept, which is very powerful, which is very effective, and it will give us a subset of the complete list. We could need this subset for many reasons. So for that purpose, what we will get is we will get a slice of this complete list. And this slicing does not need to be like 10 to 40 only will get, only 50 to 80 will get. Whatever condition you put in, if you put the step value to be 2, so what it will do, it will skip 20, it will give 10, 30, 50, and 70. These are the things you will get. So whatever type of subset you want to get, you can just simply tell. You can just simply write the concept for it. So what is this thing? What is this thing basically? So this tells me that if I have not written anything on the start, okay, if I'm not writing here numbers, so this is the way we do the slicing. If I want to take from 0 to any part, from 0 to 4, what it will do, it will take my 0th value, and then it will take my 0, 1, 2, and 3. At these places, whatever value is there, it will take all of those values. It will not go till 4. Okay, so this is the way. And if I just skip this thing, if I don't write anything for the start value, if I don't write anything for the end value, what it is going to do is it by default supposes that you are saying it to start from very start and go till very end, because you have not put any condition. So it will start from very start, it will go till the very end, wherever the end is finishing, the list is finishing. Okay, so this is the thing. Now you can just, if you put some stop condition, so you want to start from 0, you want to go till 5th position, so before 5, it is going to stop and it is going to give you this. Okay, And if you want to get this indexing, so this is the thing, numbers. If I run this part, this is the thing you are going to get. And if you want to get something from this location, if you want to get something from two location, what it is going to, this is my 0th index, this is my first index, and this is my second index. So this is the value that it is going to give us. So this is basically the concept of slicing and indexing that we are going to see here in arrays also. And if you I think you must know about this thing, but if you want to do the reverse indexing, what you have to write, if you suppose want to get this 80, okay, so I don't want to count from very start, like 0 1 2 3 4 5 6. I don't want to count it. If I know that from starting it is very close to the start, so in that case what I can write is I will simply write my negative indexing. So it will start from this point, and if I write -1 to -4, so let's sorry, -4 to -1. So if I write this thing, see what is happening. So this is basically a reverse indexing. Okay. So if you see this, if you want to start, then your end value, and then here also you will have your step value. If you want to step it out, if you want to jump for some elements, you can do that thing. It is very similar to what we have seen. Okay, in the range function also it is there. You can see it is present here also. That also you can do. Okay, so whatever thing you want to do, you can just simply write that thing. Right. So reverse indexing, you can do this part. Okay. Now,
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
we will see that how this thing happens and how indexing and slicing works in the context of Numpy arrays. So this is a chart. This shows us that where these elements are actually.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so you have a matrix of 3 cross 3. If you have a matrix, or you can say that this is an array of 3 cross 3. So I told you that if it is a 2D array, you can say a matrix. The name for a 2D array is matrix. Okay, so I have this matrix. It is a 2D array. So what will be the element? What is the address of the elements? What is being stored here? So if whatever element is there at this place, so this is the address I'll be using to take that element or to change that element. So this is the address of that element. Okay, so it is taking the row and column names, column numbers, and it is just telling me at that this is the addresses. If you want to access any element which is there at 2 comma 2, you have to use 2 comma 2. Okay, so how we are going to use this thing, let me show you. So what I'm making is, if I just mute this out, what is the thing I have is ARR. So if I show you that you have made this simple 1 to 5. And if you want to get something which is at the 5th location, if you are writing 5, what it is going to give us is this 5. Okay, 5 was present at 5th location. So this is what you are going to get. Okay, so this is the similar concept of indexing that you have seen here. Now, let's understand that what other things we can do is, now see, how we can use these things, how we can use these addresses to get some element which is present at these locations. If something is present at 1 2, if something is present at 2 2, how we can get that value. Okay, so what I have done is I have made a diagonal matrix, so it will make a 2D matrix for us. And inside of it, if I go to this 2 comma 2, so what is the thing it is showing us? So at this place, this is the location which is 2 comma 2, and you can see that at this place there would be 3. So if I run this again, you can see that at this location 3 is there. So if you want to access anything, you will be using this concept. This addresses you are going to use, and you will get whatever element you want out of it. Okay. Now you have got something from it. If you want to change some values, okay, this matrix is completely mutable. It can be changed. It is like a list. It can be changed. List also could be changed. Whatever element is present inside of a list could be changed. So similarly, whatever value is there inside of my array, numpy array, it could be changed. So what I want to do is at this location, this is my 2, 1. So you can see this is my 2, 1 location. At this location, I want to change the value from what was there from 0 to 5. So I just have to call that location. First, I have to access that location and simply by writing 5. If I write 5, if I want to keep 10 here, I can just simply write 10 here. Whatever value you give to any location, it will just make that change. So this is what you're doing is this is called data manipulation. You are manipulating the data. You're making some permanent change to the data, right? Okay, so we have seen the concept of indexing. This is how you do indexing. Very basic, very similar to how you have done indexing in the concept of list. Now let's see how we can do the slicing here. So for slicing also, the concept is very similar to the concept of list. So I made simple array, which consists of 10 elements again. I want to take from starting from 1, I want to go till 7, and I want to skip 2 elements in the between. Okay, so this is the thing that you have seen in list also. If I just skip this thing, it will now give us, sorry, it will now give us starting from 1 to 7. So this is the thing it is going to give us. If you want to skip anything from in the between, if you want to skip 3 steps, that is what you are going to write. So if you write here, so this is what you are going to get, right? So this is the concept of slicing, very similar to what you have done in this. Now, we can also combine the assignment and slicing. How we can combine this slicing and the concept of indexing? Let's see. So you have seen that if I want to get something from this location, I have to just mention that location. So here, what I'm saying is I have made one array, which is my this 0 to 9. I want to change all the values starting from 5 till very end. Whatever is the end, go till the very end and change all the values altogether. Okay, I want to change all of the values at once. So for that, what I'll write is I have made one this thing, and when I do this, when I just do this, let's see what happens. So what I have told is this: take the location which starts from 5, goes till the very end, and put 10 at every single place. So what is this doing is it is just replacing all the values in one single command. Okay, you've just given it one simple logic and it has replaced all the values which started from 5 and went till the last location. Okay, so now we have made, when we have made our arrange function, when we used our arrange function, what it was giving us. So if I just give this thing, so this reshape I'll tell you in more details. So what you can do is when you use this arrange function and you have 10 elements inside of it, starting from 0 going till 9, these many elements I have. Okay, so let's just take. So for this, if I want to reshape it, so how am I reshaping it? This is the way I am reshaping it. Okay, so I have 9 elements. So I know that I can put 9 elements in something like this. So if I change this dimension, let's see if it works. Okay, it is just telling you that not those many elements is not simply present here. Now, if I just put value 12 here, you can see that it is now working because we have 12 elements to put into this dimension. Okay, so this is the thing. You can reshape it by just using the reshape command. Okay, by using the reshape function. Inside of it, whatever dimension you give, it will convert that into that dimension. Okay. Now, if you want to get something from these locations, so let me show you that what I want to get. So I made one thing, and what is the thing I made here is just let me take 9 and then at this location I change it 1 comma 10 comma 1. So what I'm saying basically start from 1 go till 10 and just skip steps would be 1 and 1. So what I want to do, I want to take these elements 5 6 8 and 9. So I know their locations from where they are starting. I know their locations. So using slicing, I will do this thing. So what I know is this is my first row. Okay, this is my 0th row. This is my first row. This is my second row. Okay, and this is 258 is my first column. 369 is my second column. So if I want to get this thing, what I'll be writing first thing is my row, whatever is there before comma. Okay, so till this point, what we have done was we have just simply used a single. We have just simply used single times. Okay, in this case, what it will do is it will check, it will do this operation for only rows. But when you have used comma and after comma, if you have given something, now by default, what it becomes, this it understands this is your row, whatever thing you are going to give it for. This is for rows and this is for your columns. Okay, and these are the locations you want to extract from. Now what is going to happen? First, it will see that I want to, here it is written that you have to start from first row, go till the very last row. So my first row starts here and goes till this second row only. Okay, if I had more rows, it will go till 4 rows, 5 rows, 6 rows, it will go till that location. Now, second one is my column. Start from first column and go till very last column. So this 258 is my first column, 369 is my second column. So you can understand that these are my common elements which satisfy this condition. 5, 6, 8, and 9 is my common values which basically satisfy my condition. Okay, so you can basically understand that. We have to start from here and we have to start from 2, 3, 5, and 6. So I cannot take 2, 3 here. I cannot take 1 also. I cannot take 4 and 7 also. Okay, so any confusion? So you have seen that how we can do the slicing. Okay, how if I want to get some values which is present at some location, how we can do that. So for that, we have this concept of this thing, slicing. Okay, so for this, I am doing this one extra thing. So if I just write one here, let me show you what I am telling you is that if you just write 2 comma, so what it means is you have given the value for only row, only for row. But if you put comma and after comma, if you put something similar to that, what will happen is it is now understanding this has to be my column values. Okay, this is my row values, this is my column location. This is basically locations. So what it is showing, telling me that start from second row. Okay, start from second row, go till the very end row. So here we only have till second row itself. So it will take only these values. Okay, so if I just run this, so it will take only these values, and what I'm saying, telling it to do is take only this row and take these columns 2 and 3. Okay, you understand, these columns I have to take, and for row I have to take only this row. So this is the common element. What is the common element? Only 8 and 9. So this is what I am taking. This is just one way to slice it out. Okay, so now we have understood this concept also. Okay, so if I don't give any if I don't give for any column, if I don't put anything after comma, what it will do is it will just understand that I have to select every single column which is there. But for rows, I have this condition. My row will be starting from one place only. It will not start from 0, which is 1, 2, 3. It has to start from 4, 5, 6, 7, 8, 9. These many values I have to take. But for columns, I don't have any value. I will be taking all of the column values. This is the thing. And whatever is the common element in both of those things, that is what we are fetching. Right. So we have done this also. Now let's see what are the numerical operations. The the addition, the subtraction that we have talked about. Let's see how these operations happen, how these numerical operations inside of NumPy, and how easy it is basically compared to list, how easy it is to do this numerical operations. Let's see. So I make one simple NumPy array, and what I'm doing is +1. I'm just telling you that when I write this +1, what will happen is it will start adding 1 to each and every element one by one. Okay, so I have 1, 2, 3, and 4. If I want to suppose add 5. So this is very simple. So you can see that by just writing this one single thing by plus and 5, we are able to add something into our numpy array, and this is not possible inside of our list. Okay, this is not possible. If you have to add, if you do this thing, it will just simply append this into a list, but directly also it will not append. You have to make it into a list. Okay, so to solve that problem, to make it much more easier, we have something like this inside of my numpy array. Okay, so you see that what it has done, it has just added this scalar value to all of those values one after the other. Let's see. If I want to do this thing, if I want to do the exponentiation, for in the case of list, if I want to do this thing, I will have to write a for loop. Okay, I will have to write a for loop. But in here, I don't need to write any for loop. I just have to mention this thing, whatever is my numpy array, the name of my numpy array, and this exponentiation symbol, which what it is doing, it is just raising it to the power of 2. If I just tell it that raise it to the power of 3, it will do that thing also very simple, very easily. Okay, so this is what I was talking about. If you have to do any mathematical computation, if you have to do anything related to mathematics, you will be using NumPy. It makes your life much more easier. Okay. Now we have np.once. If I add 1 to it, that is also possible here. So what I have done is I have made my np.once and I have added 1. So what it has done, it has just simply taken all the values and added 1 to all of these values. Right. Now if I want to subtract 2 NumPy arrays, how can I do that? So that is also very simple. I can simply use this minus symbol. I don't need to run any loop. I don't need to do any complex thing. I have 2 arrays, which is my first array is this 6, 7, 8, 9, and my second array is this 2, 2, 2. So if second array is my A. So what I am making is, this is my first array I am making. This is my second array I am making. So when I run both of these things, let me show you that what is going to happen. So it is taking one element from this, and it is just doing the subtraction. Okay, so 2 minus 1, 1 we have 2 minus 2, we have 0, we have 2 and then 3, we have 1, minus 1, and then 2 minus 4 is minus 2. So this is what it is giving it to you. And why we have float values? Because we have used np.once. You can mute this float values by passing it d type is equal to int64. So you can get integer values altogether. Now you can simply do this multiplication also. You just have to write this one symbol a cross b, and it will do the multiplication element wise. Okay, every time any operation you are doing, it will do element wise. Okay, not directly everything will happen, not array wise, element wise operations is going to happen. Okay, so now you see that what it did, 2 cross 1 is 2, 2 cross 2 is 4, here 2 cross 3 is 6. So this is what it is doing. Now if you have to do matrix multiplication, how you can do a matrix multiplication? So what is a matrix? Matrix is a 2D array. So you have made a 2D array using your diag function. You can use whatever function you want to use. You can use once also, you can use arrange function, you can reshape it also, whatever concept I have taught you till this point. Using any of those things, you can simply make a matrix. And what will happen is, if you do this thing, if you just do this C cross C, what will happen is, at those diagonal positions, it is doing this C cross C, okay? It is doing this multiplication, 1 cross 1, 2 cross 2, 4, 3 cross 3, 9, and then 4 cross 4, 16. So it is doing matrix multiplication. So I guess you understand the concept of how matrix multiplication happens. So this basically, this row will be multiplied to this column at first time. So then this row will be multiplied to the second column, then third, then fourth. So this is what is going to happen. And when you do C cross C, when you multiply both of these metrics, you will find out that this is the output that you're going to get. So this is one way. If you have to multiply two metrics, you can simply make use of this multiplication symbol. Or the second thing, what you can do is use the dot command. Use the dot function. Okay, so when you use this dot function, inside of it, you have to write another matrix name. It could be anything. If you have made a matrix by the name D, that also you can simply put here. What will happen is C cross C or C dot C, both of these matrices will multiply. Okay, so this is what is going to happen. Okay, so this is just one thing I have printed out. These stars, I just simply printed them out to separate this thing. Okay, so this is nothing. I just printed out these stars to separate both of these things. So this is one way we do matrix multiplication, and to just separate it out, I printed these stars. And then we have second way, which is dot C. So this is how we do the matrix multiplication also. Now let's see how we can do comparison of elements inside of an array. Okay, this is just simple matrix multiplication. If you are not able to remember this matrix multiplication, this you can just see on the internet, you will be able to understand. Now let's see how comparisons happen. So we have two array. I just made two array. If I do the comparison, how can I do the comparison? So you know that this is, what is this sign? Is equal to, in every single programming language, this is equal to simply checks whether the value on the left is equal to value on the right. So this is what is equal to means. Let me show you that what I am doing here. You can pick any of the things. So whatever thing we have studied. So let me show you. If I want to take, you are saying that take a matrix like this, which has some values. Okay, so I'm just picking this thing. Okay, so let me show you that what I am trying to tell you. So this is my ARR1. I can say that this is my ARR1. Now I'll make another array, which is very simple to that, which is this. Okay, and I'll change the values here. And this could be starting from here going till 20. And if I just, okay, so now we have some values, right? Let me show you. Here are one, and then what my array 2 looks like. Okay, so this is what my array 2 looks like. So you now understand that what I have done, I have basically made two matrices. What is a matrix? It is called a 2D array. 2D array is called a matrix. Okay, so this is the thing you understand, that this is my first array. Okay, this consists of some value. Then we have second array. This consists of some value. Okay, what I want to do is, if I have to do the matrix multiplication, if I have to do the multiplication of both of the matrices. Okay, so till this point, what we have done was, we have basically done the, if I have simply 1D array like this, if I have this 1D array like scalar, and I want to do the multiplication, I could do this thing. I could do star and star. If I have two matrices like what I have taken here, you can understand I have taken the first matrix, my 1D scalar. Okay, 1D array is my this B. This is my second array, which is A. Okay, these two things I have taken. And when I multiply this, what will happen is, it will do element-wise multiplication. It will start multiplying these values one after the other. If I print A also, let me show you what is happening. 2 and 1 multiplied, we get 2. Okay, so let me put it here. So 2 and 1, we have 2. 2 and 2, we have 4. 2 and 3, we have 6. And 2 and 4, we have 8. So this we understood, that if we have 1D array, and if you want to do the multiplication, this is how it is happening. And this is the way you can do the subtraction also. This is the way you can do the addition also. So that you have understood this thing. Now what I'm doing is, here I have taken two 1D array. Now here what I'm doing is, I'm just taking 2D arrays, two 2D arrays. One is my ARR1, and don't worry about this thing. This is just, what I'm doing is, I'm just making a 2D array. You can make 2D array using np.zeros also, np.ones also, np.diag also. So these are all the ways how you can make a 2D array that we have already seen. You can use np.array function also. So that will give you some values. So what I want is, I want to make a 2D array which consists of these values, 3 cross 3. I have done the reshaping. It is doing the 3 cross 3 matrix. This is what I am getting by doing this operation. This is the way we make 10 elements. We make an array, 1D array of 10 elements. But this is just one dimension. And if I want to change the dimension of it, I have something called reshape function. Inside of it, if I write number these rows and these columns, so what it will do, it will make this, it will convert this 1D array into my 2D array. So this is what is happening. Now I have got my first ARR1 is my first matrix. Now ARR2 is my second matrix. These two matrices I have got. After that, what I'm doing, what I told you is that here, if you want to multiply these two matrices, okay, so for 1D array you have seen, for 2D array, this is very similar to this. So what you have to do is this thing I told you, that print C cross C. So let's print this thing so that you can understand this concept. Here are 1 and here 2. So this side, when I do this thing, you can see that it is doing matrix multiplication. Okay, in a manner how matrix multiplication happens, the same manner it is doing the multiplication here. Okay, so you get this point now, or are you clear with this point now, or do I have to explain it further? This is just the concept of matrix multiplication. This is there inside of linear algebra. There is nothing new that is happening here. This is just the concept of matrix multiplication. These two matrices are being multiplied. Okay. And if you want to read more about matrix multiplication, how matrix multiplication happens, just watch these concepts and you will be able to understand. Okay. So this is what is happening here. So this is what I was just trying to say. I've just done the multiplication. Previously, I've done for 1D array. Here, I'm doing for 2D array. But that's the only thing I've done here. Okay. So you can see it again if you want to see it. I've just made two arrays, and array 1 and array 2. These are my two arrays, and when you print it out, it will show you something like this, and then something like this. And then when you do the multiplication, it will simply do the multiplication, right? Okay. What is happening is, just see what is happening. So when you are using this this star, what it is doing, it is doing the element wise multiplication. Okay, so this I forgot to mention. When you are doing this thing, what is happening is, now if I print ARR1 dot ARR2, so this is what giving me the matrix multiplication. So this is what is giving me matrix multiplication. And when I do this similar thing, when I do this, when I use this star symbol, what it is going to give me, that it is doing the element wise multiplication. So first place 1 and 10, it is just multiplying this thing. 2 and 11, it is just multiplying this thing. 3 and 12, it is just multiplying this thing. Okay, so this was the thing. Okay, so sorry, I did not mention that. I just slipped off my mind. Okay. So this is what is basically happening. This is why we were having different values. This is the basic concept. If you have to do the matrix multiplication, you will be using this dot. And if you want to do the element wise multiplication for both of these arrays, this is my first array, this is my second array. If I want to do element wise multiplication, this is how am I going to do this. Okay. Now for the comparison thing. If you want to simply do the element wise comparison, this is how you are going to do this. So what I've done is I've just simply made two arrays. Okay, so to make any array, what you can do is just a1 you can write, and what I'm doing is just np dot arrays array, and you can write any value here. You can write 10, 20, and 30. You can write it here, and then we have a2, which is np dot array, and then we have 40, 50, and 60. Okay, so code along with me and you will understand. So now what I'm doing is, code along with me and you will understand this. So what it is giving you is, it is comparing for every single position. For 10 and 40 is comparing, for 20 and 50 it is comparing, 30 and 60, and okay, sorry, a1 and a2. I have, when I do this comparison, it will show you that not any element is equal here. Now if I change it to 10 again, and you can see that at this place, it is showing you that these two elements at the index position 0, these two elements are basically similar. Okay, so this is what my comparison is. Now let's see what second comparison I have. Second comparison, I can check for whether one element in one list is greater than one element in another list. So what we can check here is that if I check for this A1 and A2, let me print it out. So what I'm doing is this. For A2, if I have this, it will show me that it is not greater than. This 10 is not greater than 10. This 20 is not greater than 50. This 30 is not greater than 60. So if I just do this is equal to, now it is showing me that 10 is greater than is equal to 10, which is true. And it is giving me that. So it is doing basically element wise comparison. Okay, so now we have seen element wise comparison. Now if you have three arrays, if you want to check for element wise comparison, you have another way which is called np.equal. So if I check for this here, now I have made these two arrays. Okay, so now I made two array A1 and A2. If I do this np.equal, if I do this thing, what it will give me is I have to write these two elements, A1 and A2, is going to show me the same thing. Okay, it will just check me whether at which position the elements are equal. This is just going to check the same thing, exact same thing. Okay, so np dot equal, if you want to write, you can write this thing, or equal to equal to. Okay, so this is the same thing. Now, if you want to do the array wise comparison, the complete array will be checked. Okay, and at any place the element is not matching. So what it will show us is, so let me show you. If I change this thing, let me do it for this one only. What I want to do is np dot array equal. So this is what I am doing here is array equal. If I am doing this thing, np dot array equal, whether a1 and a2 is equal or not.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it will do the it will not do element wise comparison. It is not checking for one element, two, and two element. So it is giving me basically this. Now, if I want to make this two, if I change this values to same thing, and when I check this again, it is telling me that now both of the arrays are equal. Now both of the elements are very identical. Whatever element is there inside of it, it is identical. Even if I change one element inside of it, what will happen is it will give me false. Okay, because even if one element falls, the complete comparison does not match. Okay, so this is what is np.array equal. Okay, now we have something called logical comparison. So here what we can do is logical OR and logical AND. So what is basically logical OR and logical AND? Can someone tell me what is there? So when in this logical OR, if we have 1 and 1, what will be at this place? Okay, when we do the logical OR 1 and 1, what we get? Can someone please tell me? 1. Okay, and then we have 1 and 0. What it will print? For 1 and 0, it is going to give us what? So this is what is happening. So here you can see that only in the case of 0 and 0, it will show me false. Okay, why false? Because 0 is considered to be a false value. Okay, so whenever it is written anywhere, if you want to write anywhere, 0 is considered to be basically false. So false and false becomes false. Okay, so this is what it is showing it to us. Now, in case of logical AND, what will happen is, in the case of logical AND, what will happen? If we have 1 and 0, what is the thing it is going to give us? Okay, will it give us 1? Will it give us 0? What is the thing it is going to give us? Okay, false, exactly. So in the case of logical AND is, you need to have at both of these places, you need to have value as true. Okay, so 1 is considered to be true, and then it is also true. So 1 and 1 both becomes my true. Okay, and apart from that, wherever, even if one value is 0, it is just going to give us false. Okay, so this is what the condition of logical OR and logical AND basically means. Right. So if you are good with this, we can move forward with it. So now we have something called array mathematics. So how some of the operations, we have seen some operations previously also. Now let me show you what more is happening here. So if I make any A1, if I take my A1 also, and if I do np dot sum, and then I put my A1. What was my A1? Let me show you what was my A1. What is the thing that we have made A1? So there is something called sum function. Okay, what does sum function do is it will take whatever array you have and it will simply add all the elements together. Okay, it will simply add all the elements together and give us the result. So 10 plus 20 plus 30, it is just summing it up all the values. Okay, so this is what it does. Okay, what if I remove d type is equal to bool? Okay, let's do that also. See, d type is equal to bool means it just converted these values into boolean. Okay, so that the comparison could be similar. So what will happen is at the place of 1, if I was converting it into boolean, what will happen is at every place wherever it is written 1, it will in the background it will take it as a true value. Okay, so it is just mean that at the place of 1 I have written true. That is what it was showing. When I have written d type is equal to bool, that is what it was it was doing in the background. Okay, and if I remove it, it is just taking these elements and one. Okay, so that is just one thing, so that the operation don't fail. Okay, so for that purpose we have written d type is equal to bool. Okay, because you know that in logical or and logical and what we have is we just check for true or true and then true. So what we do is, just let me show you, we check for this. If there is true and then true, then what will be third value? This will be true. So for that purpose, so this operation to happen very smoothly, we have just converted this into Boolean type. That is what we have done. If you remove this thing, then also it will work. But so that this operation don't fail, for that purpose, we have converted this. Right. Now we have something called, let's see how sum works and how subtraction works. Let's see how these things work here. Now we have one array, which is my this 1, 2, 3, 4. When then we have 5, 6, 7, 8. This is my second array. If I just do the sum of it, if I do the sum of A, it will just take the sum of all of the elements and it will give us that value. Okay, and if I just check for B, and it will give us this value. The sum of all of these elements, 5 plus 6, 11, 7, 18, and then 18 plus 8, 26. So this is what it is going to give us. Now, A plus B, the same thing. Okay, so A plus B, if I do, what it will do is, see what it is going to do. If you do A plus B, then it will take both of these arrays, which is my first array is what? 1, 2, 3, 4. My second array is what? If I just print it out, what is my A for simplicity? And then if I just print out what is B, so this is what it is doing. 1 and 5, 6, 2 and 6, 8, 3 and 7, 10, 4 and 8, 12. So this is what it is giving us. So using this one simple plus simple, what we can do is we can add two arrays. Okay, we can simply add the elements of two arrays. So this is as simple as that. Now, if I do this np dot subtract ab, what will happen is, now see what we were doing is, we have this array A, we have array B. If I do the subtract operation, what will happen? 1 minus 5 minus 4, 2 minus 6 minus 4, 3 minus 7 minus 4 again, 4 minus 8 minus 4 again. If I change it to like, so this is what it is going to do is, now it is taking B first, this 5 minus 1, 4, this 6 minus 2 is 4, 7 minus 3 is basically 4, and 8 minus 4 is basically 4. This is what we have done. Okay, so this is the thing that is happening here, and similar thing will happen if you write this thing also. If you now write B minus A, this is what you are going to get. So both of these are similar. Now we have something called divide. So you can see that for divide, we have also something like this. If I want to divide two arrays, if I want to divide A by B, that also we can do. We just have to use this division symbol. Okay, just what I'm writing is A division 2, B. Then it is going to divide it by 2. If I want to divide it by one scalar number also, that also I can do. I'm just writing this thing. Now if I do this also, that if I'm taking my first array as A, second is my one scalar number. So in this case also what will happen, all the elements will divide by one after the other. Okay, so in A, if you see what is there inside of A, we have 1, 2, 3, and 4. So if I divide it by 2, what will happen? 0 0.5, 1.1, and then 1.5, and then 2. So these are the things that is the output that we are getting here. Okay, so this also you understood. Now comes the multiply. Multiply also you understand, we have seen it much more detail. So for this similar thing, we have this np.multiply. Okay, so now the thing is clear that dot c was the dot function that we used was doing matrix multiplication. But if you want to do the simple multiplication is this. Either we can use this star symbol or we can use this multiply. Okay, so both are fine. Now we have done this thing also. If I want to check to do more mathematical operation, what I'm doing is I'm doing the exponentiation. So in this case, what will happen is I'm taking a and I'm doing the exponential. Okay, so e to the power a. So what is there inside of my a? Let me show you. My a consists of 1, 2, 3, and 4. So what will happen? This is what going to happen. E raised to the power of a. Okay, so a means first time it will be 1, second time it will be 2. So this is what is happening here in this case. Okay, so np dot, this is what happening here is e to the power of 1, then 2, then 3, then 4. This is what is happening, and whatever result you'll get, you can simply check on Google also. This is the same result you are going to get when you do this exponentiation. Now, if you want to check the sign also, you want to check the log also, you want to check the cos value. So this similar thing we have seen that it was present in math module also. And this sign is present in this Numpy package also. So you can use whatever if you want to use it from math module. That also is possible. That also you can do. And if you want to do it this way, dot also you can do. This is perfectly fine. This is both of them basically serve the same purpose. Okay, so now this what we have done is it will take all the values. First time it will take 1, then it will take 2, then it will take 3, then it will take 4, and whatever is the sign value for these values, it will just give us sign value. Now for log, you know that log 1 is 0, so that is showing here. Then it will take for 1, 2, 3. So these are the things that is showing. Okay, log 0 is 0. Okay. Sorry, log 1. Yes, 1, 2, 3, and 4. So this is what it is printing us. Now, if you want to calculate the min, mean, and median, so you can do this also if you want to do this. If you want to find the mean of any array, whatever is the mean of any array, you can do that. So what I have done is, this is my, if I run this thing, now this is my A. I want to check the mean. So you know that mean is the average. So if you calculate this thing 1, 2, 3 plus 3, 4, and then 4. So we have, this is 10. 10 divided by 4, I'll get 2.5. So this is giving me the mean for this array itself. This could be a very long, very huge array. And when you are going to find the mean of it, you will be getting the mean of it. Very simple. And let me show you with one example so that you can understand it. Let me show you that this is a data set. Okay, just for explanation, I'm telling you this. So how this mean is actually applicable in real world, how you can find the mean of it and how you can use it to real world. So this is a data set. Okay, so this is a data I'm using. So what this data consists of is, this is my one row, this is my first column, second column, third column, and fourth column. So this data consists of something. These are some values which consist of something. Okay, and if I show you that what this data consists of, like what was the name, population.txt. So if I go inside of it, if I run this, if I show you that what is the thing. So first column is my 1900, which is my year. Okay, This is my ear, then we have hair, then we have links, and then we have carrot. So these are the values which is there for these things. So what it means is first column tells me that in these year, this was the number of rabbits which is present in Canada. This was the number of links which is present in Canada, and these are the number of carrots which was produced in Canada. So these are some hypothetical numbers. This kind of data you will be working with in real world. The data will be looking something like that. Okay, you will have some columns, and then you will have the rows, and rows will consist of values whichever has been collected for these features. Okay, so this in this one first row, what it is giving us is right. So this is basically the path of the tribe. Okay, so now let me show you that where this mean is basically used. I'll explain you this concept in a bit more detail in next session. So for this part, let me show you how mean is going to be used. So here what we did was we took a basic array. So this consists of some values. So we took the mean of this array only. But in the real world, if I want to take the mean, what mean will I be taking? So let me show you that. So this, you understand that these are similar. This is similar to what we have, what I have shown you. This is basically a matrix. Okay, this is 2D array. You can think of it as a 2D array. Here, if I want to check the mean, so what I'm writing is population, or if I write simply, let me run this part just a minute. If I run this, it has just loaded everything which is there into this file. Now what I am saying is take data. This is my data is my file data.mean. If I am doing this thing data.mean, very similar to what we have done here was.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
np.mean, and then we have put the data here. Okay, so here I'm doing something different, data.mean, and axis is equal to 0. Let me show you what it is giving us. So for each of the column, it is giving me basically the mean of it. For each of the column, it is basically giving me the mean of every column. Okay, so this is what how you will be using the mean, whatever mean I've told you, and this min function, how you are going to use this min function also. So let me show you how can I use this min function. So data dot min, what I'm checking is that I just want to know, I have a big data, I don't know that what is the minimum element present in every single column. I don't know what is the minimum value. So here I don't want to see and just check that this is my minimum value. So for this, what I have done is, if I'm checking that data.minimum, from this data file, check the minimum value. Okay, so what it will do is, it will check me for this column. So 1900 is my minimum from here. From here, you can see that 7600 is my minimum. From here also, some value will be minimum, which is 4000, and then 36,700. Now, what is this? Axis is equal to 0. Now, if I do axis is equal to 1, what will happen? So it will just give me for this, for every row. Now it is checking for every single row. When I have given axis is equal to 0, it is checking column wise. If I give axis is equal to 1, it is now checking row wise. Okay, so in every row you can see that this 1900, 1901, these are the minimum values. So this is what it is printing us. If I just simply do it max, if I do this max from every single column, whatever will be the maximum value, it is just going to show us. Okay, axis is equal to 1, it will check row wise, and axis is equal to 0, it is going to show us column wise. That is what we have done. Okay, so now I guess that you are able to understand all the concepts, whatever we have covered here. So you can write it this way also, np.max, and you can write the name of the array, or you can simply write the name of the array, which is a.max. Okay, so if you write this thing also, it is similar to that. So these are the concepts that we have seen. So from here, we will see in the next class. So some more concepts are left in NumPy. And I hope that if you want me to go through some concepts again, I'll just go through them again. So for this point, you can just see that what I've done here. we are going to see that some basic operations. We will try to take a data, okay, which consists of some rows and columns. And with that, what I'll do is I'll basically try to show you that how we can load data with NumPy. Generally, this loading of the data, whatever work we do with data, it does not happen directly with NumPy. It happens directly with Pandas. But for your understanding how we can do that thing with NumPy also, for that thing, I'll just show you what we are doing. So first thing first, what I am doing is we are taking this, we are importing our NumPy. Okay. So before working, or if you have started your Python file again, so you have to run every single cell again. Okay. And you have to import this NumPy whenever you want to work. Okay. So I'm just running this file again. So for that purpose, I am importing NumPy here itself. You can import anywhere, wherever you are feeling the need to import any library, you can just directly import that thing here itself. Okay. So we have this. Okay. So I'm just trying to show you that we are making one variable. Inside of it, what I'm doing is I'm using one method, which is np.loadtxt. So inside of NumPy, I told you that NumPy is basically a library. And inside of library that sir, I joined late. Can you give me an overview? So there was nothing, I was not explaining anything. I was just giving you some information that you have not missed anything, Ashwarya. We will move forward and you will understand everything. Don't worry about it. Okay. So this np.loadtxt, what we have inside of it is, this is a method that is there inside of NumPy. Inside, it takes some parameters. Okay. It takes some values, and what values it takes, you just have to give the name of the file in which you have saved your data. Whatever data it could be in the, it should be basically in the format of rows and columns. The same format you will see in Excel files also, use same format if you are familiar with CSV files. So that same format, if I show you that how that format looks like. So basically we will have some rows, we will have some columns, and they will consist of some values. Okay. And what are these values? You don't need to worry about these values are. I have taken some data, and a similar kind of thing you will see in every single data. Okay. You will have some rows. What are the rows? The whatever value has been collected regarding this. So in this rows, every data will be basically year. Here, I have the number of rabbits, which was there in any state or any country I've taken this. This data was basically there for you to understand. So here lynx is another animal. So it shows that how many animals were there who are lynx. And this is the number of carrots in that city, how much is the number at a current time. This is the data that has been collected, and every single data will look in the format of this basically. So now what we have is, for loading that data, we have to write this. Inside of NumPy, what we are writing, we are using load.txt. What are supported format of txt file, comma, separated, space, spatial? I'll touch on that. Okay, Bharat, I'll touch on that. Just after this, I'll touch on every kind of data. What is the kind of data available to us? Okay. So here you loaded this data inside of it. This is basically your variable inside of it. What you have done after you have run this operation, what will happen is every single data which is there inside of population.txt, what will happen is it will now be loaded inside of your data, this variable. What will happen if you have loaded everything? You can now start working with this data in your Python notebook file. Okay, if you don't import your file, you cannot work it here. So after you have imported your file, after you have got your file to this Python notebook that you're working in, after that only you will be able to do whatever manipulation you have to do. Okay, so I explained you that NumPy is basically a data manipulation tool, a data manipulation package we have. So this does some operations, some calculations. So these are things which is there inside of NumPy. Okay. So what I've done is, after I've loaded this thing, when I print out this data, this is how it will look like. So what it has done to this data, you can see that this data looks in the format of rows and columns. So after you have loaded your data, what it did was it converted into a format of arrays that we are familiar with. Okay, because that is what the work of NumPy is. it converts whatever data you give it into the format of an array. So if I just check the dimension of it, if I just try to check what is the dimension of it. So, and then if I just see, so you can see that this is a bigger file which consists of so many of values. And what it is basically, it is a two-dimensional array that we are familiar with. So till the point what we were doing, we were manually giving some values. We were giving some small values. We were giving some just random values to understand how 2D array, how matrix looks like. Here, if you have some data in the format of rows and columns, if you convert that with NumPy, what we have done, we have loaded it. And when we see this, NumPy has converted that data into the format of rows and columns. So what will happen now? You are familiar with this kind of thing. Okay, you are now familiar with this two-dimensional data. And what you can do with this, you have understood already that we have so many of the methods. We have min, max, whatever I taught you till this point. You have so many things that you can do on this data basically. So this is now a 2D data that you've got. Okay. So now we have data. We have seen the dimension of it. It is now understood that this is a 2D array that we are now familiar with. What we can do is we can check the mean of it. Okay. So what I'm doing is I'm just taking my data, whatever is your variable in which you have loaded it. On this, you will write your mean. Okay. And if you want to check for this x is equal to 0, you can do that also. So what it is doing basically, so column wise, it is taking the mean. Okay, so 1910, 34,080. So if you see this, it is taking column wise. If you have given x is equal to 0, what it is doing is for this complete column, for every single value which is present in my first column, it is calculating that mean. Okay, for second column also, for third column also, for fourth column also, this is what is happening. It is calculating the mean. Now, if you change the axis of it, just changing the axis of it, what it is doing is now is it is calculating the mean based on every single row. So now it is doing this way. Okay, so x is equal to 1, this way it will be doing it. So by just checking the axis, you can see that what it is showing, and by just seeing the output, whatever output you are seeing, you will be able to understand this is the thing. Okay. Yes, basically you can understand what zeros and ones are. By just seeing at it, you can understand what type of value it is showing. Okay. Right. So now data.max, here also what I'm doing is I'm just taking my data. On that, I have my max function that I can do. In here also, by default, axis would be something. So if I don't write this axis is equal to 0, then also it is taking some max. But what max it is taking, we are not sure of it. Okay, to this point, we are not sure that what max it is taking. Okay, so if you can understand, basically, it is taking for the whole data. Okay, for the whole data, whatever was the maximum value, it has taken that maximum value from the whole data. Okay, and if I run this also for mean, also let us check. If I remove this, what it is giving, it is basically, I guess, that it is giving us a mean for the complete data. Okay, so we have some small numbers here, we have big numbers. So what it is doing, it is taking all the numbers and it is giving us mean of that. So it is not much logical to us. Okay, we are not able to understand, we are not able to get any single information from it. So either we could do column wise or we could do row wise. Okay, so that is the thing you have to pass in. So that these are the values you have to pass in. If you give it axis 1, these are the values it will just print us. Okay, so now what if I don't want to take this first column? Okay, if I don't want to take this year column, I just want to take these columns, which is my second, third, and fourth column, and I want to do some operation of it. If data contain text file, whether mean in NP will work. No, for text file, how can you convert mean? Okay, because mean is a statistical value. So for any statistical value to work on, you need to have a number which is data which is in numerical format. You can never find a mean or max or minimum for any text data. Okay, so that is what it is. So in NumPy, basically, if you see what we have been doing is we can surely make NumPy of characters. We can take string values inside of NumPy and we can make an array of that. But what is happening over time, you are seeing that with NumPy, you are basically performing some mathematical calculations. So for performing mathematical calculations, you will be always taking numerical data. There is no sense in taking textual data. So that is what we are having. So the concern of textual data will be solved when we study pandas. I'll show you why why panda has been already actually made. Okay. So just hold that thought for a minute. Okay. So now what I'm doing is I'm making another variable, which is my populations. And inside of it, what I'm saying is take the complete uh, data that we have imported here. And here, if you see what I'm doing is we are basically doing the slicing. We are taking a sub part of the complete format, the complete data that we have. So what I'm saying is, let me show you data inside of it. If I give this, what it will do, it will take all the rows, okay, starting from very start, going till the very end. But in the columns, I don't want this 0th column. Okay, here I don't want this 0th column, which is my year column. I want to start from here. So the index for the second column is basically 1. Index start from 0. So the index column for this one is 1. So we will write that thing. So if you start from 1 and go till the very end, you could write 4 also, 3 also, whatever you want to do. You can write this. So what it will do, it will just take first and second column. Okay, the index at first and second. If you if you don't write anything, it will go till the very end and pick every single column after 1. Okay, so this is a subsection of the data that we have taken. Okay, now what we are having is we want to calculate the mean on that also. The procedure is basically saying you have to write the name of the variable in which you have imported your data, in which you have taken a subsection of the or slice of the data. You have to write your mean method. Okay, when you write dot mean, and inside of it, you just have to give axis 0 or 1, whatever you give. Based on that, you will be getting some answers. So what is happening? It is calculating the mean for all single columns. Okay. So this is the answer that you could find by just doing this one single operation. You don't have to do anything. You have just imported your data. You have just used one method which is present inside of NumPy. You don't have to write any line of code. You don't have to write any condition. You don't have to write any function. Whatever it is there, you don't need to check which values, or you don't need to write any function for basically calculating the mean. What it is doing, the code is already written in the background. You're just using the method of it, which is present inside of your NumPy library, complete NumPy library. Okay. Okay. Access is basically this. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So how am I taking this thing? So if I show you like np.math. So if I show you, so here you can see that np.max x1 x2 np. Yes, axis. Yes. So here you see that for whatever thing I'm telling you, for whatever things I'm teaching you here, is that you are working with NumPy and we are working with basically one method. Let's suppose we are working with mean here, okay? And inside of it, it will be taking some values here. So how do you know what values it is taking? You can simply go on and search for it on its documentation. So when you land onto this documentation, we now know that we have what we are working with is numpy.ndarray. Inside of it, there is one function which is max. Okay, and what it takes these values. So we can take one of these values and we can just simply pass on it. So axis basically tells you that in what manner you want to find the mean. Okay, so if I remove this axis, what was happening is this. So if I just remove this axis, it was finding the mean of the complete data. And that I thought that it was not much more meaningful to me. I'm not getting any information by just calculating the mean of complete data. Okay. So what I'm doing is I'm taking this, I think you are familiar with it. What I've taken, I'm taken my variable, which is data. Inside of it, my NumPy is now loaded. This data set is now loaded inside of it. And this is a 2D array, basically, 2D array. So we are familiar with what operations we can do on 2D array. So you just think this as a big 2D array. Okay, we have already made 2D arrays. We have already made matrices. So you take this as a big 2D array. Okay, this is why we loaded this data. This NumPy has converted into 2D array. So on it, what we can do, we have studied about this operations. We have studied about that we can find mean, we can find median, we can find minimum value, we can find maximum value. So that is what I'm doing. I've taken my data variable. On it, I'm doing my mean. Okay, I'm finding my mean, and inside of it, if I am just doing this data.mean, what it is doing, it is finding the mean for the complete data. But you know that this is not one single data. This consists of so many of the data for year, here, number of rabbits, number of links, number of carrots. So this is not any logical thing to do to just find mean for the complete data. You're not getting any information. So what you can do is you can just give an parameter basically to this, which is axis is equal to 0 or either one. These two axes it will take. Okay. So axis is equal to 0 or 1. Basically, these two things axis always take. Okay, these two values axis will be taking anywhere. Okay, these are the values which has been assigned to this. Now axis is equal to 0. What you are getting is for every column. So now you see that what we have is 4 values separated by comma. 1910. This is a float value. Okay, so after 0, after dot, it is not written it anything. Basically, it should be 0. So this is the way it is showing your information. What we have is we have something, we have a mean, we have again mean, we have again mean, and we have again mean. So what are these 4 values? Basically, these 4 values are for first column, we have some mean. Okay, it is basically what it is doing. You must be aware how we calculate mean. It is basically taking the average of this complete column. Okay, so what we have is the average of this complete column is 1910. You can calculate it, you will find this same answer. The average of this second column is given here in the format of this 34080. So this is what the average of this second column. For this third column, we have calculated mean. For this fourth column also, we have calculated mean. This is what it is showing. And if you convert it into axis is equal to 1, now instead of giving the mean for column wise, what it is doing is it is calculating mean every single row wise. Okay, for this row, it is giving one mean. For this row, it is giving one mean. What it is giving? The average of it. Average of 4 values calculated, it is just showing that to us. Okay, so you can see when you calculate row wise, you will get something like that only. Okay, so this is what the concept of axis is. Okay, so now what we have done, we have taken this population data. In that, what we did was we got rid of one column. So now why did I write this thing? So in the concept of list also, I told you that if you understand the concept of list, this NumPy array is basically very familiar, very similar to that concept. So here what we are doing is we are just doing simple slicing of the complete data that we have. We have 4 columns basically and some number of rows. Okay, so what I want to do is I want to take only second, third, and fourth column. I don't want to take my first column, which is my year. Okay, I don't want to take it. So for that, what I'll be doing is if I just write this one and this, if I just write this, what will happen is it will just give you everything starting from. So if I show you, it is giving starting from first row till the last row. Okay. If you don't give two numbers, if you don't give any comma, so what would it do is basically it will take this value for the rows. Okay. It will do the slicing on the rows. So if you have to take all the rows and what you want to do is you want to take the column starting from this, you want to get rid of 0th column. This is the index value. So this is the 0th column. This is my first column, second column, and then third column. So what you're writing is start with the first column and go till the very last column. So this is the only way. If you omit this comma, what you will be doing is you will not be getting this thing. So yeah, I'll print the output. So now what we are doing is you can see that we have completely got rid of our year column. Okay, we now don't have year column. We have completely got rid of it. So what this thing is, the first value, whatever value you give, this will be considered your row. For row, you have given some condition. Now, if you're writing here, if I show you, if you're writing starting from 1 to 8, basically, I am going 1 to 8. This is selection for my row. And what I want to say is just take the selection on the column. This is my selection for the column. This is my selection for the row. This is what is happening with this case. Okay. So that it is what it is doing. It is very similar to what we have seen in the case of list. Okay. So there also this slicing was happening in that similar manner. Okay. So we have two values. The first will be considered for the rows, whatever condition you give for the rows, starting value, end value, it will take those rows, those number of rows. And after separated by comma, if you give any value, if you want to take only starting from 2, so what it will do, it will take these values itself. Okay, it will take now third and fourth column. It has basically removed 0th column and first column. Okay, so this is what it has done. Okay, so now when we are clear with this I have taken. Now when I calculate the mean on it, we are getting mean on it also. If I want to calculate what is the minimum value in any column, so that also we can just print this thing. So now you can see here is that we have only few number of rows. So what we can do is, if we have time, we can basically see on this row and we can see that what is the minimum value. But it will take time, it will take hassle, and this is never a way if you're doing a programming. This is never a way to do something manually. If you can do something with by writing code, if you can make something much more easier, so that is the thing you have to do. So why to just manually go and see for the minimum value to calculate the mean of it, and why to write a function for it? Okay, we have already seen, if we are familiar with what kind of code we could write for finding the minimum value, what we can write for finding calculating the mean of it. So just saving ourselves from that hassle also, to avoid that also, we have this functionality built inside of NumPy. What we are doing is we are just using one method that is present inside of my NumPy package. I already told you that NumPy is a package. Inside of it, it consists of a lot of functions. It consists of a lot of variables. So you can think of it as a one function which is there inside of NumPy package basically. And in this function, what we are doing is we are giving some parameters. So based on this parameter only, it understands what you're trying to say. So when you have given axis is equal to 0, it has basically taken for the column wise. So column wise, it is giving whatever is the minimum value in that column. Okay. So these are some of the basic things so that you understand how NumPy works on a data. And every data that you take will be in the format of this, in the format of rows and columns that you are already familiar with if you have worked on Excel anytime. Okay. Now we have something called array manipulation. So there is something called this array manipulation. Okay, in array manipulation, we have something. These are the things that we have inside of array manipulation. So what I'm doing is we have numpy.concatenate. It does something, numpy.vstack, hstack, column stack. These are the things. Let's see one example of it, what these mean and how it is useful for us basically. Okay, so what I'm doing is I'm simply making, so if I just show it to you. So what I'm doing is I'm simply making two arrays. Okay. So this is one method for making array. I'm doing this. For making our second array, I'm taking another value. Okay. So what it does is it gave me basically two arrays, which is one-dimensional arrays, and both have four values inside of it. So now what I want to do is I just want to do this thing. Okay. So if I write np.concatenate, and inside of it, what are the values it will be taking? So here, this is the basic syntax of it, np.concatenate. If you write, this is the syntax of it. In here, if you have to give only one value, it is okay. But if you have to give more than one value, which will be required, at least two values if you have to give, if you have to concatenate them. What is concatenation? Basically adding the two values together, putting them side by side. Okay. So what we are doing is we are taking two simple arrays, two one-dimensional arrays, and what we are doing is we are taking these two arrays we have, and what I'm saying is do the concatenation of it. Okay. So what will happen is if I run this thing and if I just do this np.concatenation, so by default axis is equal to 0 is already there. Okay. And if you want to, let's see axis is equal to 1 is working or not here. Axis is equal to work, one is not basically working here. Okay, so concatenation, what concatenation does is it adds two values side by side. So what we have first array which is A. So if I print out what is A and what is B, so A is basically this and B is basically this. Okay, so A and B are these values. So what is happening? 0, 1, 2, 3, 4, 5, 6, 7. These are concatenated together and has made one bigger array by adding these things. What we are doing is we are taking np.addStack, and what we have done is we have taken some values which is A and B. These are the two arrays we have. And if I run this thing, what it is doing the horizontal stacking. Stacking means it is uh, taking both the arrays and it is putting them side by side. Stacking means basically adding them on the top of each other or basically in the sidewise. Okay. So what we have done is we have these two arrays and we have put them side by side, but we have made them into one bigger array. Okay. So what we have done, we have basically added these two and we have put them side by side. So this is how it looks like. So two simple arrays, two small arrays now have become into one bigger array. Now, what is the other thing we can do? np.vstack, if I write, and inside of it, if I give both of my arrays, what it will do? Now you can see that it has done the stacking. It has put both the values in column wise. So what it has done? So first array took and second array took, it put below it. Okay, so this is what it has done. Both in this done in horizontal style. This stacking has been done in vertical format. Okay, so this thing what you have done, you were able to convert two basic one-dimensional arrays into two-dimensional array. So this is how stacking has been done. So this was the concept of concatenate, what it is doing. This was the concept of horizontal stacking. This is the concept of vertical stacking. So in this case, you can see that in the case of vertical stacking, it has not added them together into one single bigger array. It has taken both of these arrays and it has put them one after the other. So this is what it is doing. It is doing the vertical stacking of the both of the arrays. Okay. So now, what is the column stacking? What happens with the column stacking? When we take two values, what we can do is we can do the column stacking. So here, what I'm doing is I'm taking two one-dimensional arrays. So if I write this out, np.column stack, and inside of it, it will again take two parameters, which is A and B. What will happen with this case is you will be able to make them column wise. So what it has done is 0, 1, 2, 3 was my first. If I show you my array A is 0, 1, 2, 3, my array B is 4, 5, 6, and 7. So what is taking? It is making them column wise. Okay. So 0, 1, 2, 3 now has become column. 4, 5, 6, 7 has now become in the format of column. So this is the thing that it has done in the background. Okay. Now we have something called at split. So what this basically means is we are doing the splitting of whatever array we have made. Okay. So if I just mute it out. So what we have done is, you understand, first I have taken numpy array, which has value from 0 to 15. Okay. This is one dimensional array from 0 to 15. What we are doing is we are doing the reshaping of it. Okay. So when I reshape it, this is what it converts into. Okay, so this will basically convert these values into the format of 4 cross 4. So if I print it out, let me show you. So what it has done, 0 to 15, the one-dimensional array, it has now converted it into two-dimensional array in the format of 4 cross 4. Okay, so this is what it has done. Now what I want to do is I want to do the horizontal split of it. Okay, so what I'm doing is I'm saying take it and make it something like this. So what is happening? It is doing the splitting based on, so you can see that 0, 1, 4, 5, 8, 9, 12, and 13, it has made it into one matrix. And a second, 2, 3, and these values, it has made another matrix. Okay, so what we have done is this X is the value of my array, whatever array I have made. This 2 is basically the how many splits you want to do. If I write 4 here, so it will make me 4 splits of whatever way thought possible. So what it is doing, basically horizontally, it is making 4 splits, and whatever value you give it to, it will make that number of splits. Okay, right. So it has taken these values and it has given you 4 different splits. Okay, no, right. So I hope you were able to understand this. What we have done, just let me go through it again. We have some things to manipulate the arrays. First thing, we have concatenate. Inside of it, we give two values, which is a, b. A, b, what is a and b? We have taken two matrices. Okay, we have n numpy.v stack, h stack, column stack. So these are the things that we have taken. Okay, so you have understood that how and what are the values it is taking and what it is doing to our arrays. Okay, we have taken two arrays. What it is doing to our arrays, we have understood that also. Okay, so I guess it must be clear by now what these things are doing. Okay, so we have some more array shape manipulations that we have. So what I'm doing is just let me. So what I'm doing, I have taken this A, and if I run this, and if I just show you how this A looks like. So what I'm doing is I'm taking two-dimensional array, which is my A. I have made this array to flatten this array. Okay, now this is in the format of two dimension. If I check the dimension of it, it will show me that A dot, and then if I just check the dimension, it is showing me that it is a two-dimensional array. Now, if I want to flatten it, if I want to convert this two-dimensional array to one-dimensional array, this is how we can do it. So what we can do, we can basically use A, which is the name of my array that we have taken, and what I'm doing is A dot travel. So if I use A dot travel, this is one method that is used to flatten out your two-dimensional array into one-dimensional array. So that is the work of. So what we have done is using Ravel method, what we have done, we have converted a two-dimensional array, which is in this format, to one-dimensional array. So this is the work of Ravel. It basically flattens any array into one-dimensional array. Okay, and try out various values for it. What kind of thing it is doing, you will understand it. Okay, so now if you want to do the transpose of any matrix, what transpose basically means, these row values will be converted into column values and column values will be converted into row values. So this is what happens with if you do the transpose of any 2D array. 2D array is what? 2D array is basically a matrix. I've told you that another name for 2D array is matrix. So if you understand, if you know about the concept of transpose in matrix, this is very similar to that. So what we are doing is, this was my first array. This was my original array, which is 1, 2, 3, 4, 5, 6. So this is two-dimensional in the format of two rows. What we can do is, if I transpose it, what will happen is, this will be converted into something like this. So now rows have become columns, and rows are the columns are basically showing the format of rows. 1, 2, 3, 4, 5, 6. Now, if you have converted this into, if you again use Ravel on this transpose also, so this will convert it into 1D format again. So what we have done with the transpose, we were able to convert it into two dimension. Okay, now this is two dimension. Okay, so now here also we have two dimension. If I do the transpose of it, it is also two dimension. If I want to flatten the transposed value also, so this stacking we can do. So what I've done, first I have taken the transpose. When I've got the transpose value, after that I am using Ravel. So even after that, it is able to manipulate this data. This is able to convert my 2D array into basically 1D array. So this is what it is doing. Okay, so this was about one simple concept which is called ravel. Inside, just use dot ravel and you will be able to convert the higher dimension values, higher dimension arrays into one dimensional array. Okay, basically you will be using all the data which is there for you. You will see that data into 2D format itself, so it will convert them into 1D format. Okay, so now the reshaping of the array. Okay, so how we can reshape the array? We have seen that we can convert the shape of the array. How we can convert it? So if I just check the shape of A, so what it is doing is, I'm just checking the shape of it, A. So it is showing me that it consists of 2 rows and 3 columns. So this is what it does. A, so if I just 2 rows and 3 columns. So it is this A. Okay, 2 rows and 3 columns. You can see it here. So this is showing me the shape of it. Okay. Now if I take one another array, which I have basically flattened it. Okay, so now I've taken B, where I'm just flattening A. Okay, so this is one-dimensional array. You can make this a one-dimensional array directly also. So I have one A. I am just converting this into one-dimensional array, and it has now become my B. Okay, so what I can do is, you can see that this one-dimensional array could be converted into two-dimensional array. I can basically reshape it. Okay, so what I'm doing is I'm just writing this B dot reshape. Okay, and inside of it I'm giving some values. Okay, so what I'm saying is convert it into 2 by 3. Okay, just a minute. So what I'm saying is convert this 1D array, which is into the format of this 1D array, it is convert it into 2D array in the format of this, in the shape of this. So can I do 3 comma 2? Let's see. So you can do 3 comma 2 also. Okay. So what these values are basically, so we have 6 elements. So related to 6 element, you can take any shape. I can, if I write 1 comma 6, that also is perfectly possible. Okay, so what I'm doing is, it must be some way calculating to 6. Okay, because we have 6 elements only. Other values, if you take into 8, if I make it something into 8, it will not be able to do it. So if I take 2 comma 4, it will not be able to reshape it, because it is saying to us basically is, I don't have that many elements to reshape it. I have only 6 elements, but what you are doing is you are asking for 8 elements. Okay, so that I cannot do. If you give me that similar number of elements, so that I can do, that I am very fine with. Okay, so this is what you can do. You can convert any matrix you have into any shape. So you just have to use dot reshape. Inside of it, whatever is the dimension, if you give it number of rows, number of columns, you will be able to convert it into it. Okay. So here, if you can see that what I've done, I have just simply taken 6 values and I have just reshaped it. Okay. And if I take from 1 to 10, if I give 2, 3, it is not taking. So what we have is, we have 9 elements here. So 9 elements, for 9 elements, what I can do is 3 cross 3 would be perfectly fine. So that is what I have done. Okay. So these are the something. Okay. So if you are clear with this, if you have any confusion, what we have used is, we have just studied about this dot reshape. What we can do with this dot reshape, we will give some dimension related to how many elements we have. So related to that, it will just convert our complete array, whatever array we have. So it will try to convert it into format of this. Okay, it will convert 2D array also into format of this. So I'll show you that. Okay, so what we have is dimension reshuffling. We can, so in Ravel, what was happening is, it just convert your higher dimension arrays into one dimension array. Okay, this is what it is doing. It is doing the flattening of the array. Okay, it is basically doing the flattening of the array. And what we are getting is, what we had is, when I made this np.array, you can see that we have two-dimensional array basically. So here what I did was, when I run this, you can see that this is how my A looks like. When I check the dimension of A, it is showing me that it is 2. It is basically two-dimensional array. Okay, so I have two-dimensional array, but I wanted to convert it into one-dimensional array. I just want to convert it. I don't want to make another 1D array. For whatever reason, I have just use of 1D array, and I have a 2D array which consists of similar elements. So I can just, what I can do using one simple function is dot ravel function. Whatever we have is, we can convert this 2D array into 1D array. This is what basically ravel does, nothing else. Okay. And what we can do, we can use ravel on the top of this transpose also. So what we have done, we have 2D array here, we have 2D array here also. After doing the transpose, we have 2D array basically. So 3 rows and 2 columns, 2D array we have. When we use ravel on it, it will just flatten it out. It will convert them into 1D array. Okay. Reshaping also we understood. What reshaping does, if we have any shape of data and I want to convert it into another shape, so that you can do. Okay. And this is one quick way. If you have basically, if you are making this np.arrange, if you are making 1D array, what you can do, you can just simply use this dot reshape and you can quickly make any 2D array using whatever dimension you have in mind. Okay, you don't need to make a bigger matrix for that, all the elements. You can just quickly make this 1D array, and by using dot reshape, you can convert it into whatever values you have, whatever dimension you want it to. So this was about dot reshape. Now we can do the reshuffling of the dimension. Let me show you how. This is very similar to this concept. So reshape we have understood about. This reshuffling we could do. So what I'm doing is I'm taking this numpy array we have. It consists of values from 0 to 23. As you can see, starting from 0, we have values to 23. What I can do is, if this is my, if I check A here, so if I just mute this out and
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
so here you can see that it is just one dimensional array containing values from 0 to 23. Okay, so now on this, what I can do is I can use my reshape, and inside of it, I'll be giving some dimensions 4, 3, and 2. So what it will do is it will just start to make this A, it will start to make that A into something like this in this format. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what I can do is, so this you can understand, this is basically in some multiple of 24. Okay. So what you can see is what we are doing. You can think of it as this also. 4 cross 3 cross 2, it becomes 24. So in this manner only we are doing this thing. And or for the simplicity, let it be 24 only. What else we can do? So I can just write 3 also here. Sorry, 3 here, 4 here, and 2. What it will do, this also now calculates to 24. So it will be able to do this in here also. So if I just print this out, you can see that now what we have is the first one, whatever is the first value, here we are using 3 values. Till this point, what we have done was we were using 2 values inside of reshape. So what it will do, it will take these values for the number of rows and number of columns. Okay. Now when we are using 3 values in reshape, so the first value now becomes something else. So what is the first value? How many matrix you want to take? So out of it, how many matrix you want to take, basically that you are writing. So I want 3 matrices, basically 3 2D arrays, which has dimension of this 4 cross 2. Okay, 4 rows and 2 columns I have. This is what I'm writing. And if I change it to 4, 3, and 2, this is what I'm saying. Give me 4 matrices whose dimension should be 3 cross 2. 3 number of rows, 2 number of columns it should have. This is what it is doing in the background. So this is what the dimension reshuffling means. You can change the dimension, whatever you have in mind. It should be in the multiple of how many elements you have. and you will be perfectly able to change the dimension of your arrays, right? So this is what it is. You can simply take some values from it also. If you just go on to this, my 0th first value, what I'm writing, 0 is my this metric I'm talking about. This is my 0th, first, second, and third. So this 0th, inside of 0th, what I'm saying is go to the second row and first column, and whatever is the value at the second row and first column, this 5, you can see that this 5 is my value at this place. So you can take this also, you can do the indexing also. Okay. Now resizing, if you want to resize something, this resize also works in similar manner, just little bit of differences, little bit of places it will be taking. In some scenarios, reshape will be used. In some scenarios, resizing will be used. Okay. So there is just some differences of what parameters it is taking. Okay. So what we have basically made one NumPy array. Inside of it, what I'm doing is first value, what I'm giving is the name of my array in which all the elements are there. And in this, what I'm saying is the second value is my 4 comma 3 I can give, or if I give 3 comma 4 also, this will be able to resize it into that manner. So this is how these resize works basically. Okay. So in some scenarios, I will explain that also. Don't worry about it. But if you are able to understand it here, then forward also you will be able to understand. What we are taking some values and we are just resizing it into here in this manner. And this is how it is taking the parameters basically. This is in the manner of that. Okay. Now this is about resizing. Can we do the sorting of values in NumPy array? How we can do the sorting of values? If we have made any array, we want to do the sorting of it. How resize is different on it just depends upon the scenario. Okay. So scenario I'll explain later on. If I explain it to you now, you will not understand basically. That will be quite complex for you. Okay, but I am saying that I will explain it to you. Don't worry about that. It just depends upon what scenario is there, what kind of data is there. Based on that only, you will be using this resize or reshape. You understood that what it is doing, it is just doing something very similar, but there are some differences. You can read the documentation of it, but in that much detail, you don't have to go at this point. Okay. Yes. Okay. So now how you can do the sorting of the values in a NumPy array. So in NumPy array, if we want to do the sorting of it, what we can do is what I'm doing this first. So let me take this out. What I'm doing is first I have made my NumPy array. This is already we are familiar with. Just a minute. So here, okay, np.sort. np.sort. This is the name of the method that is there. First thing, it will take whatever you have given, and then it will taking. So okay. And if you can use print also, if you are familiar with this. So this is what it is doing. It is doing basically the sorting of it. Axis is equal to 1. So let me show you what axis is equal to 1 basically means is. So first row is this. First row is this my 1 value. This is my second row. So row wise, it will be doing the sorting of the values. So you can see that 1, 4, 3, and 2 here. So this has done the sorting of this first one, which is this row here. And after that, it has gone to the second row, which is my this one, and it has done the sorting in that manner itself. Now, if I just give it axis is equal to 0, this is what it does. It does basically column wise. Okay. So in column wise, you can see that first we have 1 and 2. Second, we have 4 and 1. Okay. So here you can see that in first row, we have had 4 here. It should be 4 here. But what it has done after sorting, it has changed the values. It has basically swapped the values in that manner that first the minimum element should be showing, and this the higher element, whatever is there, it must be showing after that. So this you see that what we have done is if I write 8 here basically, and okay, so I should keep here 6, and here let me keep it okay, yeah, 6 will be. So you can see that on the first row, on the first of the matrix, first row that we have, first array that we have 1, 1, 4, and 4, 1, 4, 3, and 6. Now, what it has done after the sorting, it has made the change. Okay, it has basically made the change in both of these arrays. So, axis is equal to 1, it will be making change column wise. It is just basically doing sorting column wise. And whichever column for every single value it is checking in that column. So, from 6 and 4, whichever number is there, which is minimum, which is short, it is taking and putting it into the first array. So this is what happening with the sorting. Okay. So now what we have done, we have basically assigned this sorting into our new variable itself. So this is now new matrix we have got, which has all the sorted values. Okay. So this all the sorted values we have now. Okay. So this was about sorting. There is nothing complex about it. np.sort you have to write. It will, first parameter, it will take the name of the array. Second parameter, you have to give either axis is equal to 0 or axis is equal to 1. These two values only it has to give. Can you put axis is equal to 1 now? Yes, if I just do this once again. So it has taken 1, 3, 4, and 6. Yeah, axis 1, it has done, yeah, 1, 4, 3, and 6. So when you do that, it is not like permanent. What we have done is, when it was happening, you can see that it is doing this sorting here. But when you change it to axis is equal to 1, the values which was there inside of numpy array, that remains intact. Okay. So if you need to sort that for permanent, you run this 2 times. Okay. So you can make another basically variable inside of it. What you can do is, you can do that. And here again, you can make axis is equal to 0. So this way you will get 2 different arrays if you want in that manner, but permanent change is not happening. Whenever you use axis is equal to 1, it will again take this array and it will start to show you that value. Okay, so that you have understood. This is what is happening. So this was the concept of sorting. What we do is we just use np.sort. Sort is the method inside of numpy. What is the parameter is taking? First value is the name of my array. Second value is the axis. What it could be 0, it could be 1. Okay, this is what I am taking. Okay, so the sorting of values also we have done. Let's see, there is some concept of shape mismatch. Okay, so we have seen that if we have two arrays, we can basically add them together very simply by just using plus symbol. We can add two arrays that we have seen. But what will happen if we don't have similar number of elements in both of the arrays? So to add anything, to add both the arrays, whatever array we have, we can have 1D array, 2D array. If you take any array, and if you want to do the addition of them, the number of elements should be always same. Okay. If you are taking two arrays in them, if one has 4 elements, the second one also should have 4 elements only. Okay. It could not have 3 elements, 5 elements. It cannot have that. So this is what it is showing me, that when I ran this thing, it showed me that this operands could not be broadcast together with shape 4 and 2. So there is mismatching in the shape of it. So this could not happen. This operation is basically not possible to happen. Okay. Because what is happening, this computer memory does not know what values is there after this. It does not know that it cannot put 0, 0 also. After this 1 and 2, it cannot just simply go and put 0 and 0, and it can do the multiplication of it. Because you know that memory is empty. If you don't give any value, it does not have any value at that place. Whatever value you give, that will be written at that time itself. So this is what the array is showing. Now, what is the concept related to that? What is the concept behind that? In many cases, you will see that you are not giving perfect dimensions. Okay, and what perfect dimension I am talking about? Then only, then also what is happening is, if you don't give perfect dimension of matrices, also that in that case also some operation will happen. So how that dimension basically looks like? So let me show you that. So you have understood that this shape mismatch happens if you don't have similar number of elements in both the array. After that, there is something called broadcasting, which is very, very crucial concept. This will tell you that what is happening in the background. So basically what this happen is, it is taking two arrays. Okay, what you're giving is, this is my one 2D array, this is my second 2D array. Okay, so when you have given complete full matrices, full arrays, what it will do, it will just do the addition of it element wise. Okay, element wise, it is doing 0 0 0, 10 plus 0 1, 10 plus 1, 11, 10 plus 2. So element wise, the addition has happened. So this is the normal case. If we have given the complete dimension, if we have given all the elements, so you can now understand that what is happening. It is what obviously what you would see, what you would think of. But there is something magical happens, something very powerful happens. For the efficiency of all the calculation, there is some concept which is called broadcasting. This is what happens in the case of broadcasting. Okay, so now suppose the first matrix that you have made, this is in the format of 4 cross 3. This is a 2D array. You have given these values. Okay, so this is basically a 2D array which consists of 3 rows and 4 rows and 3 columns. Now, the second array that you have given, it is in the format of this. Okay, this only consists of these 3 values, and what you are doing is you are doing you are doing the calculation of all of these values. So now you can see that it should give an array mismatch. Okay, because you don't know whatever value is there below it. It does not know for all other values what value it should take. By default, it is not going to take 0, it is not going to take 1. It does not know anything. It is just a memory. Whatever you tell it to do, it will do that. But in NumPy, something very important has been written. It is there working in the background. What happens in this case? So 4 cross 3, this dimension is there, and we have these values. Okay, this is one dimension where array. If we add these two basically arrays, what will happen is this will take all the values 0, 1, 2. Here you can see that in this transparent manner, this is what it is doing. It is basically now repeating or just copying paste this how many times? This should match the dimension of it. Okay, so this many times it will be repeated 0, 1, 2, 0, 1, 2, 0, 1, 2. This is happening in the background. You will not get to see it. This is how the memory is working with NumPy. In this case, now what will happen? Now if you do the addition of it, basically, this will work very similar to that. Okay, so what is happening? These elements have been added in a ghost manner. And what elements it has taken? It has just replicated these values 3 more times. Okay, so now it has become into one big original dimension it should have been. Okay, so this is what happening in the background. Now, if you take two arrays in this condition, this is one 2D array, this is one 1D array. Now, what you're doing is you are basically doing something. You are doing calculation of it. In this case, what will happen? So in this case, it will try to make both of these arrays into some format that both could be just coming onto one single type. Okay, so in this, what it could do? So we have 4 rows. So what it could do is it could convert it into 4 cross 3. So here also what it can do, it can convert it into 4 cross 3. Okay, so this is what it can do. This is what it does in the background. So now both of these arrays are now complete. Even after having partial values, it has now added some values in the ghost manner. And after this, the calculation when happened, this looks something like this. Okay. So to show you that is it really working in the background, to show you this concept, let's just see some code and don't focus much on this. I'm just showing you that something like this is happening. Okay. So what I'm doing is I'm just taking one array. Don't worry about it. I'm just taking one array, which is in the manner of this. Okay. Which is basically in the manner of this. And I want to convert them into this manner. This is what I want to convert it into. So what I'm just doing is I'm using one np.tile function. Okay, you don't need to worry about it now because it is not much used. It is just used. I'm just using it for this functionality. So basically what I'm doing is I'm taking one NumPy array, which will be one dimensional array, which is this. And in np.tile, there is one functionality. I can just replicate it in the same manner that whatever is happening in the background, this replication, I can just simply do that replication. So what I'm doing is I have taken one dimensional array. When I replicate it, what it will give me is, what I'm saying, this is the second value it is taking. So what is the second value? I want to say that replicate 3 times in the row. In the rows, it should give me 3 times, and in the column, it should give me 1 times. Okay. So let me show you what if I just write it 2 here. So you can see that our 1D array, which was consisting of 0, 10, 20, 30. If I'm writing 2, it is now repeating 2 times. If I write 3 here, it is repeating 3 times. Okay, so this I have done. So what is the second value? How many times it should repeat column wise? So if I show you, this complete array is my one array. So if I give you here 2, what it is doing is it is now taking this complete and make it into another. So this is what it is doing column wise. Okay. So this is one functionality that is there on np.tile method. Okay. You don't need to confuse it with other methods. This is just for your explanation that what I'm doing, what are the things happening, to just show you that if this thing is working in the background or not. Okay, so what I've done, I've taken this np.tile, I have made something like this using these operations. So using this operation, I have made something like this. Now I can simply transpose it. If I transpose it, what will happen is it will convert it into this manner. So when it is converted into this manner, we have got what we wanted. So this you can see that it is perfectly in this dimension 0, 10, 10, 20, 30. This is now in that dimension 0, 10, 20, and 30. Okay. Now we have to take our second element, second value, whatever we have to take. Okay. So this we are not talking about because this was already perfect. This second example we are talking about. So what we have done is we have made our first array. This second array I'm taking. Okay, this is now my 1D array, and this is how I'm making this 0, 1, 2. You can see that it is 0, 1, 2. Now let's see how we can make it. So you now know that you can simply make this 1D array 0, 1, 2. These elements are here, and this is how it looks like. Now when we do the addition of it, you can see that this is the value we are going to get, and it looks very similar to what we have already seen: 0, 1, 2, 10, 11, 12, 20, 21, 22, 30, 31, 32. And let me show you. If you see that 0, 1, 2, 10, 11, 12, 20, 21. So this is actually happening in the background. Okay, and this we have proved. Now let's see for the second case, if it is working for the second case also. Let me show you. So for the second example also, what I'm doing, I'm making 1D array. So here, my dimension is basically one dimension. Okay, this array, is my array A. This at this point is my 1D array. So if I check this dimension, so this is my n dot, sorry, A dot, A dot. Okay, so this is showing me that it is one dimension. What you can see in this diagram is that it is 2 dimension basically. It consists of 4 rows, and it is not actually taking it into one dimension. One dimension, if we talk about, this should look like this. This is the second case, 0, 1, 2. One dimension always looks like this. Okay, so we have something, if we have an array in this manner, this is basically at least 2D. Okay, so it consists of 4 rows and 1 column. Okay, so 4 rows, 1 column we have. Here, if you see that it is showing me that only 4 values are there, it is not showing any 1 column and something like that. So we have to do something about it because our data is not in that format. Our array is not in the format that we wanted to be it into. Okay, so for that purpose, we have something, we have one way we can convert, or in whatever array we have, we can just add one dimension to it. Okay, so this is my 1D array. You can see that this is my 1D array. We have checked its dimension. So using something like this, so what I'm doing is basically, what I'm telling it to do is basically this. So A is equal to A. Take my complete array. Inside of that, take all the rows. Okay, basically take all the rows. And in the column, make one new column which should not have any values. I don't want any values. I just want to convert it into a manner where it shows me that it is 2D array. Okay, it must show me that it is basically 2D array. So after this, what will happen is if I just run this thing, it has now become into the format of 4 comma 1, and this is what we wanted to do. No, I'm using this style method on this. So this is one way. So using T, it will not make it into a manner. Okay. So this manner I want to show you. In this manner, it will not make it into this manner. Okay. So for this purpose only, and that transpose thing is different. I'm just explaining you whether this thing is happening. Okay. So for now, don't worry, don't stress on it much, because this will not be used not many times. For this, just one single concept, I'm explaining it to you. Okay. So what is happening? We are taking one array. We have added one dimension to it. Now, when I check the shape of it, let me show you. If I check the shape of it and then, so here what we have is we have 2. Okay. So the shape of my array has become 2 without adding any element. And if I check how my A looks like, so this is how my A looks like here. And here, if I check my A, after printing this A, let me show you. So here it looks like this. This is my 1D array. Now what I have done, I have changed its dimension. I have made it into 4 cross 1. That is what we wanted. That is the dimension that we wanted to do. Okay. So when I have changed its axis, this has become something like this. Now we can perform whatever operation we wanted to perform. So this A, my new A is something like this that we have seen. And what is my B? What B we have taken? We have taken B, which is 0, 1, 2. So now you can see that B is 0, 1, 2. A is my 0, 10, 20, and 30. So this is my two values, which looks similar to this. This is my A, this is my B. What will happen in the background? This will happen in the background, and we will perform this calculation, and this will be the result that we are going to get after this. Okay, so what we have done. So if I just run A plus B, okay, so we have B, A we have here. Yes, so you can see that we have taken our A and B. What has happened? It has done the calculation. It has basically added some ghost values at those places. Okay, so this np.new axis, you don't need to worry about it now. It is not going to be used much. This is just one concept that I wanted to explain you regarding this, that this is what happens if you don't have same kind of dimensions in two arrays. If you're taking two arrays, if the dimensions are not same, this is what it does, yeah, to convert them basically into this real two matrices. Okay, so this is what, this is the concept of broadcasting. Okay, so I hope that you are able to understand this. Just leave this part, I'll explain them later if I need to, but for now you don't need to know, you don't need to focus on this basic. This is one additional concept you will not use very frequently. Apart from that, if you not understood the concept, tell me about that. So what we have done, we have taken one array, okay, which is my 2D array. To convert it into my desired format, I have just made it a transpose of it. The second value, what I have done, I have taken my 1D array. I have done the addition of it, and we can confirm that this addition, this ghost values addition is adding, this happening in the background. And this is the concept of broadcasting. The second value was this. This we have taken our 4 values we have taken, and we have added that 4 values here also. Then we have got something like this. This was my first array, this was B was my second array, and this is what it has done in the background. Okay, so this was all the concept which was related to NumPy, and these are the basic computations, these are the basic methods that we have inside of NumPy if we want to do the calculation. So I hope you have understood what operations are happening with NumPy. If you have any confusion regarding that, I'll just show you from the start that what we have done. We have taken some data. We have understood this concept also. If you have any confusion regarding this, also you can tell me. Then we understood the concept of concatenate, vstack, hstack, column stack, and split. These are the concepts that we have seen. Inside of it, we ran through these queries, and what parameters, what values it is taking, we understood that. After that, What we have, flattening of the arrays, we have seen. If we have two-dimensional array, if you want to convert it into 1D, this is how we do it. We have understood the Revel also. After that, we saw the concept of reshaping and what we can do with reshaping. That also we have seen. We just have to give some dimension that must be related to the number of elements we have inside of our 1D array, or whatever array we are taking. The dimension should be shaped if you are doing the reshaping. This also we had understood. We understood how we can do the reshuffling of the dimension. This dimension you can change whatever dimension you want to pick, that you can change. We saw that also. We saw the concept of resizing, what resizing, what parameters it is. We have seen that if you want to sort the values in any NumPy array, how we can do that also. We saw the concept of shape mismatch. This is what happens if you don't have two arrays of same elements, same dimension. If you don't have that things, this is the concept of shape mismatch. And related to that, we have something called broadcasting. This is what it does in the background. If you have given some other dimensions, this is what it does. So I just basically proved this thing using these concepts.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So Pandas, being like obviously the most popular, as I said. So Pandas is composed of two words, P-A-N-D-A-S. It is composed of two words, this and this. This one stands for panel. This one stands for data. So basically, Pandas, but the name itself is trying to say that it is used for panel data, and panel data is nothing but a data which is like a two-dimensional or three-dimensional data, which can be represented like this. A simple two-dimensional data, forget about three-dimensional for now. Simple two-dimensional data having some columns and having some rows is an example of your two-dimensional data. Like the example we are talking, whether we should give a loan to a employee, to a potential candidate or not. The way we are representing our data in the Excel sheet, that is an example of two-dimensional data. All right, so that can be easily consumed by Pandas, hence it becomes very popular. Then obviously the same advantage here also that we have in NumPy also, that we have a lot of what we call predefined functions, Pandas also, which you can directly call. To clean messy data and analyze and manipulate according to your need, Pandas is very good. Basically, this is the same advantage, or this is the same objective of any data manipulation tool, and Pandas also have the capability that you can gather a lot of data from different sources, combine them, join them, remove the few part of that, do some cleaning, handling missing values, all those things which you talked about in NumPy, everything is doable in Pandas also directly, and even more. Panda is an open source. Again, it's same as NumPy. I like NumPy was an open source, free to look at code part of Python, where a lot of community work is happening, and anybody can go and contribute in it. And see, as the name derived here also it is, Pandas is derived from the word panel data, and this is how a typically panel data looks like. Here in this case, we have something with time. So time is one of the features. Then you have person ID, income, age, and sex, and such kind of data, like a tabular data, is what you can call it as panel data. And Pandas is pretty much comfortable in handling it. So if you look at it, so this guy Wes McKinney, he created Pandas in 2015. Now just imagine, it's hardly 6 years, right? So it just shows that Pandas is such a new thing still, and it has a lot of dependency now. It just shows you how much how dynamic is Python is, how highly scalable it is, how fast it is moving, and because of the awesome what you call community support, it has got. I mean, it is continuously evolving. New things are coming, which everybody is more than welcoming them and adopting them as well. So Pandas is a pretty new thing, and hence and still very popular. So for Pandas again, like the way you used to do for NumPy, here also the magic command to import is import Pandas as, and this is an alias. You can give anything you wish like. PD is what everybody in the industry use, small PD. All right, and Pandas is suitable for arbitrary metrics, tabular data, time series data. See, all these are just a variant of your simple two-dimensional, what you call rows and column type of data. You can call it anything, but eventually, if you look at it, these are just your two-dimensional rows and columns in which your data is present, and hence, and if you think about it, right, this is how you will get your data in real world also. Hence, as I keep on saying, that this makes pandas a very interesting thing. One more advantage of pandas is if you remember in an array, let's say this is an array A, and this is 1, 2, 3, 4. If you remember the index part 0, 1, 2, 3, this is how the index used to be in the array world, right? But in pandas, the one of other advantages, rather than having 0, 1, 2, 3, you can have named index. Named index. What I'm trying to say is, here rather than 0, 1, 2, 3, you can, let's say, have apple, mango, orange, banana, right? You can have your data like this as well. So if some, and let's say these are the count that are available in the shop, and somebody asks you how many bananas are available, right? In NumPy, you would have said at index 3 it is 4, hence it is 4, and you need to maintain an index that a dictionary where it says 3 is banana. But in pandas, directly you can call give me the index value of banana, and you will give me the element at index banana, and it will give you 4. Hence it becomes really, really powerful. So pandas has this capability where you can label your indexes as well, not just the numeric by default 0 to n minus 1 numeric labeling. You can give a named labeling as well. Okay, so we were talking about a few of the features of pandas, and here they've highlighted a few of them. So I'll just talk about the major ones. So series object data frame, this is something I'll talk about. I'll show you what does this mean. This basically means the kind of data structure you can use, or pandas can support. So I'll talk about this. I'll show you directly actually. Handling missing value, I think everybody knows now what is missing value. Data alignment, group by. So basically when you have data like this in pandas, right? You have rows and columns. So you have what you call capability to do any function either at row level or either at column level. For example, this is column 1, 2, 3, 4. This is row 1, 2, 3, 4. You can either have like sum of this row, I'm just giving an example, or you can have sum of this column as well. So you can apply all your functions, mathematical, non-mathematical, whatever functions you want to apply at row level or column level also in a pandas. Hence it gives you the group by functionality. All right, and then your indexing, slicing, dicing, joining, merging, reshaping of multiple data frames. We call it data frames over here. And hierarchical labeling of access. So I was talking about the labeling of access. This is what they're saying. And then time series specific data also it can handle. So for time series, there is an what you call a limitation or a requirement that when you provide an input to a time series algorithm, the index should be date. This is a kind of a constraint for any time series algorithm, and hence pandas handle that part pretty well, because as I said, you can have your index or your label as whatever you wish like. So rather than having 0, 1, 2, 3, we can have our date column also as part of our index. So hence pandas is able to do that as well. So these are just few of the features. And if you compare pandas versus numpy, what happens is when you have a lot of records, pandas tends to outperform numpy. And so basically when you have see, if you look at the exact numbers, when you have more than 500k records, pandas perform better than numpy, and perform better than numpy in the sense it is much more faster. All right, and second advantage is it can have labeled access. So these are the two major advantages. So one being faster whenever you have large data, and second is labeled access. These are the two major advantages which basically makes us to use pandas quite a lot rather in comparison to numpy. Advantages of your pandas over numpy. Okay, we'll talk about data structures in pandas, like similar to what we had, like if you remember, you had array in NumPy. Here, three major data structures that are listed in front of you. One is series, second is data frame, and third is what they're calling it as panel data. But again, panel data can be what you call, can be interchanged and used with data frame as well. So typically what they're saying is series is nothing but a one-dimensional array. Data frame is nothing but which is a two-dimensional data, and panel is nothing but a three-dimensional data. But in our case, I mean, what they're doing is in panel data, basically you have the axis as labeled axis. Here, our axis or our this index is 0, 1, 2, 3. That is the only difference. Hence, and otherwise, basically, data frame and panel are exactly the same, if you notice. Also, one of the other thing difference between pandas and numpy is, if you remember, numpy can only hold similar kind of data. It was homogeneous in nature, while in data frame you can have different types of data. For example, let's say our first column is name, second column can be age, third column can be, let's say, salary, right? So this can be a string, this can be an integer, and this can be a float. So all these things can be put into one data frame, let's say data frame one. So this is also a major advantage of pandas over numpy. All right, and so here the thing of most importance to you is data frame, because this is what you'll be using day in day out when you'll be dealing with Python, when you're dealing with data science, and I'll be going deep dive into your data frame part of it. All right, we were talking about data structures within pandas. So first one is like, what is the series object? So series object, as we talked about, is a one-dimensional data. One-dimensional array is similar to your NumPy array you can create over here, but the only difference is you can have your labeled access as well. I'll keep on repeating this part because this is very important. It makes your life much more easier when you're actually working on the code. Now, how do you create a Pandas series? The code is pd.series, okay, and pd is nothing but the way you have imported your pandas. Import pandas as pd, right? And if you do it like this, it creates an empty series object. Now, if you like logically, if you think about, now there are only two things left. One is passing your data, and second is telling what is the index values, so that we can have your labeled access part, right? If you do these two things, then you will have your series ready. Now, see, passing your data. So here if I talk about it, so these are the three major things. One is your in this function we are passing the data. This is the data on which you want to create a series. This is the index you want to put, A, B, C, D, apple, mango, orange, whatever you want to put. And third is your data type also, if you want to mention. Even if you don't mention this, then also it works pretty well. There is, see, all three, none of these are mandatory. If you see in the previous slide, we did not pass anything, and still it was able to create an empty series, panda series, right? So here, whatever you wish, like you pass, and then it will be able to create your panda series accordingly. So we have panda.series. This is the data that we are passing, and this is the index we are passing, right? If you run it like this, you will see, you will have this index over here, and this is the data you will have. So hence you have created a panda series using this function. So function is pd.series. You need to pass your data, you need to pass your index, and that's it. You can, and if you do it and just assign it to a variable a, hence this is your variable a, which will have all these values. Very simple, straightforward. Type, if you look at it, it's a panda score series. That's how they call it. Third parameter was data type. So even this index is also not a mandatory thing. Even if you don't provide index, let's say this is the same. Let me just clear it. Let's say in this same example, I don't provide index, for example. Just remove this code, and when you will run it, what will happen? It will have your data like this, 1, 2, 3, 4, and it will have your index like this by default index. It will still work pretty well. So all these, as we notice also, your data, your index, and your D type, none of them are mandatory. Obviously, if you not pass data, you will not be able to see anything. It will be an empty Panda series, but none of them are mandatory. And there can be other parameters also, but these are the three main parameters. So for other parameters, you can always do a question mark pd.series in your notebook, and you will see the official document, and you can see what all argument it takes. Now, basically, you can convert. In this example, what we were doing, we were actually giving direct values and just creating a Panda series. Rather than that, what you can do is you can always take an array and convert. For example, let's say we are trying to identify sugar content in drinks. Okay, and you have, let's say, four drinks. You have coffee, you have tea, you have cola, and let's say you have juice. Okay, and this is your type of drink, and this is sugar content. Let's say over here it is 40 milligrams. Here, let's say it is 45.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Here, let's say it is 70, and here it is, let's say 30. Okay, now if you represent this information in an array, it would be something like 40, 45, 70, and 30, right? This is your array A with the index 0, 1, 2, 3. Now, if somebody asks you, what is the sugar content of cola? How will you answer that? For that, what you will have to do is you will have to have a key value mapping, where key would be 0, 1, 2, 3, and 0 would mean coffee, 1 would mean tea, 2 would mean cola, and 3 would mean juice. From this information, you would understand, okay, cola is 2, then you will come over here, look at index 2, look at its value 70, and then say 70. But rather than 0, 1, 2, 3, if you know that this is coffee, this is tea, this is cola, and this is juice, what you can simply do, you can simply say in A, give me the index value of cola, and it will simply give you 70. You don't have to worry about having this overhead of maintaining this. You don't have, I mean, the data search process also becomes pretty small. So here, first key value mapping, and then you would have said in the A, give me the value of second index, and then it would have said 70. But the second, you need to get the value of second. That is an overhead for you to maintain. But if you have an index, a labeled index, you can directly call cola and get its value. So dictionary will not be able to hold your SQL database information. Dictionary will not be able to directly load your CSV files, and so on and so forth. There are a number of other challenges with dictionary. All right. So I was talking about here we were trying to see that from our what you call predefined data, how we can create a series. Also, directly if you have an array, a Numpy array that is already created, you can create series from there. So or a dictionary that has already been created. So basically, this shows you there's a very good handshaking capability within your this thing Numpy and Pandas. Here, if you notice this example, here you are just creating an array, Numpy array, and just passing this array variable into pd.series. And if you do this, now this array has become the Panda series type. Similarly, this is a Python dictionary, and if you pass this variable also to a PD series, so this also becomes a Panda series. Your key becomes your index, and your values becomes the data in the series. So directly also you can basically interchange your arrays to series or your dictionary to series. So access can be labeled, and arithmetic operation on rows and columns are possible, right? So this is your data frame, right? So first pointed, these can be of different data types. Second is you can add rows mutable. Third is you can give access, labeling access A, B, C, D, and let's say alpha, beta, gamma, whatever you wish like, right? And fourth is you can have row level or column level arithmetic operations also is possible. And these four features makes data frame a very important tool for any data scientist or any data analyst as such. So basically, then how to create a data frame. So the function name is data frame. See, that's the advantage of Python. Why there are a lot of articles. I think there's an article that I wrote last week itself. It should be live. probably this week somewhere. It will be there on internet, on LinkedIn and everywhere. So basically, what is the actually advantage of why I would suggest people to go and write on learn Python for data science? That the language itself is so intuitive and so simple and so easy to learn. Here, if you want to create a function, the name of the if you want to create a data frame, the name of the function is simply data frame. So pd.data frame and pass your data, and that's it. Apart from data, you can pass your index, you can tell what are the column labels, you can tell data type, and so on and so forth. This list goes on and on. But even if you just pass your data, this much is more than enough to create a data frame in Python. So you need not necessarily remember the code as such. The language is so intuitive that by practicing 1 or 2 times only, you will be able to remember most of it. All right. So I think what is data, what is index, what is columns, and what is data. I think all of you understand. So index is basically labeling kind of your records. Column basically is labeling your columns, and data type is obviously tells you the data type of the object. So we were talking about creating data frames. I think this part is okay. See here also, we are not passing any variable, any parameter. So hence, as I said, all these things, whether index, data type, data, all these things are, none of them are mandatory. Let's go to the code directly and we'll try to see what happens over there. It will make our understanding much more easier. So what I'll do is, first of all, show you one CSV, right? So these are 32 records in the CSV, right? And what from A to M, we have these many columns, right? And like you can have that's how you have your data, right? Either you have in CSVs or you can have in SQL database. For me, right now I'm taking this example of CSV, and here if you notice, one of the column name is missing. That is all right, but rest all is like serial number, this is miles per gallon, and then these are some values as well. So these are details about your car models, and if you see over here, these are nothing but names of models of cars, right? So what we'll do is we will load this in CSV in our Jupyter notebook and then see what all we can do with Pandas. So we'll try to do data manipulation with Pandas. Okay, so just a little bit of detail or history or context of, behind the data set. So basically, it is a motor car trend data set in one of the US magazine. What they did was they took out 32 automobiles, all right, and they tried to compare it using 11 parameters. So one is miles per gallon and 10 other your automobile design parameters, right? And they recorded these information in this magazine, and we are just trying to use this data. So for the context part, you have 32 models of car, you have 11 data points for all of them. One is your mpg, miles per gallon, and 10 other are your automobile design data points. And this was part of your 1970s 1974 what you call magazine where this data was published. All right. So what our objective is? Our objective is to understand the capabilities behind Pandas using this data frame, right? So basically, step one would be importing your Pandas as PD. I think here everybody is okay with this part. Step two is basically reading this CSV. So you'll use this PD and you will use a function called dot read underscore CSV. This is a function, and you will just simply pass the name of your CSV file. And if you run this, you will have your data in your whatever data frame variable that you have created. Here we have created cars, and if I just look at cars, here my cars have the exact information that I was talking about, which I showed you in the CSV. Now, all of you know how to read a CSV in a Jupyter notebook. Data frame from the code. So data frame is cars. Till now, whatever I have discussed, cars is the data frame in this code. Then how to find the path? I think how to find the path, funny, it's very straightforward, but let me show you. You go to the file wherever you want to go, click on properties, and if you see this over here location, you will have the path. In their head are thinking how to basically read an Excel. So just the code becomes like this. And whatever is the name of your Excel, you can give, and this is how you will go and read your Excel. All right. What is PD? PD is the alias that we use to call in pandas. So if you remember how we use import pandas as PD. So this is the PD. So you're going to use PD to represent pandas in your code. All right. So once you have loaded our data, now the next part is analyzing your data. All right. First of all, we'll just quickly checking what is the type of the cars that we have created, the variable, and if you see, it says Pandas core data frame. So basically, it confirms that we have created a data frame. Now, what happens in real-time scenario is usually the size of these data frames are pretty huge, right? Here in this case, it was just 31 records or 32 records, so you could see by the naked eye, just scroll it. In real time, it's not possible to do that. So what you typically do is you should be able to look at the sample set of it in order to understand what kind of data you're dealing with. So one such way of doing is called a function called head. So basically, head, what it does is, if I don't give anything and simply call a head, head will give you the first 5 records of your data frame. All right, it will give you first 5 records of your data frame. Now, if you want to customize it, if you want to see first 10, probably you can give 10 in this call value. If I want to, let's say, look at only first 2 records, I can give 2 and it will give me my first 2 records of it. So basically, this it will help you to have a quick sample glimpse of your entire data so that you know what kind of columns you're dealing with, what kind of values you're dealing with. So you can start building your next line of code accordingly. All right, then that dot shape, this is same as NumPy. Here you also dot shape works and it will give you basically the number of rows and columns of the data. So we have 32 rows and 13 columns. 32 rows because we have 32 models, and 13 columns because we have a serial number, model name. These are the 2 columns, rest all 11. If you remember, we have numeric columns in which one is MPG, miles per gallon, and rest 10 are your automobile design features. So hence we have 32 and 13 columns. All right. Now, can you tell me any issues that you see in this data? This is your entire 32 records that you see in front of it. So this is one issue. Issue 2. All right. What else? Yeah. Okay. Wherever is nan, that is an issue. We need to fix nan. This is issue 1 only. All right. These 2 things that you could find out. Now, because we are able to look, because the data sample is, I mean, the data set is small, so you could navigate and you can look at where we have nans as in missing values also. But how can you do it programmatically and you don't want to write, look at it entire way? Here, there's a function called .info, basically data frame.info, and I'm just saying null counts, that's true. So basically what it is doing is it is giving me the name of each of the columns, the number of non-null values it has, and also the data type. So here, if you see for QSEC, I have 29 non-null values. That means I have 3 missing values over here. And these are the 3 nans that you guys were showing in the earlier example, right? See, data manipulation analysis is part of, right? If one of the column is going till 3 decimal and other is going for 1 decimal, so that's just the nature of the data it is. Okay. So apart from missing value, any other issue? Yeah, this and this. Anything else? This thing. Miles per gallon should not be object. Miles per gallon should be int or float. See, in this output, you have only 3 columns to look at. So we should be analyzing all 3. So obviously, then only you should be, then only you'll be able to make some sense out of it. And so one is the missing values. Okay, we identified. Second is this naming issue. Third is this column data type. I mean, data type for MPG is not correct. And probably what I can also say is serial number is not required. If you look at it, we already have index with us, right? Serial number is just starting from 1, index is starting from 0 to n minus 1. Do you think serial number is of any value? In any case, is there any information serial number is giving you, or anywhere serial number can help you in any kind of analysis? So apart from this, it will tell you how many number of float columns, how many number of integer columns, how many number of objects, and so on and so forth. This is the kind of information you will get for info. All right, so I think we have identified 4 issues. I'll just quickly highlight them, summarize them so that all of you are on the same page. 1, probably drop serial number. And in case you have any counter, you are not convinced, please do let me know. All right, okay, fixed column name. Third is missing value handle, and 4th is fixed data type of MPG. All right. So once you have all these things done, let's say you want to look at the mean value. So now the beauty of pandas is I'm just giving the name of the data frames and giving the function dot mean and see what it is doing. It is smart enough to understand what all are your numeric columns, and it is giving you mean value of all of them done at a column level. So see, it can see that unnamed one mpgr2 object type. So it is not doing anything on it, and for rest of it is showing you the mean value. So you don't have to write mean, or you don't have to calculate mean for each of them separately, or you don't have to write the formula of mean like sum of all the numbers divided by the number of numbers. Just simply write data frame dot mean and you will get the mean of all the numeric columns in your data frame. It saves you a lot of time. Now apart from mean, you can write median, min, max, whatever you wish. Like all these functions are already developed and ready for you to consume. Like let's say I'll write cars dot median, right? It will give you a median value for all of these numeric. It is smart enough to even identify these are non-numeric columns. You don't have to worry about that. Isn't this really cool? Isn't this saves you a lot of time? And this actually shows you the power of Pandas, that when you're dealing with huge amount of data set, this can save you a lot of time while computing and also while writing code.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
You can give .std for standard deviation. You can give max. You can give min. You can give count. It will give you basically all the non-null counts in it. And here also it is showing that qsec is 29. That means there are some missing values in this column. So basically all the descriptive statistics you can get just by simply data frame dot the name of the function. Clear? All right. So all these things that you have done, if you don't want to run at what do you call at an individual level like min max separately, what you can do, there is another function called describe. Simply give the name of the data frame and write dot describe, and what it will do, it will calculate all these things together. So count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and max. So using this, you will get all these information for all the numeric columns that you have in your data frame. In one nice grid, you can see all this information done together. See, this actually shows you as I said, the power of pandas. Just one line of code, not even one line of code, just one word of code, you're able to calculate so many statistical points together, right? And if these are like 10 columns, let's say these were like 100 columns, pandas don't care. It would have still calculated it with just one word of code in fraction of a second, right? Okay, one thing everybody knows, right? What is this 25 percentile? What is 25 percentile? What is 50th percentile? And what is 75 percentile? So basically, what is 25 percentile of the data, 50th percentile, median? Okay, if this is my data, median is 11, right? So if I am saying this is my median, so median is nothing but P50. Or in other words, it is a 50th percentile value. That means, as you were trying to say also, that 50% of your data lies below it. That means this is my 50% of data that lies below it, right? So median is also called P50 or 50th percentile. Now the other two that are left is 25 percentile and 75 percentile. If I look at just this data, okay, what is my median in this? 5, right? I'm just trying to show you a very layman way of solving this. So this 5 is nothing but my P25 or my 25th percentile data. Similarly, in the lower half, 21 would be my this thing, P75 or my 75th percentile of the data, right? So this is how you can understand your P25, P50s, and P75. This is also called Q1, quartile 1. This is also called Q2, quartile 2. This is also called Q3, quartile 3. So P25, P50, P75, Q1, Q2, Q3, Q2, P50, and median is same. I mean, all these concepts should be really clear in your head now. Intuitively, this means this much percentile of data lies below it. Obviously, when they're in a sorted order. So here with just one word of code that is not described, you are able to generate all the descriptive statistics in your data set. All right, and then if you don't want to do it for all the columns, you want to do it for a specific column, you can basically do give the name of the column as well. And so let's say I'll give you I'll try to give you a real world, I mean try to relate as an example. So what happens is, let's say you know your P75 is 21. Okay, let's say these are age for some of any analysis you're doing, and somebody tells you that there is a person who is coming who is 22 years of age, and you only know P25, P50, P75, and mean. You only know these high level of data. You do not have the actual data points. So with this information, I know that this is greater than this. So I know at least this person, there are 75% of my data or of my children's in this case are below 21 years than him. So this new person will be in my fourth quadrant. Just by only having this basic information, not having the visibility of the entire data set, I am able to make a comment that this person will be on my fourth quadrant, or he'll be at higher end of the age in this data set. So that's how you typically do it. See, as I said, in real world data, there will be millions and billions of records. You will not be able to navigate at all the records, look at them. So you will have to do analysis based on your descriptive statistics. So P25, P75, P50, P75, this is the most common way of deciding or understanding a data. If I don't know whether you guys have worked on any database, data related work, but if you go on any analytics company, or if you work on any analytics team, that's how everybody will talk about P25, P50, P75 with and plus the mean, and as well as standard deviation. So these are your 4 to 5 major what you call backbones, in which just if you give these numbers, a data scientist or any mathematician should be able to have a vague picture of the data in his mind. So these are very strong concepts, very easy but very strong concepts. These are actually a foundational concepts of any statistics study. All right, we were doing it for entire data frame. You can even give any name of the particular what you call column if you want to do it. All right. So after our analysis is done, we have figured out that these are 4 to 5 major things that we need to fix. So let's say in the cleaning phase, let's go and try fixing them. First one, as all of you mentioned out, that the column name is not correct. So we have a function called rename. So basically data frame dot rename, and in the this is the syntax columns, and I want to change unnamed one to model. If you run this, what it will do is it will change the this column name to model now, which is a much more intuitive, much more logical name of this column here, right? Cars.rename. With this, we are able to solve the first part, right? So the function is as I said, Python is so simple. The function name is very easy. The function name is .rename. All right.
So as we were talking about, so yesterday I remember we were discussing what all possible ways we can basically impute for the missing values in the QSEC column, and a few of us suggested that median is a good way of doing it. So here conceptually that's the correct way, and then how to implement it in Pandas or in Python or Pandas is like, basically this is the name of a data frame, this is the column that you want to fill, and the function is fill NA. So what it does is basically it will go and fill wherever the NA is. NA means not applicable, NA means nans, wherever it is empty location, and fill with what? In bracket, whatever you will pass, it will fill it with this. So we are saying fill with the median value of this column. So that's how you basically write this code for this column. Just fill everything with the median of this value. And if you do that, you will have, all of your missing values will go, and all the missing values will be replaced by the median of that column. All right. So if you see now, just on the cursory look as well, in QSEC column, there is no nans now. So I remember Valiant was one of the car model that was having missing value. So see, it is 17.42. Then Fiat 128 was again a missing value. Now it is again 17.42, right? So we discussed yesterday, rather than replacing it with a default value, let's say 0 or something else, this 17.42 makes a lot of sense, because this is somewhat similar to what the other cards are. So If I'm comparing Fiat with 128 versus Honda Civic, probably this makes sense that Fiat might be at 17 and Honda might be at 18. So they are quite close to each other. So we cannot take a call, obviously, in these two metrics, but we have other metrics also to evaluate which one is a better model or how they perform, so on and so forth, whatever the analysis we are doing. So with this, we have kind of fixed the second part. Now the third part is dropping the serial number column. Here the function itself is pretty simple. Like I've said multiple times in Python, the function name is simply drop, cars.drop, your data frame name dot drop, and in just simply in the columns, give the list of all the column names you want to drop. Here in this case, I just want serial number. Let's say I wanted to drop model also. So I would have written like this. And if I run this code, it will drop serial number and model both. But I don't want to drop model. So I'll just run it like this. And when I run it, I see now after this thing, running this code, the serial number column no longer exists. Right? Simple, straightforward thing. If you notice, I mean, you don't have to even remember the code also. It is so simple. I'll come to this part, correlation analysis. So here, this is how you change it. So there's a function called as type. So in as type, in bracket, whatever the data type you will give, it will change it accordingly. So if I run this, so what it will do is it will change. Now here I'm just doing a cars info function again to see whether it has to look at the details. Now what it has done, now the miles per gallon has been changed to float, right? Which we were expecting or which we wanted. Then if you look at the QSEC also, it has 32 non-nulls now. Earlier it was 29. That means missing value we have also fixed. Then we do not see serial number over here. So that is also fixed. Serial number, missing values. So after doing this, all four of our issues have been fixed over here. Correct? Kind of just getting a confirmation. Now, once that is done, what you can do is something called correlation analysis. Now, correlation analysis is basically as part of, because we are in our analysis / cleansing phase. So correlation analysis tells you how much is one factor dependent upon the other, in the sense whether, let's say there are two factors, X and Y. If X increases, Y will increase or decrease, right? This indication or this strength or this relationship is what correlation analysis gives us. For example, let's say if I take another example, salary versus age. Most likely when your age increases in an organization, and I'm just talking about, let's say one organization, let's say I am plotting data for Amazon, all the employees in Amazon. Probably if the age increases, the salary also increases, right? Something like this. So a person who is 25 years old versus a person who is 35 years old, probably he is earning $100. So probably he might be earning $120, right? This kind of relationship, if you can determine, this is called correlation analysis. All right. This is very important in order to understand what kind of pattern and trends your data might have. So if you remember, I talked about before passing our model to our machine learning models, before passing our data, we need to do the data manipulation part as well as the trend pattern data visualization part. So this is coming from there only, is the statistical way of doing understanding the trends and pattern rather than visualizing them. So correlation analysis gives you something called correlation coefficient, and it will tell you basically it goes from -1 to +1. Okay, so -1 means highly correlated in negative direction, inversely proportional. +1 means highly correlated in positive direction. And then there's a 0 means they are not correlated with each other. And how to do it in Python, just simply use a function .corr and it will give you correlation matrix. Okay, so how to read this matrix is, let's say DRAT and let's say I'm saying HP. So if I go over here, so this is the correlation value between them, HP column and DRAT column. Now, as I'm saying, let's say X and Y are highly correlated. Okay, given this is what you are seeing in your data. For example, let's say DISP and CYL. See, this one is 0.9, so it is highly correlated. Correct? Okay, now let me give you an example. Let's say I am at a beach. All right. I am recording number of ice cream sold. And then I'm recording number of shark attacks. Let me write it properly. All right. Ice cream sold and shark attacks. And this is day, let's say. So Tuesday, Wednesday, Thursday. I'm just measuring for these 3 days. Ice cream sold were like, let's say 200, and number of shark attacks were 5. Then ice cream sold was 100, number of shark attacks were 3. Then ice cream sold on Thursday was 400 and number of shark attacks was 7. If you do a correlation analysis on this data, it will be highly correlated. If you see whenever ice cream sold is increasing, shark attack is also increasing. When ice cream sold is decreasing, shark attack is also decreasing. So that's how you basically read a correlation matrix, right? The function to implement it .curr. Now with this, we kind of did our analysis part, and now we'll move to our next part in the pandas discussion, which is manipulation. All right. Okay, before coming to manipulation, I have one more concept to discuss. So there's a concept of merge join, SQL joins, right? This slide. Let's say you want to predict salary. All right. In one of the CSV, you have your employees with their age. In another CSV, you have employees and their education qualification, right? Then in another CSV, you have your employees and their current salary. How will you work on it? You need to put everything together, right, in order to start working on it. So in such cases, you need to combine all these files into one file or in one data frame and then start working on it. Correct? I'll take a quick small example in an Excel and then we'll move ahead. So let's say this is data frame 1, and I'm talking in the terms of data frame because this is what we are going to discuss in pandas. This is, let's say, employee 1, 2, 3, 4, and this is their age. Now, let's say these are the two data frames that you guys have. What would you get for left join? What will you get for right join? What will you get for inner join? And what will you get for outer join? Okay, so I will get imp, age, work x, right? And common is 1, 3, 4, and whatever is the age. Correct? This is what you'll get. So basically, inner join is where you'll find the common things. See here, because our employee ID is the common column or is the key on which we are doing the join, whatever is common between these two, we'll get it. So here we have 1, 2, 3, 4, and here we have 1, 3, 4, 5. So the common is 1, 3, 4. Hence we get all the details for 1, 3, 4, right? This is where we have joined these two columns, and now in one data frame, let's say this is data frame 3. In data frame 3, I have information for age and work x both. Clear? And here, if you look at it, so we kind of discussed the inner join part. So basically, this portion, the common portion between these two is what you'll get in inner join. Now, if we understand this part, other three are is very simple. Left join is nothing but the common part as well as the everything that is present in the left data frame. Right join is whatever is common you will get as well as whatever is left on the right hand side. And outer join is you will get all the details from all common as well as what is left on both. So basically, if you sum all three of these, this is what you'll get an outer join. Clear? So this is how your joins or merge work. This is a typical SQL database concept, but yeah, you can do all these things in Python data frame as well. Okay. Now, if you remember in Numpy, we did a, what do you call, manipulation or indexing or slicing over there, right? Go from here, go till there, so on and so forth. All these things are available in pandas as well. It's just in pandas, there are two possibilities. One, you do slicing by index, or second is you'll do slicing by, the name of the columns. So because we have names over here also, so you can do it by that as well. And this one is same as what we did in NumPy. Now let's see how we do it. Now, so if you want to do it by index, the function is, let me highlight that as well. If you're doing it by index, the function is iloc. And if you're doing by position or location or column name, however you want to call it, the function is loc, LOC. Okay, using these two functions, you're going to do it. Now, let's say, first of all, we are doing by indexing, by index, using our index number. So I know that fourth is my column of HP, let's say, or let's say any column. Let me write, first of all, do cards dot head. So these are, let's say, your column. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? This is how your column goes. Now, one way would be to use this column name directly, or second way would be to use this index, right? If you want to use these numbers, you will use something called iloc. And if you want to use this column directly, you can use a function called lock. Now, let's say you want to get HP column. So I know it is like 0, 1, 2, 3, 4, right? As a C. So basically, if I write like this, iloc first is always rows, if you remember from a pandas discussion, and then it is columns. So if I write it like this, get me all the rows, that means colon means if you are not providing anything, that means get me all the rows, and comma, the column that you're looking for, fourth. If I run this, I'll get all the what you call rows or all the values of column HP, right? Now, so if you want to do it with column name, the function is dot lock. All right. So there can be counter for that as well. I can say there are certain instances where using index number is much more easier. Then there are certain instances where column name is much more easier. So it depends upon the use case where you're applying it. Like when you're having dealing with 1 or 2 columns, obviously column name makes it much more easier. So over here, the function name is lock. Everything remains the same. It's just rather than giving the index, you're giving the name of the column. So here, if you look at it, let's say if I say start from 1, go till 8th record, and give me all the values of MPG, right? So I'm just giving these information for records, row level, and for column, I'm just looking for MPG column. As usual, I mean, the Python code is very straightforward, and it's very intuitive. See, simply the name of your data frame, and you simply pass, I mean, write dot sort values, and you tell, you give a command keyword called by, and tell by which column you want to sort. So if you write card dot sort values by CYL, so it will sort the entire data frame by CYL values. All right. And by default, it will do it by in ascending order. If you want in descending order, you will have to pass additional parameter called ascending equals to false, because by default ascending is true, right? So if I do ascending equals to false, what it will do is it will sort my data frame depending upon the values of CYL cycle, and it will do it in a descending order. See, this is the file that I'm using correctly. This is already available, so probably you guys can use it from there. Yeah. So what happens is, okay, rather than that, let me show you how to understand it when you do it on your own. Let's say this is the function that you're looking for. All right. And I'll simply put a question mark. And if I run this, so if I go and look at the official documentation of it, it says that ascending equals to true is the default value it takes. That means it will always sort in ascending order. But if you want to change this natural behavior or default behavior of it, rather than true, you need to put ascending equals to false so that it sorts in the descending order. So always check with the official documentation in case you have any confusion like that. So basically what it is saying is, when I don't give anything else, say I say cars dot sort values by CYL, it will sort the data frame by cycle column and in the ascending order. But if you want in ascending order, you'll simply write ascending equals to false. Now, one more thing, like how can we basically do a filtering of our data? So by filtering, I mean, let's say you want to filter out few records depending upon certain conditions that you need to put, right? So how can you do it? Let's say if I say cars, given the name of the column, and greater than 6. So basically filter all the records where I have values greater than 6. So what it does on the backend is it will go and check CYL column against all of these values, against the 6 value. So first one, is it greater than 6? Probably not. False, 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 where it is true. So I don't want this false true, rather I want my data in the original state, but depending upon this filter condition. So how will I do it? I will write this condition of filtering. So I've passed it into a variable called filter1, and simply my new data frame is cars in square bracket, this filter. So if I run this, what it will do is basically it will give me my filter data. Let me simplify it for you. Let's say even if you don't want to do it, simply do it like this. You want cars, this is the original data frame, and in the square bracket, write the filter that you're looking for. Here my filter is car CYL should be greater than 6. So I'll simply write car CYL is greater than 6. And if I run this, I will get only those records where CYL value is greater than 6, if you notice. Right? This is how you filter your record. This is one condition. If you want to put multiple condition, like you can put and or like logically how you put, right? So you can use those as well. So here what I'm saying is, give me all the cars records where CYL is greater than 6 and HP is greater than 300. So multiple condition I've given. I've passed it into a variable called filter2 and simply given that value in the square bracket of the cards. So it will give me all the records where CYL is greater than 6 and HP is greater than 300. So very easy, right? Rather you can write all sorts of what you call a condition if you want. You can have multiple complex conditions. So depending upon your simple and or rules, it will evaluate and it will give you the results, right? Simply write the condition that you want to looking for, pass it to a variable, and simply give that variable in the data frame. This is all I had to discuss from Pandas perspective. Fine. So let's start with data visualization. And okay, so basics of data visualization. So data visualization, I think I don't have to emphasize on the need of it or the definition of it, but still we'll just quickly look at it. So data visualization is the graphical or pictorial representation of information and data. I think everybody understand. See, on the left hand side, this is the same data set that we were looking from past 2 days, right? Your cars data set. But if I go and create a dashboard like this, obviously this right hand side is much more appealing, and you will be able to grasp a lot more information from it quickly versus the left hand side. Does everybody agree to this statement that the dashboard gives you quick information versus on left hand side the raw data, it is very tough to understand what exactly is happening, right? You'll use bar charts, line charts, all those histograms, these sundials and everything. These gives you quick information, and also you tend to retain information for long also. So that's why data visualization is very important. Then another example on the similar lines, but a simpler example. So let's say these are two extinct animals that you're trying to compare. One is a mammoth and other one is a saber tooth cat. Now we are trying to compare them using these 3 parameters. One is speed, aggressiveness, and size. So speed, if I see this is 25 kilometers per hour, this 75 kilometers per hour. So obviously first thing in my mind would be, okay, mammoth was slower than saber tooth. Then aggressiveness, this is low, this is high. So probably saber tooth was much more aggressive. So I'm just trying to picturize these 2 extinct animals in my head. In the size, there's a huge difference between the size. So I know that mammoth would be really huge versus the saber tooth. But rather than looking this information like this, if I go and look at like this, the way in the in this visual, in this box, I will be able to understand, or I will be able to remember the difference between mammoth and saber tooth for long, because this gives me that quick what you call visual appeal, and hence I'll be able to retain this information for long. That probably this one was a more aggressive animal. It was very quick in the speed, but the size was pretty small compared to the mammoth. Right, just another way of showcasing, highlighting the need of the data visualization. What all extra advantage you can have by looking at the data visualization versus the raw data. Now, somebody might say, rather than looking at the raw data, if we look at the descriptive statistics of it, do we still need data visualization? Okay, so for that, there is a guy called Francis Anscombe, and he was able to answer this question. Let's see. Okay, so this is a very famous example, and if you look at this data, so we have 4 data sets. Please pay, we have 4 data set, 1, 2, 3, 4, and both have 2 variables, X and Y. All right. And what I am doing is I'm looking at the descriptive statistics of it. Because what I have learned till now is descriptive statistics give me a very fair understanding of how my data set is, right? If I look the sum, if you notice exactly it is the same. For X and Y, exactly the sum is same. If I look at the average, again, exactly same. If I look the standard deviation also, I mean how much it is deviating from your mean, this is also exactly the same. Now, if I give this information, what can you say about all 4 of these data sets? When you're looking at the descriptive statistics, all the values exactly matches to each other. I mean, exactly, it's not even like 0.5 going here and there. Can we say these 4 data sets are similar to each other, if not exactly equal? Right, as all the descriptive statistics values are exactly same. Now, I mean, logically speaking, they look like pretty similar, but if I go and actually plot this data, okay, uh, descriptive statistics wise, everything is exactly the same. But when you plot this data, this is how the data looks like. So this is a way, and if you look at this this information, obviously now you can say that these two are nowhere similar to each other, or these 4 are nowhere similar to each other. So basically what we are saying is just these descriptive statistics alone cannot give you a quick, I mean, cannot give you the exact picture. Data visualization is also important. So this is what Anscombe's quartet actually proved to us, that there can be data sets where those look like exactly the same from a descriptive statistics point of view, but when you actually go on and plot them, when you actually go and graph them, you will see that the behavior might be absolutely different. Right? Hence, data visualization is also a very important aspect in order to understand patterns, trends in your data. And this is a very famous example. People in interviews from senior level to junior level, all the.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Business analyst interviews, data scientist interview, and Anscombe's quartet is a very common question. All right.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Understood, everyone? I mean, just trying to emphasize on the fact that data visualization is very important. So this guy actually, he came up with this. So he was an English statistician, and he showed the importance of visualizing the data. Okay, so he came up with these 4 data sets. Hence, it's called quadrant. All right. So in order to, now what we have done till now is we have kind of established the fact that data visualization is pretty important, right? How to do it? There are much more. Every day you will find a new level. So in short, for experimentation or for POC, Matplotlib and Seaborn, I think is more than enough. For production ready, obviously you would go for any sophisticated consumption layer, which has a lot much better aesthetic appeal. So there are, I mean, here few of the Python libraries that they have mentioned, the popular ones. The one I was talking about, it's a very new thing. It's a very new thing. It's called Streamlit. Streamlit. So it's a very new thing. I think hardly 2 years old or something like that, but it has a very good aesthetic appeal to it. You can do a lot more things. It's a web-based basically app that you'll be creating it. Right. So in this course, what we'll do is we're going to deep dive into Matplotlib, because Matplotlib is the most basic one, yet it has all the basic plots in it, which you can create in order to analyze your data. See, our objective is not to create beautiful visuals, rather to get insight from it, speaking from a data science perspective. So Matplotlib, as I said, it's one of the most popular ones. It can create very nice, beautiful 2D graphs. Few major concepts in Matplotlib. Theoretically, we'll just quickly have a look at them. So Matplotlib, E. So that is the one which I'm going to talk about. That is the most common one. So in the slide also it says the most popular one, this one. All right. So few of the common things in all the plots is something called dot plot, dot show, dot grid, dot set title. So basically dot plot is actually to plot the data. Dot show is to show that graph of plotted. Dot grid is to set grid lines, and dot set title is to set the title. So basically, let's say if this is your plot, this is the graph that you have created, right? So on the back end, you can have grid lines, right? All these things like lines running here and there. So this is your set grid lines, grid lines. Then set title is like naming this title. Let's say this is salary versus age comparison. So you can put a title to it as well. And show is to actually show the output, and plot is to plot the data into this graph. So these are the 4 common functions that you need to that you will be using again and again. And then depending upon which graph you're calling, you're going to customize these ones. Just a basic theoretical part. Just a basic concept. Then on this thing on the chart, this is how a typical chart would look like. Here you will put the title of it. Here you can have y-axis label, y-axis title. You will have x-axis label, right? And then here you will have something called legend. So legend will tell you by color wise what does each of the line of the color means. Then here these dotted lines are your grid, right? And then you can have markers like where the line will cut. So let's say I can have cross as markers wherever they're cutting them, something like that, right? All these things are just basic things to show while we will do what you call, while talk about these graphs. I'm going to show you, I think, almost all of these. So in the code itself it would be much more easier. Otherwise it's like just a basic theoretical part. If you want to remember, that is all right. In case if you don't want to remember, that is also fine. Then few of like if you want to change the color, so what are the color codes? So B is for blue, G is for green, R is for red, so on and so forth, right? Then if you want to change the markers, I said like how you want to represent where the lines are cutting and all those things. So you can have dot, circle, X, diamond, hexagon, all those things. Like just these are all what you call artistic customizations. It's very individual thing. Somebody might say I like diamond more than X. Somebody might say no, I want a simple point. So it's a very individual and artistic thing. And then you can have solid lines, dotted lines, hash lines, all those things, right? So basically you can have all these customizations as per your need. Now types of plot. So my where I can be what you call productive in this module is where I can basically discuss and I can help you to understand in what scenarios to use which graph in order to generate the maximum insights from it, because that is our end goal. Our end goal is to understand the maximum information we can from our data. Now for that, let's talk about each of these graphs. So line plot is a very simple plot where you're actually just plotting the data by a line. So this will be, let's say, an x. This is your x-axis. This is your y-axis, and let's say over time. So this is, let's say, time, and this, let's say, sales. So in such instances, so you will show the data, how the data is moving in time as per your sales. So this will tell you to help understand some trends in your data. So right, so line plot, this is an example, sales versus time, and it helps you to understand the trends in your data, right? Also, it can be used to understand the correlation between the data. Similarly, scatter plot is nothing but on x-axis and y-axis, you're actually plotting all the data points. So rather than showing them by a line, you're plotting all the data points, right? So it will tell you whether these two are highly correlated, not correlated. So scatter plot is also a very important plot in order to understand the what you call the correlation between the data. For example, let me draw an example. So this is an x, this is y, and these are my data points. So what can you say about the correlation of this between x and y? So basically line plots can be what you call extended for as an area plot as well. So area plot basically under your line, whatever is the area they are covering, this is what they showcase. So they can be used to compare two variables over time or two classes of data over time. It can also be used to compare cumulative data over time or over any other variable on the x-axis. So this is where area plot comes into picture. So not a very intuitive plot, to be very honest. It's always better to draw a simple line plot rather than an area plot, because it can become a little confusing for some to interpret. So but overall it is just representing the area under the curve. So area under the curve is also statistic numerically, mathematically, it is integration from your minus from your lower limit to upper limit. Integration is nothing but the area under the curve. Okay, so now coming to bar plot and histogram. Example of area plot, let's say you want to look at sales of a certain product in New York versus London versus New Delhi. So this can be an example for area plot. I mean, this information can be represented in other formats as well. But if you want to see the trend over time, over each year over year, how the values are changing for each of the city for the sales of a certain product, you can use that. So basically, bar plot are used when x-axis has categorical variables. That means one variable is different from the other variable, or by different I mean is not dependent upon the other variable. In the sense, so let's say there's a city column. So city column is a categorical in nature. Or let's say if you look at year as a different category, each year as a different category, then you can put bar plot as well. So maybe it could be something like, as I was given an example of the city, let's say New York, London, New Delhi. Let's say these are 3 cities, and you're looking at the sales. So if you look at like this, let's say this is like here, and this is like number of items sold. So in such instances, bar plot gives you very good way of comparing one category versus the another. This is where you'll use bar plots, right? While histogram is a different story altogether. Looks pretty much same, but histogram is to look at the distribution of data. For example, let's say, so I have my employees and their age. So what I'm doing is I'm creating buckets. So 20 to 25-year-old, 26 to 30, 35 to 31 to 35, so on and so forth. And in this, I have, let's say, 40 employees. In this bucket, I have 50 employees. In this bucket, I have 60 employees. So this probability distribution, or the distribution of data, on the x-axis, you will create buckets. On y-axis, you will basically represent the frequency or this count. This is what histogram is used. Histogram is used to understand the distribution of the data. So eventually you can figure out whether your data is following a bell curve or it is not following a bell curve. So histogram is also used to understand whether it's normally distributed or not. So bell curve is also called normal distribution or Gaussian distribution. All these three are same, right? So bar plots is where you are comparing, and histogram is whenever you want to look at the probability distribution or a frequency distribution of one continuous variable. Here only one variable we are analyzing, which is age, and what is the frequency in its buckets. Here we are comparing two variables, the number of items sold versus the city.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video, but note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console, but here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter. And if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSBA and CSS. And as you can see that it added it to the it added those two strings together. Now if this was not string and if I were to use a number, again what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable.
So I'm assigning 25 to age. If I were to type name, comma, age and equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now, if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there. So you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B and C to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B and C, if I were to use B, C and A, then B will be assigned 10, C will be assigned 15 and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1 because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter, and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand. So let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and one. So when you hear something like integer can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits. Number formed by 4 binary digits. So I will have this will be 0 since all the 4 numbers are 0. Now what we're doing is I want to check if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3. This should be 2. Should be 1. This should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0 plus 2 to the power of 2 which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1 which is 2 multiplied by 0 and we go 2 to the power of 0 which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1 and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you a look at what it means. Now because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we've run out of space. We can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator does. It takes the binary format and shifts it by 2. Now, on the other hand, we also have right shift operators. And it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed and add 2 zeros at the beginning, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right. And at the very end, let me show you what the NOT operator does, because this is very something that's not shown very accurately. NOT operators turn the number from, turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the NOT operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python, and I were to use the ID method, and I were to pass it a number 1. You see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4, and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discussed are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code, and we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type ret is equals to 7, this works just fine. But if I were to type return return, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every character in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. When Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7, And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, and it's 72. So if I were to print VAR with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 VAR equals to 7. We'll get a syntax error. But if I were to do it V1AR, this is just fine, it will work. V1AR, and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, Boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path. Press enter and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now, the way it worked in Java and C and C++ was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that, you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. Just need to understand why there's two quotes and why there's one quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type three single quotations, press enter. I get back the prompt with three arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l. And I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers. So numbers with real and imaginary parts. Now, if you worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers. So we can store that in integer as well. Let's say that I want to store -77. I can store it in number, or +77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now, there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type BOL, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that could that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers, and tuples will have some value assigned to them. And then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable, we have lists, dictionaries, sets, and in lists, we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this. And if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that, I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now, another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the 5th character or this the 6th character in this, which is on the 5th index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the 5th character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the removing the last one character. If I were to remove the last 2 characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f g. I press enter, it returns another string to me, which is a, b, c, d, e, g, g, h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O, or U, and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me, Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to into the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousand. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it looks just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when it's trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple, 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple. So to see if it's a tuple or not, and it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list, which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create, again, salaries equal to, and I can create a dictionary like this. Add two curly braces. Inside it, add the key, which would be the person's name, let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter. And now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good. But one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. I press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is, if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets. Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? A set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in s, and it will show you 2. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do 1 in s as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in s I can type 1 in l, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window. And here type in VS Code. Press enter and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open with this code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py and right and click on edit. It will open it in Notepad and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. Here you can do it this way. Now if I open this, as you can see, I can type in a lot of things.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method in the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I printed it's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num0, and then I keep going on like print num1, num2, num3, so print all the 4 numbers, what I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understands what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parenthesis, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter, and pop is also not available. But you can print them, you can loop over them, just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this. DICTIONA dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, Let me just, yeah. Now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys. These are the values. So Jane earns 15. John earns 20. So we type it. We print in the keys. Now, if you don't want to print the keys, let's say we want to print the values. I do that. Now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now, another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now, if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for x in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10 because the end is exclusive. So always remember that. And now if I do L dot append X, and finally we can print X, not XL. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code, because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add X to the list. Now Python is waiting for me to define what X is. So I'll go for X in range 0 to 9. And that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier. And this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and so you will get run into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a Boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if-else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if say the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand if the condition is true, then statements 1 is going to execute, and if condition is false, we'll execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true, then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Where this again is correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else. I can write some code. X is greater than 15, and finally else. X is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We assign a value of 17 to x. We check this condition. We check if x is less than 20. It is less than 20. We go down. We print x is less than 20. We go down. We check x is if it's less than 15. It's also true. So we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read if you can you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on. So don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list But if anything, if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flow chart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So in space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and a space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping, we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this, done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list and you don't want to print the name of people whose salary is less than, let's say, 40k. So what you can do, if person, let's say that for each x0 index is x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. It'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. Another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1, I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it'll do the same thing, but I had to write a lot more code and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you have working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements. Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform. And if that's the case, then you don't return anything, you just omit the return statement completely. To give an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's lambda functions. Now this is a concept that gets overlooked quite often, but lambda functions are very powerful. So lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But if since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, another thing that Lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. All right. So if I were to call this function, download file, and let's say that the URL is ftp : www.abc.org. Now if I were to run this, let me just run this here. It's going to perform these tasks. But the major advantage of using a function is now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL, df ijk, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database, that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines, so this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see. And it's downloaded it, but as you can see that this step is now added to all 3 of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in 2 data and I perform some task. Now I want to return x multiplied by y. Let me call it, again, this is a very trivial example, multiply, right? And if I want to multiply two numbers, multiply, you multiply x and y. Now x and y are going to be numbers, so let's say 15, 10, 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it. So multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again, and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply. multiply, and we want to execute. If I run this, again it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and. Okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. Taking a look at what our data structures.
Let's get started. The first question that comes to everyone's mind, okay, is that what is data, right? Data is nothing, right? But it's essentially just collection of facts, collection of information, which could be used for bringing about a meaningful output. Okay, data could be of various formats, right? It could be in the form of, let's say, in the form of numbers. Okay, it could be in the form of names. It could be in the form of various formats, right? For example, right now, while I'm talking, right, while I'm basically speaking, what I'm doing is I'm basically generating data, right? This speech that comes out of my mouth right now is being recorded and it's being used. It could be used for future reference, right, for something meaningful, right? And that meaningful thing could be basically aided uh, for a better or and improved learning for some of you, right? So when we speak, right, that's also data. When we consume info, okay, so data could be numeric, it could be textual, right? It could be speech, right? It could be video, it could be images, it could be binary numbers, it could be formulae, everything that could be potentially used for bringing about a positive outcome. Well, positive is not the right word because you could use it for negative outcome as well, but whatever can be used for bringing about a meaningful outcome, that's essentially data for you. Okay, traditionally, right, traditionally the data that we had was mostly structured and small in size. Okay, and you could use, let's say, simple business intelligence tools, right? Let's say Excel or Tableau, okay, for analyzing this small, simple, unidimensional data, right? But unlike the data in traditional systems, the data today is mostly unstructured or, let's say, semi-structured. Okay, when I say unstructured or semi-structured, what I mean is that the data that is getting generated from various sources, let's say text files, right? Financial logs, multimedia forms, right? Images, video, audio, information that gets captured on sensors, right? Every machine, in fact, every machine nowadays has some sort of sensor in it, right? Which records information, which saves information. Okay, that information that gets saved in sensors, right, and instruments is also semi-structured or unstructured data. Okay, any data which is not in the form of rows and columns, okay, it's essentially either semi-structured data or unstructured data, right? Which means that you will have to apply additional effort to bring that data into a structured format, which you could then use for for bringing about a meaningful outcome. Okay, so I right now most of the data that gets generated is semi-structured data or unstructured data. Okay, in fact, it's a slight cliche, but um, the amount of data that we have generated in the last 2 years, okay, is equivalent to all the data that was being stored and generated before the last 2 years, right? In the history of mankind, all the data, if you put together all that data that was saved, that was stored before, let's say, 2019, it is equivalent to the amount of data which has been stored in the last 2 years. Okay, so now that you're taking so much effort, now that every business, everyone is essentially taking so much effort to capture, to store all of this huge unstructured data, right? It is actually a responsibility for these businesses, right? That we basically come up with more complex and advanced analytical tools, right, and algorithms which could help in processing, analyzing, and drawing meaningful insights out of this huge unstructured data, right? So data science is so popular today. It's because we are generating so much data, right? And businesses are realizing that they could potentially use this data to identify insights which could help them grow their business uh, by several times as compared to what they would have done before or be without using this data. Okay, all the businesses are realizing the power of using data for bringing about data driven decisions, right? Data driven decision making is something which everyone is realizing is so important, because if you as a business are not using data and your competitor is, then you're essentially losing out on a competitive edge from them, right? So that's one of the reasons why data science is so popular today, right? It helps you come up with a competitive edge, right? It helps you get insights out, right, which otherwise might not have been available to you. Okay, so that is one of the reasons why data science is so important. And but this is not the only reason, right? This is not the only reason why data science has become so popular. Why data science is so popular today is because of the number of applications that you could possibly derive um, from learning data science, right? There are innumerable kind of use cases, right, that you could potentially derive out of data science. Also the usage of these use cases are so varied that you can apply data science across various domains and industries, right? It's not just limited to a particular domain. Let's say I just gave you an example of predictive maintenance, which is most common, let's say in a manufacturing setup, right? Which means within manufacturing you could definitely use data science, but it doesn't mean that you cannot apply data science in, let's say, insurance or banking, right, or healthcare, right? Data science today is being used, and there's so many popular use cases of data science across so many different industries, right? Just to give you a small glimpse, okay, let me show you a very interesting infographic. Okay, so this is an infographic which captures some of the most widely used business use cases, right, applications of data science across different industries. Okay, and this is not exhaustive, right? It doesn't capture all the use cases, it doesn't capture all the industries where you could potentially use data science, but I just want to give you a glimpse of what are the possible industries where you could apply data science and what is the outcome that you can derive out of using data science. Okay, so here is a very interesting infographic. Let me talk through couple of these. For example, in marketing, okay, in marketing there's so many different use cases of data science today, right? uh, Customer churn, right? Churn is a very important use case of marketing, right? Today, if you can predict in advance, right, that this customer is going to churn, right, this customer is going to leave my services and join a competitor service, right? If that is something that you can predict in advance, right, then imagine uh, then imagine that you can take efforts, right, that you can make efforts to improve the churn rate and improve the retention of your customers, right? So if you know in advance, let's say if I know in advance, I am a business, I know in advance that these are the 100,000 people that are most likely to leave my business in the next 30 days, right? Then in the next 30 days I know where I need to focus on. I know that these are the 100,000 people who are most likely to leave, and also using machine learning, I can understand that what is that pain point which is forcing them to leave, right? Whether it's cost, whether it's customer service, whether it's user experience, what is it that I need to improve for specific components, for specific segments of customers, that would help me retain my customers better. Okay, so that's what customer churn analytics, right, or churn prediction enables you to do, right? It enables you to understand in advance who are the customers that are most likely to churn, right? And it also enables with their toolkit to know what is the reason why this customer is leaving, right? And if you know that this is the reason why this customer is going to leave, you have, let's say, 30 days or 60 days to improve upon that parameter so that you can prevent that customer from churning, right? Let's say if I know, and based on this knowledge, if I'm able to retain, let's say, 50% of these 100,000 customers, then that in itself is a very big win for me, right? I'm able to retain 50% of the customers that would have otherwise churned, that would have otherwise moved out of my organization, right? All the effort that I had taken to acquire these customers would just be gone in no time, right? So that's where customer churn plays a very important role, right? What you do essentially is that you train your machine to understand the differences, to understand the relationship between customer churn, right, and various independent parameters such as, let's say, cost, right, let's say customer service, let's say user experience, right, let's say uh, competitors, right? What is it that is leading for a customer to leave, right? And you try and use machine learning to come up with an equation, right, which could be then applied for customers in future and help, and that will aid in making predictions. Okay, so that's customer churn. There are a lot of there's several other applications as well. For example, cross selling and upselling. You can use machine learning to understand if a customer buys X, right, what is that next best product that you can uh, push to the customer, right? And there's a good likelihood that that customer will end up buying that product, right? That customer, when it came to you, he came to you with the intention of buying X, right, which would have led to $100 sale for you, right? But because of knowing that this customer might already need another product, right, this comes from the understanding of their transactional behavior, this comes from the understanding of their demographic behavior, right? You are able to predict, okay, that when customer buys X, right, he or she is also likely to buy Y, right? And you basically make that available to that customer, right, in the form of assortment, in the form of recommendations, right? And when you do that, instead of generating $100 sales from product X, you are also generating, let's say, $150 sales from product Y, right? Now it is likely that not it is likely that 100% of the customers who you have recommended Y might not buy it, but even if 25% people buy it, that's incremental sales for you, right? So that's cross selling. There's also a concept of upselling wherein you see that if a customer has bought a slightly inferior service, and this is mostly true in the case of services, right? You try to identify who are the set of customers, right, who are most likely to move to an updated service, right? Today, let's say I am using an internet service from a telecom provider um, where I use let's say 500 GB of data. Okay, now every month, right? Now using this information and using this information from a lot of other customers, what my telecom provider could predict is that because I am already using close to what my quota is, what if they propose to me a plan, okay, which offers me, let's say, 100 GB more, right, with some additional cost, right? And I'm most likely to buy because I'm already sort of exceeding, or I'm very near to what my threshold, um, what my quota is, right, for data consumption. Okay, so basically providing me an upgraded service, right, at some additional cost, right, which is of course as a profit generating source for the organization, right, revenue generating source for the organization, right? So that's cross selling, that's upselling. Digital marketing is very popular in the market right now, right? You use ads, right? You use, because everyone is on social media, right? Everyone, uh, let's say everyone uses Instagram, everyone uses Facebook, everyone uses YouTube as well, right? You push ads on these platforms so that, and you do this in a very targeted manner, right? You understand what are the demographics that you need to target to, let's say, promote your business, right? Who are the set of customers that should see your ad, right? And you push ad campaigns on these platforms, and basically use these ads to improve awareness of your brand, or you could also use these ads to drive traffic to your own website. Okay, so digital marketing is very popular today because of the absolute scale, right? Absolute volume of audience which is available on these social media platforms, right? Digital marketing, sentiment analysis again, right? It's a very popular advanced analytics use case where you use social media reviews, right? Social media comments, etc., to understand the perception of customers about a particular brand, right? Let's say if I'm Apple, right? I'm coming up with iPhone 12. Okay, I can, and let's say people have bought iPhone 12, right, from Amazon, and there are 100,000 people who have bought it. Out of those 100,000 people, let's say there are 10,000 people who have written a review about their purchase on the website, right? Now, of course, it's almost impossible for a human to read through 10,000 reviews, or if even if they do that, it would take them several days to do that, right? What you could do is you can essentially capture that data and try to generate the sentiment of those reviews, right? Whether the sentiment is positive, whether the sentiment is negative. If there's a negative sentiment, what are the primary themes, what are the primary reasons why your customers are coming up with a negative sentiment, right? So that you can work upon them and improve them, right, for future purchases. If there's positive sentiment, then you understand what is it that is driving positive sentiment, and you do more of that, right? So a lot of different use cases of analytics, of data science across marketing, social media, automation. Of course, automation is all about machine learning, data science, right? Tesla is coming to India soon. Tesla is all about AI, right? um, so it's all about AI. It's all about reducing the effort for human beings, right? There's a lot of interesting use cases of healthcare, of analytics in healthcare, right? Clinical trials, by the way, is one very popular use case of data science in the healthcare industry.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
You can use statistics, you can use data science to predict the effectiveness of let's say a vaccine, right? Because of the recency of it, I can say that, let's say, um, when India was coming, or when any healthcare firm was to generate, was basically building a vaccine, they have done clinical trials, right? They've used data science, they've used statistics to understand what is the effectiveness of their vaccine, right? uh, how this is done is a slightly um complex approach, but let me give you a very quick overview of how this could be done, right? Let's say, you, like, anyone who's trying to build a vaccine is trying to build a vaccine for, let's say, 100 million people, right? Or if they're in India, they're building a vaccine for, let's say, 1.3 billion people, right? And there are almost thousands different traits of people, right? Or 1,000 different varieties of people who could possibly consume that vaccine in the future, right? So when you have to you have to do clinical trials, when you have to justify that your vaccine is working, it is effective, and it does not have any side effects. When you're doing sampling, right, of course you cannot, when you're doing clinical trials, you cannot you cannot use everyone to do a trial on, right? You will have to pick a sample, okay, and that sample has to be such stratified, it has to be done in such a manner that it the uh, captures all the attributes of the entire population, right? Unless the sample which is used to test the effectiveness of a vaccine to be declared whether it's a good vaccine, whether it's a poor vaccine, whether it's let's say 90% effective, you have to ensure that the sample that you have taken into consideration, that the sample of humans that you've taken into consideration for testing your vaccine is representative of your entire population. If it is not representative, right, then it is a risk, because let's say you did not take into consideration all the diabetic people, right, into your sample when you did clinical trials, and you said your vaccine is 90% effective and it does not have any side effects, but later on when it was um, rolled out to everyone in the population, right, and let's say for all the diabetic people there were several side effects that were observed, right, or it did not show any effectiveness for diabetic people, then that's a huge disappointment for the vaccine, right? That's basically a bloat, a black mark in their on their name, right? So statistics is also very important there. Data science is very important in the sense making sure that your sample is representative, your sample is chosen um, such strategically, right, in such a manner that it takes into account all the different demographics that could potentially exist in the entire population. Okay. um, Credit and insurance is another very popular domain where data sciences is used. Okay, every transaction, every credit card transaction that you do, by the way, it goes through a machine learning model. That machine learning model predicts, okay, whether the transaction that you made is it has certain signals of a fraudulent transaction or not. Only if the model says that this transaction that you've done does not have any signals of fraud, that's when that transaction will go through. Otherwise that transaction will be blocked, right, and it will go through a manual test. Okay, so fraud detection model is so important, of course, because of the volume of credit card transactions that happen today. Every day I'm sure millions of transactions are happening across the world, right, and the amount of monetary value that is associated with those transactions is huge, right? Even if let's say 10% of those transactions were fraud transactions, then it's a huge loss for the credit card organization, right, because it has to repay its customer on any fraud that has happened to them, right? So for that reason, what credit card companies do is they basically make use of historical data. They make use of machine learning to identify traits of fraudulent transactions and traits of non-fraudulent transactions, conceptualize that in an algorithm such as, let's say, linear regression, logistic regression, etc., right, and use that model, right, predictive model, on every transaction that goes through. Okay, only if the model predicts that this transaction is a non-fraudulent transaction, that's when it will go through. If it says that it's a fraudulent transaction, then that transaction might be blocked, or that transaction might have to go through a manual review, and then it'll take some time for the reviewer to understand what that transaction is all about. You might also get a call to understand whether the transaction is fraudulent or not. Okay, so a lot of different use cases across healthcare, across sales, across travel, right? Everywhere there's data science, and as I said, right, this is not exhaustive. There's so many other applications which you've not even touched upon in this infographic, right? So because there's so much that you could do potentially using data science, that's why data science is so popular. That's why data science is almost indispensable in today's world. Okay, so why data science is important? Because it helps you in understanding your data, right? It helps you in identifying interesting insights, right? Insight is nothing but an information, a finding which is actionable for the business, and it basically can be used, okay, to come up with uh, an action, right, which would lead to improvement for your business, or improvement for any uh, mostly for business, right? So yeah, and then of course by identifying those interesting insights, you could make informed decisions about your business, right? You can come up with actions, you can come up with strategies, right, to efficiently counter those insights, to efficiently handle those insights that you've gotten, that you've sort of extracted from data science. Okay, all right. So what we're going to discuss now is understanding what is data science. So to start with, in the most easiest manner, if I have to define data science is nothing. Okay, data science is nothing but it's the science, okay, of applying mathematics to data. Okay, it's the science of applying mathematics to data so that you can make the data talk to you. Okay, when I say you can make the data talk to you, it means that you enable interpretability of raw data, right? You make data talk to you in the sense that you are able to generate insights, generate hidden patterns out of that data. Okay, that's how I would define data science. Also, let's say if I were to formulate a chemical equation, right? I'm sure a lot of you might have, like in chemistry, you might have learned about different equations, right? Something like S2 plus O2 gives you S2O, something of that sort. If I were to build a similar equation, okay, my equation wasn't correct, by the way. When I said S2 plus O2 would give you S2O, okay, you'll have to balance it. But if I were to form a chemical equation, an equation which will give me what data science is, okay, this is how I would do it. I would say it's nothing but data, okay, plus math, okay, and in my right hand side I get insight, okay. But we are not done yet, because to process this data through math you need a very important catalyst here, right, which is nothing but technology, right? You need technology to be able to process data and apply math on it, right? If you're not able to use tech, if you didn't have technology in here is nothing but the computers and the supercomputers that you use to process large volumes of data, right? The memory that you use to process large volumes of different varieties of data, right? And then apply mathematical algorithms to them, then apply statistical algorithms to them to generate hidden information, to generate insights which were otherwise hidden to us, right? So that's what data science is, okay. And by the way, there's no perfect definition to data science, right? You like even this definition, the definition that I just presented could also, I mean, I'm not saying it's a flawed definition, but I'm saying that there's no perfect definition in the sense because it's such a vast concept that you can't really create a one sentence definition which could encompass everything that data science is comprising of. Okay, so data science is nothing but it's essentially a blend of various tools, algorithms, right, and different machine learning principles with the goal to discover hidden patterns from raw data. Okay, the ultimate goal here is that you generate insights, you generate patterns which were otherwise uh, not visible to our naked eyes, right? Now you might ask me, right, some of you might ask me that how is this different from what a business analyst does, right? Or how is this different from what a data analyst does, or how is this different from, let's say, what a business intelligence officer does, right? All of these roles are in the domain of analytics, right? But how is a data scientist different from these two or three other roles that I mentioned? The answer to this basically lies in the difference between explaining and predicting. Okay, the answer to this basically lies in the difference between explaining and predicting. Okay, what an analysts, or let's say a business intelligence officer, would do is basically what they do is they've been deriving findings. Okay, they derive findings, they derive insights by processing the history of data. Okay, they look at the historical data and they look at the trends, and then they present to you what is the information that is coming out from that historical trend. Okay, on the other hand, what data scientist does, that's the data scientist not only does exploratory analysis to discover insights from historical data, but they also use various advanced machine learning algorithms to identify the occurrence of a particular event in the future, right? So data scientist doesn't just explain what has happened in the past, okay, but they also use the learning of the past to predict something which is going to happen in the future. Okay, an example to that would be, let's say you were looking at the sales of an organization. Okay, let's say I build a time series graph. Okay, a time series graph. Here I have time, which is, let's say, month year. Okay, this is month, and here I have sales of a product. Let's say sales of iPhone. Okay, this is first month, second month, third month, fourth month, fifth month, etc. This is the sales, right? This is the sales, and let's say all of a sudden there was a huge spike. Okay, and then let's say it's sustained. Okay, what a data analyst would do is that, or what a business analyst would do is that they will make this information available to you, right, by processing data. Okay, also they might do a detailed deep dive to understand why this spike was observed, what was the reason of the spike, right, in the sales of iPhone in the market, right, whether it was uh, let's say because there was a discount that was offered on the product across the world, or let's say there was a different model that was released. Let's say iPhone Red was released.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In this month, and hence this happened, right? So they will do a deep dive. The data analyst would do a deep dive and understand why this happened. But what a data analyst wouldn't do is that beyond what has already happened in the past, they will not come up with prediction of this. What a data scientist would do is they would basically consume this information, okay, historical information, and try and correlate this trend with a lot of independent variables, right? When I say independent variables, I mean variables that could have caused, that are basically responsible for this trend, right? There are different things that are responsible for sales of a product in a particular manner, right? That it could be, let's say, the purchasing power of people, it could be macroeconomic factors, it could be um, different features that you've introduced in a mobile phone, it could be discounts that you offered, etc., right? So what a data scientist would do is it would basically try and find relationship of sales of the product, okay, with all of these independent variables. They would try to encapsulate that in the form of an equation, right? And using that equation, they will try and predict the sales of this product in the future. Okay, so that's what a data scientist does. A data scientist doesn't just explain what has happened in the past, rather they build algorithms, they use machine learning algorithms to make predictions in the future as well. Okay, and we will learn this better, right, in the next slide. I'm going to do a very clear segregation of where is it that the skill set of data scientist is essentially concentrated. Okay, but you should understand that a BI officer or a data analyst would essentially analyze previous data to find hindsight, right, and insight to describe business trends, right? It enables you to take data from various external and internal data sources, prepare it, run queries on it, right, and create dashboards to answer questions like, let's say, quarterly revenue of an organization, or let's say any other ad hoc analysis, right? They can also evaluate the impact of certain events in the past, right? But data science, it is more forward looking, right? It's a more forward looking approach, uh, or you could say an exploratory way by which uh, you can focus on analyzing the past or current data and use that to predict the future outcomes, okay, with the aim of making informed decisions, right? So you try to predict the future, but knowing that based on any, like, if you do not do any interventions, this is how the future is going to look like. But if you could do certain interventions, then you could of course change uh, that pattern, change that trend, right, by putting additional efforts, putting additional incentives for the user. Okay, so what data science lets you do is it basically tries to answer more open-ended questions like why, what, and how an event would have happened, right, rather than just describing that this event happened, right? it tries to focus on the why, what, and how of things, right? And using that, they come up with more meaningful conclusions. Okay. Also, data science is an umbrella term, right? It's basically a combination of multiple domains or multiple tools, resources, you could say, right? And some of those resources are mentioned here, right? So it basically takes into consideration visualization. It takes into consideration data manipulation, right? So collecting data through various sources, aggregating it, transposing it, cleaning it, improving the quality of the data, etc. All of that comes under data manipulation, right? You will have to do that in irrespective across all your data science projects, right? It also includes statistical analysis, like statistical exploratory analysis to understand, get a better understanding of your data, right? The relationship between various dependent and independent variables, right? And then use all of this learning to build a machine learning model which has a good accuracy, which has a good predicting power. Okay, that's what data science essentially enables you to do. Moving on, what are the different types of data analytics? Okay, uh, this is important for us to know that what are the different domains of data analytics. Okay, because it would help you distinguish between different roles which are there, right? And it will also help you understand where is it that data science focuses on, where is it that you should try to develop your primary skill set on. Okay, so there are four major domains of data science. Okay, the first one is called descriptive analytics. Descriptive analytics is nothing but it's essentially focused on describing what has happened in the past. Okay, this is what business intelligence officers do the best, right? So creating dashboards, creating reports which describe historical events, describe the trends of historical events or trends of any variable. Okay, let's say trends of sales of various products, trend of revenue of an organization, trend of or like of course or pre-post analysis of a particular feature, etc., right? Where you're just trying to describe information, right? Describe what has happened in the past. That's descriptive analytics, right? So all the reporting, dashboarding, etc., comes into descriptive analytics. Okay, uh, this is a domain where data, like there's some focus of data analyst, right? And the primary focus of business intelligence officer lies. Okay, so this is that domain. The second domain of data of analytics is called diagnostic analytics. Okay, diagnostic analytics is basically when you try to do a deep dive on a particular event that has happened in the past, right? So remember I was showing you that trend, right, where we were looking at the sales of iPhone in the last 12 months or in the last 1 year, etc. Okay, and we saw various spikes and troughs. Right now, if you decide to do a deep dive, okay, on a particular trend, uh, on a particular pattern, to understand why that pattern had happened, right? Let's say if you saw that the sales of your product increased in July, and you do a statistical analysis to understand why that peak happened, right? Why you try to understand the why and how of a certain event by doing statistical analysis, by doing correlation analysis, by doing exploratory data analysis, right, to understand the root cause of the problem, right, or to understand the root cause of a positive trend as well. That's called diagnostic analytics. Okay, what you need for diagnostic analytics is descriptive analytics, right? So you basically consume a historical trend, right, and then you decide to do a deep dive on it by trying to validate or disprove various hypotheses, right? So for example, uh, if you saw a spike in the sales of iPhone in July, okay, you can come up with various hypotheses, right, that why that sales could have gone up, right? It could be because of discount, it could be because of new product, it could be because um, of a particular campaign, it could be because of um, let's say like probably there was no other competitor in the market. So a lot of different hypotheses, right? And then you decide to do an analysis to either prove or disprove each of this hypothesis. That is something that you do when we talk about diagnostic analytics. Okay, so that's diagnostic analytics. Analytics is something where business analysts and data analysts are concentrated. Like, this is what the primary skill set of data analysts and data and business analysts is. Okay, so this is DA and BA. Okay, this is the first one, is basically the prime focus of business intelligence officers. Okay, people who do MIS officers as well. Okay, the third domain of analytics is called predictive analytics. Okay, predictive analytics, as you would know, right, and I think I've been speaking about it over the last few minutes as well. It's basically a technique where you use historical data, right? You use historical data, feed it to a machine, right? You let the machine use its intelligence to derive relationships between the dependent variable and various independent variables, right? And then using that relationship, come up with predictions about what is going to happen in the future. That's what predictive analytics is all about. Okay, so basically using techniques like machine learning, deep learning, etc., okay, to come up with models, right, that can predict the occurrence of an event in the future. That's what predictive analytics is all about, and this is where a data scientist should fit. This is the primary focus of data scientist. Okay, however, it doesn't mean that the data scientist should not be able to do the first two, right? Data scientists should of course have the skill set to perform both descriptive analytics and diagnostic analytics, right? Because those are important for you to get a better understanding of your data, right? And once you have that skill set, once you've done that, only then you can do a good job of doing predictive analytics, right? So the primary skill set of a data scientist is still predictive analytics, but it doesn't mean that he or she doesn't need to do descriptive analytics and diagnostic analytics, right? You might not spend, let's say, 50% of your time doing descriptive and diagnostic analytics, but still 20% of your time would go into doing a descriptive analytics or diagnostic analytics, and 80% of your time would be on predictive analytics and prescriptive analytics as well. Okay, so prescriptive analytics is the fourth domain of analytics, where instead of predicting outcomes, right, you use concepts of diagnostic, descriptive, and predictive analytics to prescribe outcomes, to come up with recommendations. Okay, a very good example of this is recommendation engine, right, wherein you use machine learning not to uh, influence an insight, right, to grow a business, rather to come up with a recommendation, right, to come up with an output to the end user that they could consume directly. What you're doing in recommendation engine, for example, the Netflix recommendation engine, what it is doing is it is prescribing to the user that why don't you watch this movie X, right? Because of all the other movies that you have watched, I feel that you have a very high likelihood that you are going to like this movie, right? So I'm prescribing you that you watch this movie. That's what Netflix is doing, right? So wherever you're prescribing an output, wherever you're recommending something as an output, as an outcome to your user, okay, that's prescriptive analytics. Okay, so our data science primarily works on predictive and prescriptive analytics, right? And let's say 20 to 25% of their time also goes in performing descriptive analytics and diagnostic analytics, right? In the same manner, a data analyst would be primarily focused on diagnostic analytics, right? This is where a data analyst 80% time of a data analyst would be concentrated. Then the rest would be concentrated across other domains, right? So they might develop a skill set of doing a little bit of linear regression, etc., right? Which is something that will come under predictive analytics as well, right? So primarily a data analyst is focused here, primarily a data scientist is focused here, and primarily a business intelligence officer is focused here. I hope this is clear.
So, have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So, our dataset for the case study comprises of these four files: ratings.csv, books.csv, booktags.csv, and tags.csv. So, as the name suggests, ratings.csv contains all users' ratings of the books. So, there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the book tags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Alright, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our datasets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I'm using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N. And I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these 2 cases over here. So the user number 4206 has rated the book number 8945 2 times over here. Right, so these are the duplicate ratings which I'm talking about. So these records need to be removed. Right. Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function, and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book. Right, so this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than one time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given. And I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what we get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by two users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we had to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938, and for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the data set in descending order. And after arranging the data set in descending order, I will also left join the tags data set to the book tags data set, and the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got a data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function, and the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Right guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column, and then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model, and then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs and I'm also extracting all of the unique book IDs and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose. And I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in 2 parameters. So the first parameter is basically what we are trying to convert this into, and then we give in the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here, and this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into 2 parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in 2 parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is nRecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in nRecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF at the rate items 1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are presented columns 2177, column number 6343, column number 423, column number 1908, column number 2274 and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels. And inside this, I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jumpaleri. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segel. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users.
What chatbots actually are. So as the name suggests, chat and bot has something to do with a robot imitating a person, while chatting to another person. So when we have to break it down into a little bit of simple terminology, basically it's a software which is based on artificial intelligence, and this software will try to imitate humans. It'll try to basically, perform the same actions as us human beings without the person, having a very good idea if they're talking to a human being or an AI. If your chatbot is very good, if the chatbot which is being implemented is amazing, well, the human can be fooled enough to not know if they're talking to a robot or if they're not talking to a human as well. And most of the time you wouldn't even require that kind of a complexity, because let's say when you're in the Amazon case as well, where is my order, or why is my payment declined, or whatever it is, you will have a very simple question to which there will exist a straightforward answer, right? So it'll not like Amazon's chatbot will start telling you stories about why your payment failed or why your order didn't come or whatever. So when it comes to that, if it is very subtly implemented, if it is very complex in the back end, you will not find a difference between it being a robot or it being a human being as well. Way back in the 70s and the 60s, there was a test which was very famously implemented across the world. It's called as the Turing test. If you guys didn't know on that, make sure you read up on the Turing test. It was amazing on how artificial intelligence is such an old concept, but it's being used a lot in the 21st century. So whenever you think about artificial intelligence, ladies and gentlemen, the first couple of things that should come into your mind is, for example, Siri of Apple, Alexa of Amazon, or the Google Assistant. These chatbots again have been in our lives most of the time, right? For all the Apple users, you guys have Siri. For Amazon, we have Alexa, and for the Android phone mobile users, we have the Google Assistant. So you might have been using these on a daily basis, because I use Siri a lot and I use Google Assistant a lot as well. And I do know people who use Alexa for their home automations and much more. So when it comes to stuff like this, from the simple Amazon chatbot all the way till a complex powered bot such as Siri, Alexa, or Google Assistant have been helping us daily. So in fact, you can ask the Google Assistant or Siri to play any song for you. And in fact, let's say you're sitting at a restaurant or something, you listen to a beautiful song that's being played, and you just want to find out what song it is. Instead of going through all the pain of installing a software which will listen to the song and tell you what song it is, or you asking the restaurant manager what song it is, just pop out your phone, say, hey Siri, what song is playing in the background. Siri, or in fact even Google Assistant, will actually analyze the song, it will listen to it, and it will tell you, hey, this is the song that's being played. How simple is that? For example, you want to set a calendar invite for the next month, or let's say you have a meeting which you want a reminder for, you want to set an alarm. So all these manual tasks which you could do basically with one voice command, you can get all of it done very simply. And I think that's the essence of chatbots, ladies and gentlemen. So again, coming to emphasize on why we require chatbots, well, when you look at it, the first thing, it's cost and time effective for the companies, because developing a chatbot does not take a lot of money, and it makes sure that it can be done in a quick and a rapid way. As you'll see in the demo which I'll be showing at the end of the session, it will basically validate this point on how time effective it can be when we are working with chatbots, because it's pretty simple, it's pretty straightforward, and at the end of the day, even when you're working on an enterprise level, basically you're working at a level where you have a huge organization which requires a chatbot, it will not really cost much to build it as well. And of course, adding on to the last point itself, coming to the second point, it's cheap development cost. When you're working with chatbots, you need to understand that there are only certain things at this point of time that we can do with chatbots. Of course, with every passing day when we're talking about technology, there are again thousands and thousands of things which keep coming into the market. But with chatbots, you can have it respond, you can have it imitate a human to the best of its ability, right? And with the current power of AI, I think the entire world is pretty much just trying to make sure that their chatbots are as human as possible. So with cheap development costs, there are again a lot of companies which are jumping on the need of chatbots as well. So how would it help the companies, you might be asking? And the best thing is human resource. See, if you have a person who is responding to live chat, which is basically a mundane task, right? They keep doing it again and again and again. So this person as a human resource can probably put into a more effective role. This person can be put into a more productive role rather than answering the queries of customers, which can easily be done with the help of chatbots, right? So it's saving time, it's saving money, and pretty much it's increasing the productivity of the company as well. This is the primary reasons why thousands of companies across the world today have implemented chatbots. And the next point again adds on to the previous point as well. So since your company is being more productive now with the help of chatbots, again you can pretty much give that wow factor to your customers. And if it's not the wow factor, which is basically what you're looking for, you can help your business brand itself through all the social medias out there by showing the world, you know what, I've implemented artificial intelligence here. And you would invite the world, you would invite the developers, customers, or whoever it is to check it out and see if they like them, to see what's going on. And this again directly translates to you talking to your customers in a more customized way, and this will probably help your business in the short term as well as the long term as well, right? So it makes sense. So what do you think? I mean, there are millions of other chatbot cases that we can think of as well. For example, there are doctor apps and health apps which will basically diagnose any condition that you might have. So you can pretty much type in the symptoms and say this is what I'm facing, and it'll probably give you a very vague outcome of saying, hey, you might have this kind of a condition. Of course, you should consult an actual doctor and not rely on these chatbots at this point of time, but then we're getting there. Who knows, probably 10 years from now, the world of medicine can be revolutionized by keeping chatbots very accurate with respect to the field of medicine as well. And that's the thing about artificial intelligence, right? So when you think about it, the possibilities are actually endless, and we've started seeing those endless probabilities in the last 10 or 15 years or so. Coming to the next point, which is chatbot evolution. So this is one important concept, because when we talk about traditional chatbots, so all these traditional chatbots that we have seen all these days basically are system driven. So by system driven, what it basically means is that they have access to a small amount of data and they have responses which basically they know what to reply for when you ask. For example, if you have to take the Amazon case again and simplify it to a level where there is a possibility is that the customer might ask two questions. The first question is, where is my order? And the second question might be saying, why is my payment failed? So when you have to break it down into simple terms, and the bot recognizes what question you might throw at it, giving the answer to it becomes very simple. So that was system driven. And automation scripts, as I just mentioned, if there are a certain number of questions which the business things that you can ask, they can program the answers automatically for this as well. And this relates to a minimum amount of functionality, because the chatbot cannot really think and grow and understand from what the customer asks. So it already knows the question, it basically maps that to an answer, and it just gives an answer. So it's basically a give and take policy where the bot might not be learning anything. And then coming to the current bots of today's world, these implement task level automation. So basically with task level automation, they know what they're seeing and they can understand the context between the tasks and all of the system requirements that exist. So basically, if you're asking a question, the simple question again saying where my order is or why my payment has failed, it'll already have a system context there in place, saying this is the question, this is the answer, give the customer the answer. With task level context, it will know what task has to be done to arrive at that answer. So it's not like take a question, find the answer, give you the answer. So it's take a question analyze and then give you the answer. So with current bots, that analyze part that exists right now. So the communication level is intermediate. So probably 7 out of 10 times or 6 out of 10 times, you will not figure out that you're talking to a chatbot. So that's how interesting and intimidating it's become right now, that it's getting good. We're getting there. And customer help. Well, current bots basically have been put into a use of, for example, project support, customer service, front desk management, and much more. So if we have to talk about the future bots will have multiple levels of communication which are cross-linked with each other. What this means is that at the end of the day, when you are talking to a bot, you can ask the bot to get some task done for you. You can ask it queries and get questions. It can perform analysis for you and much more. And all of this coincides to one thing called a service level automation, basically, which will ensure that all the tasks which are to be done manually, all of these can be automated easily as well.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it understands system level context as the traditional bots. It understands task level context as the current bots we have in place. And the best part is it'll get people context as well. So it'll understand who you are, and it can start generating and recognizing patterns in between people, what people are requesting for, why they're requesting for, who requested it. So out of billions of people across the globe, if you keep asking and training your future bots on a certain number of questions, or you keep asking it something, it'll recognize that the question is coming from this particular person. So that's how powerful it can actually get. And of course, in the future as well, there are multiple concepts such as bot OS and master bots. So bot OS is basically an operating system which is completely revolutionized and revolving around the usage of bots for your use as well. And master bots are basically bots which can control a certain number of chatbots under them and control some amount of context, some amount of functionality which are given to them to handle, basically. So they are the bots which will handle other bots, something like these. So something like this. So again, when we have to get a quick vivid comparison, I thought it was very vital for you guys to understand this about the traditional, current, and the future bots as well. Going to the answer of how does a chatbot actually work? Well, there are two types of chatbots when you have to think about it. One is something called as rule-based bots, and the other one is called as self-based bots. And the other one is basically self-based bots. So when we talk about rule-based bots, as the name suggests, there are some rules on which these bots will basically work on. You ask a simple question such as where is my order? Your bot will recognize the word where is and probably order. And this is a rule which is programmed in the backend, which says when you find all these keywords, just give them an answer saying, hey, your order is here. Your order is on the way. Your order is delayed, whatever. So you cannot ask any complex queries to a rule-based bot because it will not have rules in the backend which will basically help it understand. So think about rules if they are like a book, all right. So it will basically look into this book for an answer. If it can find it, it will tell you, or else it cannot. So it's as simple as this. And most of the time, the training of these bots are really simple, and it is not complex. And what this coincides to, it basically means that you can ask simple queries, get simple answers. If you ask complex queries, it might fail. And now coming to self-learning bots. Self-learning bots will make use of concepts such as machine learning. It will make use of concepts such as deep learning to basically understand what you're trying to tell the bot. It's not like there's a book, it will blindly refer the book and give you an answer. So it'll try to understand why you're asking this, what you're asking, and how best it can think it can give you the answer. So this line that I just said, this is very important for self-learning bots, because this is exactly what makes it highly efficient, and it is basically a trick to learn and to basically fool you into thinking that it's a human being, and that of course is very good for us. That is what we're looking for here as well. But then training a self-learning bot will take a lot of effort because it is a very complex process to think about working with a lot of data. It will be terabytes worth of data for a very simple response generation as well. So training it with a lot of data, helping it analyze, and helping the bot give us an answer based on an analysis rather than a textbook definition is something which is very complex as well. So these two are the basic types of bots which we work with in today's world. But then when we have to talk about self-learning bots a bit, because again, when you're talking about artificial intelligence, when you're talking about machine learning, there are again two more types of self-learning bots. So they're called as generative bots and retrieval based bots. So let me talk about generative bots for a second here, and it's going to give you an answer. So basically you might be wondering, okay, so if I ask it any complex query, will I get an answer because it's using artificial intelligence? Well, the answer is no, because even though it can do word to word analysis, there are certain limitations here which will not allow it to give you an answer every single time. So in that particular case, generative bots actually have the upper hand when we think about retrieval based bots, because retrieval based bots are again, they have predefined responses. So there are so you ask a question, it will go somewhere, pick up your answer and give it to you. So it's content based, no, so it's context based. With context based, it knows what you're asking, but it does not know. So it does not know how it can improvise its answer to basically give you the best answer out there. It knows that it can give you an answer, but it doesn't know how it can give you the best answer. For that, you need generative bots. Your generative bots will analyze the accuracy. It will analyze the likeness of its answer, and then it will give it out to you. So with self-learning bots, these are the basic examples. I'll quickly repeat it. So with generative bots, it knows and analyzes your answers before giving it out. With retrieval based bots, there are certain predefined responses where it just picks it up and it learns a little bit on that and then gives it to you. With generative bots, there's a comprehensive analysis which goes on with every single word that you put in, and then it learns. With retrieval based bots, it will look and hunt for a context, and once it finds that context, it will go back to the responses which are stored again, and then map those contexts based on responses and give you those answers as well. So on that note, next we'll have to check out something called as the chatbot chart. So basically, when you're working with a chatbot, right? So there's a good chance if you're either talking to the chatbot via messenger, you're communicating via website, or you're probably using a mobile to talk to Siri, Alexa, or all of the chatbots that we discussed. So as a human, you will be giving it certain inputs, and the chatbot will give you an output. So whatever inputs you give, right, so it will go into something called as a chatbot server. So the chatbot server will have three important things if you're talking about self-learning bots. So it will have certain knowledge, and this is like the book that it will go on to hunt, and it will have rules is basically like an index to the book saying this is where you need to look for the answers in the book. And then of course it will have machine learning, it will have artificial intelligence saying learn to understand these rules and learn to understand where you can apply these rules to find the context in the knowledge. So it's something like that. And to do all of this, it needs a lot of data, right? So there are numerous data sources across the world. It can be something as simple as learning from Twitter, all the way to learning from certain studies which is like probably 35,000 pages long or whatever. So everything from simple to complex data sources, it might be on the cloud, it might be social media, or wherever it is. Your chatbot server will pick up all of these data sources. It will try to understand what knowledge can it learn based on machine learning, and what rules it has to apply, so that it can arrive at this stage where it knows stuff. And then it's not important that it has to know stuff. What's important is that it has to find a way to convey all of this it knows in a human way, imitating a human, right? So that is again an important thing. So basically this is like a one picture one stop solution to understand the basics of how a chatbot would work. On that note, we can actually go on to building our own chatbot. To do that, there are certain things we need to walk through as well. And the first thing is prerequisites when you're working with Python. There are two amazing libraries, and two among, let's say, thousands of beautiful libraries of Python, because I'm a huge fan of Python for the reason that it has amazing libraries. So there are two main things which we will be using to build a chatbot, and it's pretty common and obvious as well. So we have scikit-learn, which is basically used as the machine learning library for Python, and there is NLTK. So NLTK is again another amazing library, as we'll be walking through step by step to understand what makes NLTK what it is. So it's an amazing natural language toolkit. That is what NLTK stands for, and it's widely used in today's world to ensure that they can make a very good chatbot as well.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So to give you a quick revision of what NLTK is actually used for. So this natural language processing, this natural language toolkit is actually used to process certain human language data. Well, mostly it's English because again English is a widely used language. So it is basically used to understand how this chatbot can be built by making it understand the words. See, for example, you will know what an apple is, you will know what a ball is, you will know what a cat is. This is because from your childhood till today, you've been taught A for apple, B for ball, C for cat, or whatever it is. So you have been programmed over the years where you know what all of these are, but then as soon as your computer sees a cat, there's a good chance that unless it has any training, it is just a text which says cat. It will not understand that it's seeing a cat or that the context is a cat. So to teach it that context, saying whenever I type a cat, you think of cats, so that aspect is basically where NLTK comes into play. And to do all of this, there are many concepts. There's classification, there's tokenization, there's stemming, there's lemmatization, there's parsing, and all of this. But to get to all of that, of course, we'll be checking out all of these. The first thing you need to do is you need to install NLTK. And to install NLTK with Python, there is a very simple command with pip, the package manager. It's pip install NLTK. And once you clear this step, you have NLTK installed and you can work with it. So coming to the terms that we have put down there, classification. So classification, when you're working with data, basically is where you help the chatbot understand what type of data it can see. For example, there are certain words which are used very commonly. They're called as stop words. So for example, the, is, that, was, all of these are stop words which will arrive, and you will be using it multiple times in a given sentence, right? So I might have used the word like 100 times or more than that in this live session as well. So you need to understand to classify what words are very commonly used, what words are not very commonly used, and more. And then tokenization. So tokenization is this process where each of your words are actually broken down into events and so tokenization is this process where each of your words are broken down into single entities, and these entities are called as tokens. Tokens are basically the input to the chatbot that you give, saying, hey, you know what, this is a word, understand what this means. And then coming to stemming and parsing, we're going to check this out in a bit of detail in a second now. So to make your bot understand text, the problem here is that your machine, when you're using machine learning, when you're using artificial intelligence, deep learning, whatever it is, it will require some numerical features to work with. It will require numbers, it will require vectors, it will require matrices to work with. It does not require strings, and with the help of strings it cannot learn. So how do we solve this problem? Well, let me tell you with pre-processing how basically the text pre-processing works. There are two things. One is case conversions and the other thing is tokenization. So again, before we delve into tokenization and case conversion, let me repeat why we are doing this. So when you're using machine learning, when you're using artificial intelligence, your bots or whatever you're building, it will require to understand zeros and ones. It will require numbers to understand, and it cannot work with text. So we need to find ways to convert our text into these numerical features, right? And hence we're doing the text pre-processing. Okay, so coming back to the methods. So there is case conversions and tokenization. With case conversion, for example, lower cases might mean different and upper cases might mean different. Let me tell you. So when you're starting out a sentence, you always start with an uppercase, but in the middle of the sentence, you will not be using any uppercases unless it's like a proper noun and certain reserved keywords, right? So your computer needs to understand this, and basically to do all of these, we will be converting everything into one case, usually when you're working with building a chatbot, because when you're thinking about keeping the same case and helping your machine teach, it becomes a very, very, very complex process. So to keep it very simple, we'll have the cases converted. So everything in a sentence will either be lowercase or everything in a sentence will be uppercase. So that's why we need case conversions. And when we talk about tokenization, as I just said, you'll be breaking down your sentences, your words into a list. So that's basically sentence tokenizers and word tokenizers. With sentence tokenizers, each of your sentences will be broken broken down into singular entities. With respect to word tokenizers, each of your words are broken down into structured entities called as tokens, and these form as the input. So when we have to talk about how it works in NLTK, we have something called as the NLTK tokenizer. And since we're working with the English language out here, so there is a pre-trained tokenizer which will already understand what you're typing in, and it's basically the pre-trained punct tokenizer which is present as a part of the NLTK library. Alright, so one important thing you need to understand is that your text might contain a lot of things which is not required. For example, there are a lot of numbers or letters which you might not make sense of, or your computer might not sense of. So basically we need to remove all of these words, and this process is called as removal of noise, because this is noise through which it will not help us in any way building our chatbot. And then stop words, as I just mentioned, right? So is, was, and, the, all of these are very common, very common stop words which need to be removed to ensure that your chatbot is not confused when it's working with words. So stop words have been removed, or they are pretty much categorized differently. And then stemming and lemmatization is where things starts getting really nice, because when you're thinking about stemming, so stemming is basically a word which is derived from its stem. So let me give you an example of a stem word. A stem word may be learn, Learn, learn. So when you're talking about stemming these words, think about the concepts such as learnt, learning, learned, learn. So these four words, right, which basically has something in common, which is Learn. You can have Learnt, Learned, Learning, learning. So learn is common in all of these words. So learn becomes a stem word through which you can give context to all of these other words, right? So that is stemming. Now talking about lemmatization is a little bit different from stemming, and here is why. Here we talk about context rather than the words itself. See, for example, if I tell you good, better, and best, it gives you a positive connotation, and it gives you a general meaning of something is good, right? So good also means it's good, better means it's good, best means it's good. So you need to make your computer understand that good, better, best all have a positive connotation, and it means something is good in general. So lemmatization, all of these lemma concepts that we talk about, is basically this, giving your context some meaning. So I hope I was clear with stemming and lemming. Stemming is where we use these stem words and basically derive something out of each word's process, processing, processed, all of that. With lemmatization, it's basically context based learning, good, better, best, where you're giving meaning to the words you're checking about. And then talking about the input to a chatbot, it's of course when it has to learn, it needs input, right? So basically as I just mentioned, since it cannot understand strings directly, all of these strings are converted into numerics. So basically we are doing this by converting text into numerics based on their requirement. If they're required, they're considered. If they're not required, they're not considered. And you might be wondering why a concept like this is called as the bag of words. Why can't you just call it input? So it's called bag of words because here we're trying to consider the words which have come in. So we do not care about the order of words which come in. So if there is a sentence which says I like Intellipaat, with the bag of words, think of it like you're dumping the words in the bag where you do not care about the order. For example, I like Intellipaat can become Intellipaat like I like Intellipaat I, or whatever order it is. So your sentence might not make sense grammatically, but all the words are there in a jumbled order. So it's like taking these words and putting them in a bag and jumbling them up, or even just putting it inside without any order. That is why it's called as the bag of words. And now coming into how it is basically processed. Let us take a raw input, and this raw input is something like a sentence which says I do not like chocolates. Of course there's not a lot of us who do not like chocolates, right? So ladies and gentlemen, again, let's keep this session interactive. So head to the comment section and put in your comments so we can understand and help each other out better here. So again, coming back to this, with respect to raw input, it's let's have a sentence which says I do not like chocolates, and you want your computer to basically understand I like chocolates part of it. So I do not part, we do not want it. Are you getting it? So your input is I do not like chocolates. You want your machine to pick up I like chocolates, and this is how it does. So I is required, so it becomes 1. Do not is not required. So do becomes 0, not becomes 0, like is required, like is 1, chocolates is 1. So whatever words you want to be picked, those words are 1, and whatever words you do not want it to be picked, those become zeros, right? So this is how, in a very, very simple way, it's called as vectorization. And of course, each of these entities will be separated by a comma. But then just to keep it more readable for you guys, I'm just showing you a general way on how an input can be vectorized and what is the result that we can obtain by converting this grammatically correct or incorrect sentence, for that matter as well, into a mathematical vector. All right, so I hope this is clear.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
And with that, we need to check out something called as the TF-IDF formula. So guys, again, if you know what TF-IDF is, head to the comment section and let us know. So what is a TF-IDF? Well, it's actually an acronym for term frequency and inverse document frequency. Well, fret not if you don't know what this means, as I'll be explaining all of this. So with respect to bag of words that we just discussed, right? So when you have an input which is a bag of words, it'll have a lot of words. So basically I told you we are ditching the order and we're just considering a lot of words, right? So that is the advantage and the disadvantage. The advantage is that there is a lot of words. The disadvantage is that, you know, your bot will not have a lot of information there. So there is a difference between having a lot of words and helping your bot understand all of these words, right? So this is where bag of words has a little bit of a downside which can be fixed, and it's fixed by giving it context and making it understand about these words. And to do that, we have something called as term frequency and inverse document frequency. So let's talk about term frequency before. First, basically, term frequency, when we're working about it, you need to understand that we need to find out how many times the term is occurring. So this might be because of classification. We need to understand stop words. We need to find out how many times one word is occurring. So if you have a sentence which has the word apple like 100 times, let's say it's a 10,000 word essay and you've used the word apple 100 times, you know it because probably you have used it. Now to make your computer understand that there is apple there 100 times, we need to find out how many times it has occurred divided by how many total terms there are in the document, right? So this will give you a term frequency saying, for example, if we do 100 by 1000, so there is a chance that 0.1% of every single time your word apple is occurring. So if you have like 1,000 words which says apple 1,000 times, and then if you want to search the term frequency of apple, what do you think it is? So it's going to be 1,000 itself, right? Because there is nothing else in that. So I'll give you an example again in the next slide. You will get a lot of clarity on this as well. For now, you need to just know that the formula of term frequency, where we are trying to find out how many times a term occurs, is basically the number of times it appears in a document divided by the total terms in that document as well. Now if we talk about IDF is basically inverse document frequency. So inverse document frequency is the number of times that your word has not occurred. What is the rarity of words that has basically occurred in your document as well? So for that, we'll be using a logarithmic formula. It's basically 1 plus log of x by y, where x is the number of documents that you have where you're checking this, and y is the number of documents documents where this term occurs. So when you do a logarithmic inversion of this number of documents by the number of occurrence of the term, you will get the rarity of how many times the term has not occurred there. So let's walk through this with an example. On the left, I've kept the formula so that you can refer to it while we calculate on the right. So let's say right now we have an essay or we have a document which we also call as a corpus. So corpus is basically the input document. So let's say we have a document which is 500 words and in this 500 words the word call appears 10 times. Alright, so this is a generic document, there is 500 words and the word call appears 10 times here. So what does the term frequency of this mean? So term frequency again is the number of times a term appears, which is 10, divided by the total words, which is 500. So 10 by 500 will give a term frequency of 0.02. So for every word that you have written in this document, there is a 0.02 times chance that you've used the word call. This is term frequency visualized. And then if you have to talk about IDF, consider this. Let's say there are 10 lakh documents out there and the word call now appears in just 60,000 of these 10 lakh documents, right? So 10 lakh documents, the word call appears in only 60,000 documents of these 10 lakh documents. Now to find out the inverse document frequency, basically as I just mentioned, we're going to take the 10 lakh, which is the number of documents, total documents, and divide it with the documents where we have the term which we require. So IDF in this case becomes 10 lakh divided by 60,000, which gives us a value of 1.22. And now if you have to give context to your machine, if you have to tell your machine, hey, this is the word, this is the context, this is how many times it occurs, there's something called as TF-IDF weight, and this weight is basically the product of term frequency and the inverse document frequency here. So as soon as we multiply all of that, we'll get a number which is 0.0244, and this number will basically give context to your machine, saying this is the weight of this particular term in these documents and in each of these particular documents as well. So your word in every document, in total number of documents added together, clubbed, and after you find the term frequency and the inverse document frequency, you will arrive at the weight of it. So on that note, we've seen all of these theoretically and we need to now check it practically. So let me quickly jump to the practical aspect of how we can go on to check it. So here I am making use of Google Colab. Google Colab is basically a Python Jupyter notebook which is hosted on their Google Cloud platform. So this is where we will check out a very simple demo use case of how we'll go on to work with chatbots by using Python. Here again, as we have walked through in the theory, we'll be making use of NLTK. NLTK is the natural language toolkit, which is a beautiful library to work with when you're thinking about Python. And of course, as always, whenever you're working with Python, it is a common practice that you import all the libraries that you require at the start of it. So in this particular case, we are importing NLTK, Numpy because you have to work with numerical computations. We're importing random because we'll be randomizing a couple of aspects here, and we're importing string. So string is basically a library which will help with string processing techniques in Python as well. So if you are on a native Python environment which is different from Google Colab, you might have to install all of these before using it. To do it, instead of import, just type pip install, pip space install space NLTK, pip space install space Numpy as well. So with Google Colab, all of this comes pre-installed, and that's the reason all we have to do is we have to just import them and it starts working. So after importing all of the libraries, the first step is to make sure that there is some data through which we can teach the chatbot, right? So this is where we'll have a file. This file or this document is called as a corpus, and with this document, this is where all the data resides in which your chatbot can understand. All right. So to do that, first we'll be using the file function. We'll be using an open function where the file we have, we'll call it as chatbot.txt. Of course, you can call this anything else you want. You'll be opening it in the read mode because you're reading it, and if there are any errors, we're going to ignore those errors for now. So after reading these document, we'll be converting it to lowercase because, as I told you, case conversion is very vital for data pre-processing, and we will download the punked part of the tool case because we're working with English language and this is already a pre-trained library that is present, right? So this is a one-time download that you'll have to do. And of course, we have something called as WordNet. So WordNet is basically a database which consists of relationships in between each of these words, all right. So with WordNet you will have an access to like 200 languages. With respect to Punkt, it'll give you the pre-trained library for English as well. And in fact, the WordNet is it's a pretty old library of data. It is present with us from the 1980s as well. So that's a fun fact for you guys. And now we spoke about tokenization as well, right? So we need to tokenize this to be each inputs of words and be inputs of sentences. So basically we are using nltk.sent underscore token to basically convert the sentences from the raw data, and word underscore tokenize to basically convert words. So here sent underscore tokenize is the sentence tokenizer, word underscore tokenize is basically the word tokenizer. All right. So again, as you can see, if you just put your mouse on that, you will basically find out what it is. So you can actually go on to the definition of it and find out about it a little bit as well. So now to do this, we need an input. So we haven't yet talked about what input we are doing, right? So in fact, let's go to a Wikipedia page and give chatbot. So there is a Wikipedia page called Chatbot, and this is like a basic input to our model to train. So what we'll actually do is we'll take everything here, just hit Control A, in fact copy all of this and basically put it to a file. Create a file called as chatbot.txt and just put all of this there. So you will have something like this, and this is like a text file through which your chatbot can learn something. All right, it's simple as this. After that, save it, call it whatever you want, but then you have to remember the name because you have to input this, right? So now coming back to the input, as soon as I hit play, now it's going to say an error because it does not know where my chatbot.txt is. It's on my desktop and we're running it on the Google Cloud. So let me quickly upload the file here, chatbot.txt, and as soon as this is uploaded, I can run it again, and now it sees my chatbot.txt file. It will convert everything to lowercase. It will download everything that's required. It will convert it into sentence tokens. It will convert everything into word tokens. So we did all of this by making use of 5-6 lines of code, and it's this simple, guys.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now, coming to the next aspect of the same step 2, basically here is where we'll be printing an example to see our sentence token and word tokens to see if it has worked, right? So now, as you can see, I just hit print and we're trying to just print a sentence token here, and we're trying to print a word token here as well. So whatever sentence here, you can give any sentence for checking here, and then you can just paste to see if this this sentence, which is the raw input, if it is converted into a token or not. So as soon as I hit play here again, it is obviously converted into sentence tokens and word tokens as well. So coming to the next step is basically pre-processing and handling your data. So as I said, WordNet is basically like a dictionary out there with more than 200 languages, and where it understands your words. Now we discussed about lematizer. With respect to lematizer, we give this word certain context, right? So that's basically what we're doing out here. With lemmatization, we are giving it context. You can think of the example which I just mentioned: good, better, and best. There as well, right? So basically step 2 is all about that. And then coming to step number 3 is basically where you will be programming a greet response. See, for example, with any chatbot, right, be it Alexa, be it Siri, be it Google Assistant, whatever it is, as soon as you say hi or hey, it will not tell you something which is very vague. It'll greet you back. It'll be very nice to you, and it'll say, hey there, what's up, or how's it going, whatever it is. It's like a human conversation. So when you say hi to someone, they'll not just nod their head. 90% of the time they'll say hi back to you, right? So to give it that human touch, step 3 is all about giving greeting inputs and responses. So if you give it a response saying hello, hi, greetings, sup, what's up, hey, or whatever it is, it will give you a response back with hi, hey. It'll nod its head. It'll give you hi there, hello. It'll say I am glad you're talking to me and all of that. So you can change these inputs and these responses to whatever you want. So basically this is not very complex. If it sees any of these, it'll give you a random input of this. This is where we require the random function that we inputted, right? So you might be wondering where it's not like you give hello and it tells you hi every single time. You can say hello 10 times and it'll give you 10 different outputs from this response here. So as soon as we run this, we are taking the inputs and we're generating random greeting responses and printing to the screen. Now coming to step number 4. Step number 4 is where we start giving out responses. So to give out certain responses, so you need to understand that we'll be using the TF-IDF concepts. So I hope you guys remember the term frequency concept, the inverse document frequency there. Now we have to import all of these, right? So basically these are all part of scikit-learn. It's part of the concept called as the feature extraction, which is based on textual inputs. So we're going to import that, and you might be seeing the second thing which is being imported here as well. So the second thing which is imported is something called as cosine similarity. So cosine similarity is a part where you'll be checking out and teaching your chatbot about how to find certain behavior inputs and how to find and understand what your difference is and the similarity is in between what the user types and in between what document is present. Do you understand that? So in our case, the document is the Wikipedia article that we took up, and the user input might be something where, you know, it has to learn and map this user input to the document. So that is where cosine similarity is used as well. Of course, you know, we can discuss the TF-IDF concept or cosine similarity in a lot of depth, but then I do not want to overwhelm you guys with loads of information here. All right, so we're trying to keep it simple, and as you can see, it's just a couple of lines, and you know, we have almost built our chatbot. So after generating these responses, we need to write a function for concepts such as where, you know, we are thinking of stop words, we are pretty much, you know, removing all these stop words, understanding it, and we haven't talked about what happens if your chatbot doesn't understand you, right? So if it sees stop words, it knows what to do. If it sees a greeting message, it knows it has to greet you back. But then if you type random stuff there, it has to give you a response, right? So it cannot stay idle. So basically we are trying to print a message here saying, hey, I'm sorry, I do not understand whatever you have typed. So with respect to this function, it's pretty straightforward. It's pretty easy. If it doesn't understand something, it'll tell you it doesn't understand you. And step 5. Yes, step 5, or probably we can call this step 6 as well. So this is the last step where you will be programming the start point and the end point. So starting when you run the chatbot, instead of greeting it, it will probably say, hey, my name is this, I can help you with this, and you know, I want to quit. No, and if you want to quit, you know, just type something, you know, type bye-bye or whatever. So in fact, there's actually a tiny mistake here which I will clear, which is a spelling mistake which is can. I mean, come on, everyone does spelling mistakes. All right, now so basically what I'm trying to tell you guys here is that as soon as your chatbot starts working, it'll print out this message. It'll say, chatbot, hi, my name is samplebot, I can help you with chatbots if you need. This will be anything else, because you know, we randomly picked a Wikipedia article for chatbot. You can pick up anything. It doesn't have to be a Wikipedia page. You can make it learn on a blog of your choice and then give you responses to the questions you ask. And then if you want to come out of the loop, this is basically working on a while loop where it's constantly waiting for your input. If you want to quit, you can just type bye, and if it sees a bye in the input section, it'll say thank you or thanks, and it'll basically quit. So as soon as we go ahead and run this, you know, it says, chatbot, my name is samplebot, how can I help you? You know, if you want to quit, type bye anytime. So let's say hi to our chatbot. It'll say hey. Again, as I mentioned, it is a random response that it is giving to us based on the greeting pool, right? So I can say hi again, and it will say something else apart from hey. So it says hi there. Another time, let me say like hey or something. It'll say something else. So as you can see, it's not giving you the sample a response that it is supposed to give. So it is generating random responses and it's giving it to you out there. Now let's just say we want to quit. All you have to type is bye, and as soon as it says bye, it's like, okay, thank you for talking, bye bye. And it's pretty simple like this, right? So even this we achieved with like 5 or 6 simple steps in Python, which is really amazing. And in fact, let's run again. So in the chatbot article, there's this person called as Alan Turing, who is considered to be the father of intelligent machines. So let's ask the chatbot, who is Alan Turing. Let's see if it can find that out. Of course, the responses will be pretty vague. It will not be very accurate. It says there is a stop word which came here as well. Of course, apart from that, it gave you the answer. It says Alan Turing was a British scientist and he was a pioneer in computer science. See, I asked it a question saying, who is Alan Turing? It figured out that I'm asking a who question. It found out everything about Alan Turing and it gave me a sentence output there saying Alan Turing was a British scientist and a pioneer in computer science as well. So basically, this you might be expecting like a 2-liner, 3-liner output, but our chatbot, this simple chatbot, is intelligent enough to find this for you, and it's amazing. So basically, we didn't write hundreds of lines of code here. We probably wrote like 100 lines in total, or less than that, in fact, to build our own chatbot to do this, right? So it's as important as this, and it's as fun as this. So we can check out a case where it doesn't understand. So if I go on to type some random stuff, it'll say, so, see, I'm sorry, I did not understand you. So this pretty much covers all of the cases. We checked out greeting, we've generated response where it does not understand you, and it pretty much analyzes your document and gives you a valid response of whatever is in the document as well. So you can type something else as well which is not in the document, and it will say I do not know, because it has not gone through these words in the document there as well, right? So again, pretty simple, and I hope this demo was pretty much understandable to all of you guys. So there are many other complex demos which I can use and show with respect to NLP, probably by making use of very, very complex data, and by creating like a very nice use case, by making use of a very nice user interface, by using TK inter and whatnot. But then again, to keep it simple, so this was what I had in mind.
Right, so we'll start off with the questions. So this is our first question over here. So we have this diamonds data set, and we are supposed to extract only those rows where the price value is greater than 1000 and the cut is equal to ideal. So this is our data set over here. So we'd want to extract only those records where the value of the cut is equal to ideal, and this price which you see, and this price needs to be greater than 1000. And we are supposed to implement this with R. So let's do that. Now this diamonds dataset is a part of the ggplot2 package. So first we'll go ahead and load this ggplot2 package. So I'll use the command library of ggplot2, and then let me have a glance at this dataset. So I will use view of diamonds, and this is our diamonds dataset over here. So this is our dataset which comprises of these columns: caret, cut, color, clarity, depth, table, and so on. So our task was to extract only those records where the price value was greater than 1000 and the cut was equal to ideal. And to do that, we'll be using the deployer package. So I'll be loading the deployer package. So deployer is basically a package which is based on grammar of data manipulation. And this is the command to extract those particular records. So first, what I'm doing is, from this diamonds data set, I'll be using the filter function which is part of the deployer package. And with the help of this filter function, I'm giving two conditions inside this. So the first condition is the price needs to be greater than 1000. After that, I'll use the AND operator, and then given the second condition. So the second condition is the cut needs to be equal to ideal. And I'll store the result in diamonds 1000 ideal. I'll hit enter. Now let me have a glance at the result. View of diamonds 1000 ideal. So you see that there are 14,700 entries in total where the cut is equal to ideal and the price of the diamond is greater than 1000. So out of the 53,940 records, we have filtered out 14,700 records where the cut is equal to ideal and the price is greater than 1000. Now we have our second question over here. So on the same diamonds dataset, we are supposed to make a scatter plot between the price and the caret. And we are supposed to do that using the ggplot2 package. So over here, the price needs to be on the y-axis and the caret needs to be on the x-axis. So this column, it needs to be on the x-axis, and then we have price. This needs to be on the y-axis. And the color of the points need to be determined by the cut value. So again, let's head back to R and let's implement this. So again, to implement the scatter plot using ggplot, we are supposed to load the ggplot2 package. Alright, and this would be a command to make that particular scatter plot. So ggplot2 is something which is based on grammar of data visualization. So ggplot helps us to stack multiple layers on top of each other. So first off, we'll start with the data layer. On top of the data layer, we'll stack the aesthetics layer. And on top of the aesthetics layer, we'll stack the geometry layer. So first, we have the data layer where we'll give the name of the data frame to this data attribute. And we are working with the diamonds data frame. So the first layer is diamonds. After that, we will map these columns onto the aesthetics. So using this aesthetics attribute inside this ggplot function, I will map this caret column to the x aesthetic, and similarly I will map this price column onto the y aesthetic. And as the question stated, the color of these points need to be determined by the cut column. So again, I'm reiterating it. Caret is mapped onto the x aesthetic, price is mapped onto the y aesthetic, and cut is mapped onto the color aesthetic. And once these two layers are done, we are supposed to build the final layer, which is basically the geometry. And since we are supposed to make a scatter plot, we'll be using the geom point geometry. And this gives us the required scatter plot. Let me zoom this. So as we see over here, price is mapped onto the y-axis, caret is mapped onto the x-axis. And these colors which you see, these basically denote the different cut values. So yellow, it denotes the ideal cut, and this purple which you see, that denotes the fair cut. So we see that if the cut is fair, then mostly the price of the diamond is higher and also the caret value is higher. And when it comes to the ideal cut, we see that the caret range of the ideal cut, it starts from 0 and it's mostly till 3 or 4. So this is the sort of interpretation which we can make from the scatter plot. And then we have our next question. So this time we are supposed to introduce 25% missing values in the iris data set and impute the sepal length column with the mean, and similarly impute the petal length column with the median. So this is the iris dataset. So again, let's head back to RStudio and perform these tasks. Let me have a glance at the iris dataset first. View of iris. So this is our iris dataset, which comprises of these 5 columns. So we have sepal length, sepal width, petal width, and species. And our first task is to introduce 25% missing values in this entire dataset, and that'll be totally random. And to introduce missing values, we'll be using the Miss Forest package. So let me load the Miss Forest package using the library function. Now, this Miss Forest package comprises of this prod any function. And using this prod any function, I'll be introducing 25% missing values. So this basically takes in 2 parameters. First is the data frame or the object into which we are supposed to introduce missing values. The second parameter is the percentage of missing values that we'd want to introduce. So in this iris data frame, we are supposed to introduce 25% missing values. So I'll give the value of 0.25 and I'll store this in a new object and name that object to be iris.mis. Now let me have a glance at this modified dataset. View of iris.mis. So this is a new data frame which comprises of 25% missing values. Now I'm supposed to impute this sepal length column with the mean and similarly this petal length column with the median. And to impute those 2 columns separately, I would require the HMISC package. So I'll load this package now. Library of HMISC. And this package comprises of the impute function with the help of which I'll be imputing different columns. So first I'll use the width function, and this takes in 2 parameters. First is the data frame which consists of missing values. So in this data frame we are supposed to impute the missing values. So this is the iris.mis data frame and this is the first parameter. Next we'll use the impute function And inside the impute function, again, it takes in two parameters. First is the column which we want to impute. Next is the function by which we want to impute this column. So I want to impute the missing values in the column with the mean of this column. So wherever you see any values in this column, all of those values would be replaced with the mean of this column. And I'll store the result back to this column, which is iris.mis $sepal_length. I'll hit enter. Now let me have a glance at this imputed dataset. So view of iris.mis. So you see that wherever we had the any values, all of those values have been imputed with the mean. So this 5.85562 which you see, this is nothing but the mean. So initially there was an any value over here and that has been imputed with the mean. Similarly, there was an any value over here and that has been imputed with the mean of this column. Next, similarly, we are supposed to impute this column with the median of this column. So let us do that. So again, I'll use the with function and then pass in this data frame with the missing values. After that, I'll use the impute function and I am supposed to impute this petal length column, and the imputation would be done with the help of the median function. So wherever there are any values, all of those any values would be replaced with the median of this column, and the final result, I'll store it back to the same column. I'll hit enter. Now again, let me have a glance at the modified data frame. So view of iris.mis. So this is a modified data frame. So this 4.2 which you see, this is nothing but the median of this column, right? So wherever there were any values, those any values have been replaced with the median of the petal length. Now let's head on to the next question. So what do you understand by linear regression? Well, linear regression is a supervised learning algorithm which helps us in finding the linear relationship between two variables. So one is the predictor or the independent variable and the other is the response or the dependent variable.
Just a quick info guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we try to understand how does the dependent variable change with the independent variable. So linear regression is a supervised learning algorithm which helps us in finding the linear relationship between two variables. So one is the predictor or the independent variable and the other is the response or the dependent variable. And we try to understand how does the dependent variable change with the independent variable. So let's say there's this telecom company called as Neo, and now the data scientist at this company wants to understand if there's a linear relationship between the monthly charges incurred by the customer and the tenure of the customer. So he collects all of the data and builds a linear model between the monthly charges and the tenure. So here, monthly charges would be the dependent variable and tenure would be the independent variable. And in linear regression, there could be more than one independent variable. So if there's just one independent variable, it is known as simple linear regression. And if there's more than one independent variable, it is known as multiple linear regression. So guys, this is the underlying concept of linear regression, where we have one dependent variable and multiple or a single independent variable, and we try to understand the linear relationship between the dependent variable and the independent variables. So next, we're supposed to implement this simple linear regression in R on this empty cars dataset, where the dependent variable is this MPG column and the independent variable is this displacement column. So again, let's head back to RStudio and implement this simple linear regression. So this is our empty cars data frame, which comprises of all these columns. So we have MPG, the number of cylinders, displacement, horsepower, DRAT, weight, CUSEC, VS, AM, gear, and carb. So as the question stated, MPG is our dependent variable and displacement is our independent variable. And we want to try to understand how does MPG vary with respect to the displacement of this column. So now, before we go ahead and implement the model on top of this data frame, we are supposed to divide this data frame into training and testing set so that the model does not overfit the data. So what happens when we don't divide the data set into training and testing sets is it overfits this data set. And when we give it new data, it'll fail miserably on that new data. So that is why it is always necessary to divide a data set into train and test sets. So let's go ahead and do that. And to divide a data set, we would require this caret package. So let me load up this caret package, library of caret. And this caret package comprises of the create data partition function. Now, this create data partition function would give me true or false labels. And this create data partition function comprises of these parameters over here. First is the column which determines the split. So that is obviously the MPG column. And then we are supposed to give in the split ratio. So I am giving the split ratio would be 0.65. That is 65% of the labels of this column would have the true label, and the rest 35% of the records would have the false label. And I am storing this into the split tag object. So again, I'm reiterating it. So I am taking this empty cast $mpg column data set, and 65% of the records would have the true tag associated with it, and the rest 35% of the records would have the false tag associated with it. And I'm storing this result in split tag object. Now, once I have the split tag object ready, what I'll do is from this entire empty cast data frame, I'll select all of those records where the split tag value is true, and I will store those records in the training set. Similarly, from the empty cars data frame, wherever the split tag value is equal to false. So if I just give in split tag, it'll have all of the true values in it. And when I put in the minus symbol in front of the split tag object, it'll contain all of the false labels. And I will select all of these records and store them in the test set. So now we have our training and testing sets ready. Now let's have a look at the number of rows in training and testing set. So I'll type in n row of train. So see that there are 23 rows in the training set. Similarly, I'll type in n row of test. And now we see that there are 9 rows in the testing set. Now we'll go ahead and build a model on top of the training set. And to build the simple linear model, we would require the lm function. This lm function again takes in 2 parameters. First is the formula. So over here, the formula is mpg tilde symbol displacement. So whatever column we give on the left side of the tilde symbol, that is taken as the dependent variable, and whatever columns we give on the right side of the tilde symbol, all of them are taken as the independent variables. So this time mpg is our dependent variable and displacement is our independent variable, and we are building this model on top of the train set. And we'll store this result in mod underscore empty cars. So now that we've built the model on top of the train set, it's time to predict the values on top of the test set. So for that purpose, we'll be using this predict function, which again takes in 2 parameters. First parameter is the model which we've built, and the second parameter is the data frame on which we want to predict values. So we want to predict values for the test set, and I will store this in predict empty cars. Now let me have a glance at the predicted values. So head of pred empty cars. So these are the predicted values of MPG for all of these cars. So Mazda RX-4 WAG, the mileage predicted for this car is 22.55. The mileage predicted for Valiant is 20.04. The mileage predicted for Mercedes is 18.08, and so on. So this is how we can build a simple linear model on top of this empty cars dataset. So now we'd have to calculate the RMSE value for the model built. Now when we actually build a regression model, it predicts certain Y values associated with a given X value. But there always is an error associated with this prediction. So to get an estimate of average error during prediction, RMSE or root mean square error is used. So again, let's go ahead and calculate the RMSE value for the model which we've just built. So now that we have the actual values and the predicted values, let's bind both of them into a single data frame. So for that purpose, I will use the cbind function, and our actual values are basically present in this MPG column from the test set. And our predicted values are stored in this spread empty cars object which we had created in the previous question. So I will create this new column and name that column to be actual. And again, similarly, I'll create another column and I'll name it as predicted, which would have the predicted values. And I will store this in a new object and name that to be final data. Let me have a glance at it. View of final data. So these are the actual values of all of the mileage, and these are the predicted values of the mileage for these cars. Now we see that there is an error present in the prediction. Now what we have is actually a matrix. So we are supposed to convert this matrix into a data frame. So I will use the as.dataframe function and convert this object into a data frame. So as.dataframe, I'll pass in this object, which is final data, and I'll store the result in final data again. Now I'll have a glance at the same thing. View of final data. So these are the actual values, these are the predicted values, and we see that there is an error present in the prediction. Now the error is basically the difference between the actual values and the predicted values. So let's go ahead and calculate the error in prediction for each of these records. So to calculate the error, all I have to do is subtract the predicted values from the actual value. So it'll be final data $actual minus final data $predicted. And I will store this result in a new object and name that object to be error. So now that we've done this, I will also go ahead and bind this error calculated to the same final data frame.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So cbind, I'll bind the error object to this final data and I'll store the result in final data again. So it'll be view of final data. So this time we have the actual values, we have the predicted values, and we also have the error in prediction for each of these records. Now to get the average error which is present throughout all of the predictions, we would have to calculate the root mean square error. So the root mean square error, as the name states, first we'd have to calculate the error, then we'd have to take the square of it, then we'd have to take the mean of it, and then finally we'll take the square root. So this is how we can calculate the root mean square error. So final data $error, and we'll square this error first. After that, we'll take the mean of this squared error, and then finally we'll take the square root of the mean squared error. So this is what we have. So the RMSE value for this model which we built is 4.33. Now you guys need to keep in mind that the lower the value of RMSE is, the better the model. So let's say if we had some other model and the RMSE value for that model was 5, then this model would be better than that model. Similarly, let's say if another model's RMSE value was 2, then the second model would be better than the model which you built. Now similarly, we are supposed to implement simple linear regression in Python on this Boston dataset, where the dependent variable is this MEDV column and the independent variable is the LSTAT column. So now in the data science interview questions, it's not necessary that you'll be asked questions only with respect to one programming language. So you might be asked questions with respect to R and Python, both of them. So that's why it's necessary to be good with both of these languages. Right, so I'll head on to Jupyter Notebook and implement simple linear regression on top of this Boston dataset. So I'll start off by loading the Pandas package. So I'll type in import pandas as PD, and then I'll load this Boston dataset, and to load the dataset, I'll be using the read_csv function. So pd.read_csv and the name of the file, which is boston.csv, and I'll store this in the data object. So now that we've loaded the data, let me have a glance at the head of this data. So these are all the columns and the first 5 records present in the data frame. So we have Crim, Zn, Indus, Cas, Nox, Age, and so on. And for the task of simple linear regression, MEDV is our dependent variable and LSTAT is our independent variable. So this MEDV is basically the median value of price of the houses. And we are trying to understand what is the median value of the price of the houses with respect to this LSTAT column over here. Now, before we go ahead and implement the model, let's understand the dataset a bit more. So I'll use this data.shape, which would give me the number of rows and columns present in this data frame. So we see that there are 506 rows in total and 14 columns in total. Now I'll go ahead and separate the independent and dependent variable from this entire data frame. So for that purpose, I'll use this data.loc, and since I want all of the records, I'll take all of the records, and the only columns which I want from this entire data frame are lstat and medv. And I'll store this result in data1, and I'll also have a glance at the first 5 records of this data frame. So these are the first 5 records of this new data frame where I have only lstat and medv columns. Now I'll also go ahead and do a bit of visualization with respect to these 2 columns. And for that purpose, I would require the matplotlib package. So I'll go ahead and import this matplotlib package as well. So here what I'm doing is, I am mapping the lstat column onto the x-axis and the medv column onto the y-axis. And I will give the label of the x-axis as lstat and the label of the y-axis as medv. And finally, I'll show this graph which I've built. So what I've built is basically a scatter plot where medv is on the y-axis and lstat is on the x-axis. So you see that as lstat increases, medv decreases. So there is an inverse relationship between medv and lstat. So again, I'm reiterating it. As lstat increases, medv decreases. So this tells us that there is an inverse relationship between medv and lstat columns. Now to build the model, we are supposed to separate the independent variable and dependent variable into 2 separate objects. So I'll take this lstat column from data1 and store it into x object. Similarly, I'll take this medv column from data1 object and store it in y object over here. So x consists of my independent variable and y consists of my dependent variable. Now it's time to divide the data set into training and test sets. So we have this train test split function from sklearn.model_selection. I'll go ahead and load that function, and this function over here takes these 3 parameters. So x and y are basically the dependent variable and the independent variable, and then we have test size is equal to 0.2. So this states that 80% of the records would be in the training set and 20% of the records would be in the testing set. So it's a 80-20 split. And this random state which you see, so this is basically a seed value, so that if I want to get the same values again, I can set the same random state to get the same values. And I am storing these values in xtrain, xtest, ytrain and ytest. So xtrain contains all of the train values for that independent variable. Xtest contains all of the test values for the independent variable. Similarly, ytrain contains all of the train values for the dependent variable, and ytest contains all of the test values for the dependent variable. So now that we have xtrain, xtest, ytrain and ytest, it's finally time to build the model. So I'll go ahead and load the linear regression model from sklearn.linear model, and then I'll fit the model. So first I'll create an instance of this. So linear regression, and I'll create an instance and I'll name that instance to be regressor. And with the help of this instance, I'll fit the model on top of the training set. So regressor dot fit, and I will pass in xtrain and ytrain. So to sum it up, what I'm basically doing is building the linear regression model on top of the training set, which basically comprises of the independent variable and the dependent variable. I'll click on run. Now let me have a glance at the intercept and the m value of it. So linear regression is nothing but y equals mx plus c. And that c is nothing but the intercept. So you see that the intercept is 34.12. And m, which you see, this is the coefficient. This coefficient is nothing but the slope. And you see that the coefficient is minus 0.91. So there is a negative value associated with the coefficient because there is an inverse relationship between the dependent variable and the independent variable, as we saw over here. So as lstat increases, medv decreases, and that is the reason this coefficient is associated with a negative value. So now that we've built the model, it's time to predict the values on top of the test set. So again, I'll use this instance and I will use the predict function with the help of this instance. So regressor.predict, and I will pass in this xtest object inside this function, and I'll store this in the ypred object. So we've built the model and we've also predicted the values. Now let me have a glance at the number of rows and columns of the actual values and the predicted values. So we see that both the predicted values and the actual values comprises of 102 records in total. So now that we predicted the values, we'll go ahead and calculate some metrics. So we'll find out the mean absolute error, the mean squared error, and the root mean squared error. I'll click on run. So see that the mean absolute error for this model is 4.69, the mean squared error is 43, and the root mean squared error is 6.62. So again, the lower the values of these three, it means the better the model is. So let's say if we are comparing these values with some other model, and if these values are less than that second model, then the first model would be better than the second model. So that was implementing simple linear regression in Python. Now we have our next question over here. So the question is, what do you understand by logistic regression? Well, logistic regression is actually a classification algorithm which can be used when the dependent variable is binary. So let's take this example. So here we are trying to determine whether it will rain or not on the basis of temperature and humidity. That is, temperature and humidity are the independent variables and rain would be our dependent variable. That is, we're trying to understand whether it will rain or not on the basis of the temperature and the humidity. And again, logistic regression algorithm, it actually produces an S-curve. So let's say x-axis over here, it represents the number of runs scored by Virat Kohli, and the y-axis represents the probability of Team India winning the match. So let's say this point over here, it denotes 50 runs. So what we can see from this graph is, so if Virat Kohli scores more than 50 runs, then there is a greater probability for Team India to win the match. And similarly, if Virat Kohli scores less than 50 runs, then the probability of Team India winning the match is less than 50%. So let's take this value over here. So let's say the number of runs scored by Virat Kohli is around 60. So if the number of runs scored by Virat Kohli is around 60, then the probability of Team India winning the match would be, let's say, around 65% or so. Again, let's take this value over here. So let's say this is around 97 runs or 95 runs. And if Virat Kohli scores 95 or 97 runs, then the probability of Team India winning the match is 1, which is 100%, isn't it? So similarly, this value over here. So let's say this is around 5 runs or 10 runs. So if Virat Kohli scores 5 or 10 runs, then the probability of Team India winning the match is 0. So basically in logistic regression, the y value lies within 0 and 1 range. And this is how logistic regression works. So now we are supposed to implement logistic regression on this hard data set where the dependent variable is this target column and the independent variable is the age column. So let's go ahead and implement logistic regression. So let me start off by loading this data set first. I'll use the read.csv function. Now let me have a glance at this dataset, view of heart. So this is our entire data frame, and this target which you see, this is our dependent variable, and we have the age column over here, and this is the independent variable. So we are actually supposed to rename this. So we see that the column name is incorrect over here. So our first task could be to rename this column. Let me go ahead and do that. So I'll use the column names function and I'll pass in this data frame which is heart, and I am supposed to rename the first column. So I'll give in 1 inside the parenthesis and I will rename this to be age. So now again, let me have a glance at this modified data frame. So it'll be view of heart. So see that we have successfully renamed this column from IH to age. Now let me have a structure of this data frame. So structure of heart. So you see that most of these are integers. But then again, since we are building a logistic regression model on top of this data set, this final target column is supposed to be categorical. It cannot be an integer. So we'll go ahead and convert this into a factor. So I'll use the as.factor function and convert this integer value into a categorical value. So as.factor, and I'll pass in this column over here, which is hard $target, and I'll store the result back to hard $target. Now again, let me have a glance at the structure. So that will be structure of heart $target. So initially it was integer. Now we have converted that integer column into a categorical value, which has two levels, which are 0 and 1. So now I'll actually build a simple logistic regression model. and I'll not divide this data set into training and testing sets. So we'll do this and we'll see what are the different probability values for the person to have heart disease on the basis of the different age values. And to build the logistic regression model, we'll be using the GLM function. So again, this takes in 3 parameters over here. First parameter is the formula. So here target $age is the formula, which basically indicates that target is our dependent variable and age is our independent variable. And we are building this model on top of the entire data frame, and family is equal to binomial. So when we state family is equal to binomial, we are basically telling R that this is a logistic regression model.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And I'll store the result in log mod 1. So now let me have a glance at the summary of the model which we've just built. So summary of log mod 1. So we have this p-value over here, and we see that there are 3 stars associated with this p-value. So this basically means that we can reject the null hypothesis. That is, the null hypothesis states that there is no relationship between the age and the target columns. But since we have 3 stars over here, this states that the null hypothesis can be rejected and there is a strong relationship between the age column and the target column. Now again, we have other parameters over here. So we have something known as null deviance and residual deviance. So simply put, the lower the deviance value, the better the model. So this null deviance basically tells us the deviance of the model when we don't have any independent variables. That is, when we are trying to predict the value of the target column with only the intercept. So if that's the case, then null deviance is 417.64. And residual deviance is that deviance when we include the independent variables and try to predict the target column. So when we include the independent variable, which is age, we see that the residual deviance drops. So initially when there were no independent variables, the null deviance was 417. After we included the age column, we see that the null deviance has reduced to 401. So this basically means that there is a strong relationship between the age column and the target column, and that is why the deviance has reduced. So now that we've built the model, we will go ahead and predict some values. So now I want to know the probability of the person not having heart disease when his age is equal to 30. So now let me actually head back to this data frame over here. So the values in this target column, it is 0 and 1. So when we predict the values, we get the prediction for 0. That is, the person not having heart disease. So when the person's age is 30, we see that the probability of the person not having heart disease is 81.2%. Now similarly, I'll predict the probability of the person not having heart disease when the age is 50. So when the age is 50, we see that the person not having heart disease, the probability, it comes down to 60%. Now what I'll do is, I'll predict the values for a set of age values. So this time the age value, it starts at 29 and it goes on till 77. So I'll get a set of predictions starting from 29 to 77. So you see that when the age is 29, the probability of the person not having heart disease is 82%. Similarly, when the age of the person is 30, the probability of the person not having heart disease is 81%. So as the age increases from 29 to 77, the probability of the person not having heart disease decreases. So this is the final case over here when the age of the person is 77. So when the age of the person is 77, the probability that the person does not have a heart disease is 26%. So this is quite an interesting relationship, isn't it? So we see that as the age of the person increases, there is more likelihood that the person would have heart disease. So this model we built on top of the entire data set. Now what we'll do is, we'll divide this data set into train and test sets and build the model on top of the train set and predict the values on top of the test set. So again, for that purpose, I would require this caret package. So library of caret, Again, this caret package comprises of the create data partition function. So this takes in these parameters over here. So this is the split criteria, which is hard $target. That is, I want to split this data frame with respect to this target column. And the split ratio which I'm stating over here is 0.7. That is, 70% of the records would have the true label associated with them, and the rest 30% records would have the false label associated with them. And the final result, I am storing it in split tag. Now, what I'll do is, from the entire hard data frame, whichever records have the true label associated with them in the split tag, I'll take all of those records and I'll store them in the training set. Similarly, from the entire hard data frame, wherever the split tag value is equal to false, I'll take all of them and I will store them in the test set. So I have my training and my testing sets ready. Now let me have a glance at the number of rows of the training and testing set. So n row of train, there are 213 rows, and n row of test, there are 90 rows. So now that we have the training and testing sets ready, let me go ahead and build the model on top of the training set. So again, we'll use this GLM function and build the model. So this time the formula is the same, which is basically target tilde symbol age. So target is the dependent variable, age is the independent variable, and we're trying to determine the probability of the patient having heart disease with respect to his age. And we are building this model on top of the train set. And since this is a logistic regression model, the family would be equal to binomial, and I'll store this result in log mod 2. Now that we've built the model, it's time to predict the values. So I'll use the predict function, and this again takes in these three parameters. First is the model which we've just built, and then second parameter is the object on which we want to predict the values. So we want to predict the values on top of the test set. And finally, we'll set the type to be equal to response, which will basically give us probabilities for these predictions, and I'll store the result in pred hard. So let me have a look at the range of the predicted values. So we see that the range of the predicted values of the heart disease, it varies from 0.21 to 0.86. That is, the probability of the patient having heart disease, it varies from 21% to 86%. And this is how we can build a simple logistic regression model on top of this heart disease dataset. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is actually a table which is used to estimate the performance of a model. It tabulates actual values and the predicted values in a 2x2 matrix. So these are the actual values and these are the predicted values. So this what you see, true positives. So this denotes all of those records where the actual values were true and the predicted values were also true. So these denote all of the true positives. After that, we have the false negatives. So false negatives denotes all of those records where the actual values were true, but the predicted value was false. So where the actual value is true, but the predicted value is false, that is known as a false negative. Then we have false positives. So in false positive, the actual value is false, but the predicted value is true. And such values are known as false positives. And finally, we have the true negatives where the actual values are false and the predicted values are also false. So if we want to get the correct values, then correct values would basically represent all of the true positives and the true negatives. And this is how confusion matrix actually works. So now we are supposed to build a confusion matrix for the model which we built, where the threshold value for the probability of predicted values is 0.6, and then we have to find the accuracy of the model. So as I've already stated, accuracy is basically true positives plus true negatives upon all of the values. So this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. So when we divide the left diagonal with all of the values, that is when we'll get the accuracy of the model. So let's go to RStudio and find out the accuracy of the model which we built. So to build a confusion matrix in R, we'll be using the table function, and inside the table function, first we'll give in the actual values and then we'll give the predicted values. So the actual values are stored in this target column of the test set, and the predicted values are stored in the pred heart object which we had created. And then we saw that the range of the probabilities, it was from 0.2 to 0.8. So from that range of 0.2 to 0.8, I am setting a probability threshold of 0.6. That is, wherever the probability is greater than 0.6, it will be classified as 0, or in other words, it will be classified that the person does not have heart disease. And similarly, wherever the probability is less than 0.6, it will be classified as 1, or in other words, that the patient has heart disease. So I'm reiterating it again. So wherever the probability of pred heart is greater than 0.6, it will be classified as 0, and wherever the probability of pred heart is less than 0.6, it will be classified as 1. So let's go ahead and build a confusion matrix. So see that this is our confusion matrix, and this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. And if you want to find the accuracy, all we have to do is divide this left diagonal with all of the values. So that'll be 31 plus 17 divided by 31 plus 17 plus 10 plus 32. So you see that we get an overall accuracy of 53% for this model which we built. Now let's head on to the next question. So what do you understand by true positive rate and false positive rate? So let's start with true positive rate. So in machine learning, true positive rate, which is also referred to as sensitivity or recall, is used to measure the percentage of actual positives which are correctly identified. So the formula for true positive rate is true positives divided by all the positives. So I am stating it again. True positive rate is basically the measure of the percentage of actual positives which have been correctly identified. Now let's look at false positive rate. So false positive rate is basically the probability of falsely rejecting the null hypothesis for a particular test. So the false positive rate is calculated as the ratio between the number of negative events wrongly categorized as positive, that is all of the false positives, upon the total number of actual events. So this is how we can calculate true positive rate and false positive rate. Now we have the next question, and we're supposed to explain what is ROC curve. So ROC curve, which actually stands for receiver operating characteristic, is basically a plot between the true positive rate and the false positive rate. And it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So the closer the curve is to the upper left corner, the better the model is. Or in other words, whichever curve has greater area under it, that would be the better model. So let's say we have this curve over here, and let's say there is another curve which goes like this, which is nearer to this upper left corner. Then in that case, since the second curve covers greater area under it, that would be a better model than the first model. So this ROC curve helps us to find out the area under the curve as well as the right trade-off between the true positive rate and the false positive rate. Now we are supposed to build the ROC curve on top of the logistic regression model which we've built. So let's head back to our studio and do that. So to build the ROC curve, we would have to load the ROCR package. So I'll use the library function and load up the ROCR package. Now, this ROCR package comprises of the prediction function, which would give me a prediction object. So this takes in two parameters. First parameter is all of the predicted values. So this pred heart comprises of all of the predicted probabilities for the target column. And the second parameter is the labels of the dependent variable. So test $target has all of the labels of the dependent variable, and I will store this result of the prediction object in ROC pred heart. So now that we've created the prediction object, we can go ahead and build the ROC curve. And to build the ROC curve, we'll use the performance function, which is again a part of the ROCR package. So this over here takes in three parameters. First is the prediction object which you built. So the name of the object was ROC pred heart. After that, we will just give in TPR and FPR. So TPR and FPR stands for true positive rate and false positive rate. So for this prediction object which we built, we are basically trying to find out the right trade-off between the true positive rate and the false positive rate, and I'm storing the result in ROC curve. Now, let me go ahead and plot this ROC curve which I've just built. So this is our ROC curve over here. Let me zoom this. So we have this curve for different probability values over here. So this what you see are the different probability values. And our ideal curve should be something like this, where we have more of true positives and less of false positives. And this green color which you see, so this green color actually represents the ideal threshold value. So the ideal threshold value over here would be somewhere between 0.48 and 0.62. So this is where we would have the ideal threshold value of the probability, and this is somewhere where we can get the right trade-off between the true positive rate and the false positive rate. So maybe it could be this over here. So this point which we see, so the probability would be somewhere around 0.5 or somewhere around 0.55. So this is where we could get the right trade-off between the true positive rate and the false positive rate. So now that we've built a logistic regression model in R, again we need to know how to build a logistic regression model in Python. So this time we are supposed to build this logistic regression model on top of this customer churn data frame, where the dependent variable is this churn column and the independent variable is this monthly charges column. And after that, we are supposed to find out the log loss of the model. So we are basically trying to determine whether the customer would churn or not on the basis of this monthly charges column. So again, I'll start off by loading the Pandas data frame and also load the customer churn.csv file. And for that purpose, I'll be using the pd.readcsv function. Right, so we have successfully loaded the file. Now it's time to have a glance at the head of this data set. So these are the different columns which we have. So we have this customer ID, then we have the gender of the customer, we have the senior citizen column, which tells us whether the customer is a senior citizen or not. This column tells us whether the customer has a partner or not. This column tells us if the customer has any dependents or not, the tenure of the customer, whether the customer has phone service or not, and so on. Sort of all of these columns, the columns which are of our concern would be the monthly charges column and churn column. So this monthly charges column basically tells us the monthly charges incurred by the customer in dollars, and this churn column tells us whether the customer would churn or not. So now since we have our data the data set with us, let me go ahead and separate the dependent variable and the independent variable into two separate objects. So I'll store this monthly charges column from this customer churn data frame in the X object. Similarly, I'll store this churn column from the customer churn data frame in the Y object. So we have our dependent variable and independent variable to be separate. Now I'll go ahead and divide this model into training and testing set. And for that purpose, I would require this train test split function, which is part of the sklearn.model selection package. Now, I'll use this train test split function, and this takes in these parameters. First are basically the independent variable and the dependent variable. So the independent variable is stored in X and the dependent variable is stored in Y. After that, I'll set the test size to be equal to 0.3. So this basically states that 70% of the records would be in the training set and the rest 30% of the records would be in the test set. And again, I'll set a random state value so that I can use these same values again if I want to. And I am storing all of these values into xtrain, xtest, ytrain and ytest. So xtrain comprises of the training set of the independent variable. Similarly, xtest comprises of the test set for the independent variables. After that, we have ytrain, which comprises of training set for the dependent variable. And then we have ytest, which is the test set for the dependent variable. So now we have xtrain, xtest, ytrain and ytest. It's time to build the model, predict the values and get the log loss value. So first I will import this logistic regression function from this sklearn.linear model package, and I'll create an instance of logistic regression. I'll store it in L, and then I'll fit the model on top of the training set. So L.fit, and I'm fitting the model on top of xtrain and ytrain. After that, I'll predict the probabilities on top of the test set. So L dot predict underscore proba, and I'll pass in X underscore test, and I'll store the predicted probabilities in Y underscore pred. So now that we've fit the model and also predicted the probabilities, it's time to look at the metrics. So the question stated that we were supposed to find out the log loss. So I'll just import the log loss from sklearn.metrics, and inside this log loss function, I will pass in the actual values and the predicted values. So actual values are stored in y-test and predicted values are stored in y-pred. So we get a log loss value of 0.55. Now again, similar to RMSE, the lower the value of log loss, the better the model is. So again, let's say if there is another model and the log loss value of that second model is less than this, then that second model would be better than this model. Now we'll head on to the next question. So what do you understand by decision tree? So decision tree is a supervised learning algorithm which is used for both classification and regression. Right. So decision tree can be used for both classification purpose as well as regression purpose. So in this case, the dependent variable can be both a numerical value as well as a categorical value. So there is a flowchart like structure where the topmost node is known as the root node, the internal nodes with children are known as the branch nodes, and the final nodes without children are known as the leaf nodes. So here, each node actually denotes a test on an attribute, and each edge represents an outcome of the test, and each leaf node holds a class label. So let's say this first node over here, we are trying to determine the age of the patient. So let's say if the age of the patient is greater than 50. If the condition is true, we'll come here. If the condition is false, then we'll come here. After that, over here, we'll check if the person smokes or not. And if that person smokes, we'll come here. If that person doesn't smoke, we'll come here. Similarly, over here, the test condition could be whether the patient has any children or not. If the condition is true, we'll come here. If the condition is false, we'll come here. So this is how the decision tree works. And finally, we'll have class labels over here. So these would represent individual class labels. So let's say this represents that the person has cancer. This represents that the person does not have cancer. Similarly, this would represent that the person has cancer. And again, this would represent that the person does not have cancer. So in decision tree, we basically have a series of test conditions which would give us the final class labels. Right. So now we have to build a decision tree model on top of this iris data set, where the dependent variable is the species column and all other columns are independent variables. And after we build the model, we are supposed to find out the accuracy of the model. So let's go ahead and do this. So I'll start off by having a glance at the iris dataset. View of iris. So this is our data frame which comprises of all of these columns over here. And to build a decision tree model, we'll be loading the party package. So library of party. So again, before I go ahead and build the model, our task is to first divide this data frame into training and testing sets. So again, I will load up this caret package, library of caret. I'll use this create data partition function, and this create data partition function takes in the species column as the split column, and I'll give the split criteria to be 0.65. That is 65% of the records would be having the true label and the rest 35% of the records would be having the false label, and I'll store that in split tag. Now from the iris dataset, wherever the value of split tag is equal to true, I'll store that in the train set. Similarly, from the entire iris dataset, wherever the value of split tag is equal to false, I'll store that in the test set. Now again, let me have a glance at the number of rows of the training and testing set. So you see that there are 99 rows in the training set and there are 51 rows in the testing set. So now again that the train test split is done, we can go ahead and build a model. And to build the model, we'll be using the ctree function, which is a part of the party package. So this again takes in two parameters. First parameter is the formula. Next parameter is the data set on which we are supposed to build the model. So here the formula is species tilde dot. So this tells us that species column is the dependent variable, and when you put a dot on the right side of the tilde symbol, that basically means that all other columns except the dependent variable are the independent variables. So sepal length, sepal width, petal length and petal width, all of them would be the independent variables and species would be the dependent variable. And again, we are building this model on top of the train set and I'll store this result in my tree object. So now that we've built the model, let me plot it. So plot, and I'll pass in this object, which is my tree. Now let me zoom this. So this is our root node, and the root node, the split criteria is on the basis of the petal length column. So we see that if the petal length is less than or great, so see that if the petal length is less than or equal to 1.9, then we come over here and this tells us that the species of the flower is setosa. On the other hand, if that is not the case, that is, if petal length is greater than 1.9, then we have another test condition over here. So here we check if petal width is less than or equal to 1.7. And if it is true, again we have two scenarios. So here we are checking if petal length is equal to or less than 4.7. So if petal length is equal to or less than 4.7, then there is a 100% probability that the species of the flower is versicolor. Similarly, if the petal length is greater than 4.7, then there is around a 60% probability that the species is versicolor and there is around a 40% probability that the species is virginica. On the other hand, from over here, if we directly come over here and if we check that petal width is greater than 1.7, then in that case, there is almost a 100% probability that the species of the flower is virginica, right? So these are the test conditions on the basis of which we are trying to determine to which class does the species belong to. So now that we've built the model, let's go ahead and predict the values. So I'll use the predict function again. This takes in these parameters. First is the model which we built. So the name of the model is my tree. And then this is the data set on top of which you want to predict the values. So we want to predict the values on top of the test set. And then finally we want the response. And that response I'm storing in my pred object. Now after this, let me go ahead and build the confusion matrix. And to build the confusion matrix in R, we'll be using the table function. And the first parameter includes all of the actual values and the second parameter includes all of the predicted values. And this is what we have over here. So this denotes all of those records where the actual value is setosa and all of those actual values have been correctly predicted as setosa. So there are 17 such instances. So this denotes all of those records where the actual value is versicolor and all of them have been predicted as versicolor. So there are 16 such instances. And this one denotes those records where the actual was versicolor, but it has been incorrectly classified as virginica. Similarly, this one over here, this states that there is one record where the actual value was virginica, but it has been incorrectly classified as versicolor. Similarly, this 16 which we see. So out of the 16 records which were actually virginica, all of those 16 records have been correctly classified as virginica. Now again, to find out the accuracy, we are supposed to divide this left diagonal with all of the values. So that'll be 17 plus 16 plus 16 divided by 17 plus 16 plus 16 plus 1 and 1. So you see that we get an accuracy of 96% for the model which we've built. Now let's head on to the next question. So what do you understand by random forest model and also explain the working mechanism of random forest? So random forest is an ensemble model. That is, it combines multiple models together to get the final output. And to be precise, it combines multiple decision trees together. Now let's understand the working mechanism of random forest model. So let's say we have this dataset A and we have n records in it. Now what I'm going to do is draw samples from this dataset. So this actually will be sampling with replacement. That is, I'll take one record from dataset A, take note of it and enter the same sample in dataset A1 and then put the record back to where it came from. And I'll repeat this process n times so that there are n records in dataset A1 as well. So what you need to keep in mind is, out of these n records in A1, some of them might have come twice, thrice or even several times over. While some records from A might not have made it at all to A1. So I've created A1 like this. Now I'll go ahead and create multiple data sets the same way. And each of these have the same number of records as A. And the X over here, it could be anything. Let's say 100, 500 or 1000. So from just one data set A, we were able to create multiple data sets for our advantage. So just for our sake, let's say the data set A has 1000 rows and the value of X is also 1000. So it would be 1000 cross 1000, which would give us 1 million rows. That is, from just 1000 rows of data, we were able to create 1 million rows. Now for each of these X data sets, we'll fit X decision trees. Now let's say this A1 dataset over here has 10 independent variables. So what happens in a random forest is, each time a node is being split in a decision tree, not all 10 columns will be provided to the algorithm. This is important, so I am retreating it, guys. So each time a node is being split in a decision tree, not all 10 columns will be provided to the random forest algorithm. So now the question arises, what would be made available to the algorithm? So only a random subset of these 10 columns will be available to the algorithm. So let's say I want to split this root node now. So instead of providing it all the 10 columns, only a subset of the columns will be provided. So let's say 3 columns. And it could be any 3 out of the 10. And with those 3, the algorithm goes on to split the node. And similarly, from the left node over here, it is again going to be provided with a random set of 3 variables. And it is not necessary that the left node should get the same 3 variables. It can be a different set of 3 columns altogether. So whenever we are splitting a node, it is given a random set of m predictors from the entire predictor space. And the reason this is done is to make each of these X trees very, very different from each other. Now let's say a new record Ri comes our way. Then we are going to pass this record to each of these X trees, and we are going to get each tree's prediction on what class this new record is going to represent. And since we have X trees, we'll get X predictions in total.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And to get the final prediction, all we have to do is select that class which would have the majority of the votes across all the predictions of the individual trees.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So guys, this is the working mechanism of random forest. So now we'd have to go and build a random forest model on top of this CTG dataset, where NSP is the dependent variable and all other columns are independent variables. So let's head on to RStudio and implement the random forest model. Alright, so let me start off by loading the CTG dataset. So I'll use the read.csv function and load this file. Now let me have a glance at this data. So view of data. So this is our dataset which has all of these rows and columns. And this is our dependent variable where we have these 3 values, 1, 2 and 3. So this 1 basically means that the person does not have cancer, 2 means that the person is suspected to have cancer, and 3 means that the person has cancer, right? So these are the 3 different levels associated with this NSP column. Now let me have a glance at the structure of this dataset. So structure of data. So you see that this NSP column is actually an integer. So we'd have to go ahead and convert this integer type into a factor. So I'll use the as.factor function and convert that NSP column from an integer to a factor, and I'll store that back to same column, data $NSP. Now let me have a glance at the structure of it again. So structure of data. So see that initially this column was an integer. So using the as.factor function, we have converted this into a factor with 3 levels. Now let me have a glance at the frequency of the values of this NSP column. So see that there are 1655 patients who don't have cancer, 295 patients who are suspected to have cancer and 176 patients who do have cancer. So now, before we go ahead and build the model, we are supposed to divide the data set into train and test sets. So first we'll set a seed value. So that seed value would be 1, 2, and 3. Now, I'll go ahead and create the data partition, and the split column is basically this NSP column, and the split ratio which I'm giving over here is 0.65. That is 35% of the records would be in the test set and the rest 65% of the records would be in the training set. And I'll store this in split tag again. Now from this entire data object, wherever the value of split tag is equal to true, I'll store all of those records in the train set. Similarly, from the entire data object, wherever the value of split tag is equal to false, I'll take them and I'll store them in the test set. So we have our training and testing sets ready. Now again, let me have a glance at the training and testing sets. So n row of train, there are 1383 records in the training set. Similarly, n row of test, there are 743 records in the test set. So now that we've divided the data into training and testing sets, I can go ahead and build the random forest model. So for that purpose, I'd have to load the random forest package. So I'll use library of random forest and I'll load up the random forest function. Now again, I'll set a seed value and the seed value would be 222 and I'll build the model. And I am building the model on top of the train set. So I'm using the random forest function. And this random forest function again takes in two parameters. First parameter is the formula. Second parameter is the object or the data set on which we are supposed to build the model. So the formula is nsp tilde dot. That is, this nsp column is our dependent variable and all other columns would be our independent variables. And we're trying to determine whether the person does not have cancer, is suspected to have cancer, or has cancer with respect to all of the other columns. And we are building this model on top of the train set, and I am storing this result in the RF object. Now that we've built the model, let me go ahead and predict the values on top of the test set. So again, I'll be using the predict function. This again takes in two parameters. First is the model which we've just built. So the model which we've built, the name of that model was RF, and we are supposed to predict the values for the test set. So I'll give in test over here and I will store the result in the P1 object. Now let me build a confusion matrix for this. So table, and this table function will take in the actual values and the predicted values. So the actual values are stored in the NSP column of the test set and the predicted values are stored in the P1 object. So this is what we have. So this left diagonal represents all of those values which have been correctly classified. So this 567 which you see, so this represents all of those records where the patient actually did not have cancer and it was correctly classified by the model that those patients did not have cancer. So this 8 which you see, this tells you that there were 8 patients or 8 records where the patient did not have cancer, but then again it has been predicted that the patient is suspected to have cancer. Similarly, this 4 over here, it represents those records where in actuality the person did not have cancer, but it has been predicted that the person has cancer. Similarly, if we take this row over here, this 20 represents all of those records where that person in actuality is suspected to have cancer, but it has been incorrectly classified that the person does not have cancer. And this 81 represents all of those records where the person is in actuality suspected to have cancer and it has been correctly classified. And that is how it goes for the rest of the records. So if you have to calculate the accuracy, we are supposed to divide this left diagonal with all of the values. So that will be 567 plus 81 plus 51 divided by all of the values. So 567 plus 81 plus 51 plus we have 2 plus 3 plus 8 plus 4 plus again 2 plus 5 plus 5. And this gives us an accuracy of 96%. So what I've done is I have divided this left diagonal with all of the values, and for the model build I got an accuracy of 96%. So guys, these are some of the questions which you frequently come across when you appear for data science interviews. Now let's actually start off by having a glance at the job trends of different programming languages. So here we are comparing Python, R, Angular and C. And it's very obvious that Python is the most preferred language across various industries. So you see this blue color line over here. So this blue colored line is for the Python programming language. And if you closely observe this blue colored line, you will observe that the popularity of Python has been steadily increasing over the years. So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue and so on. And in total there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'd have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary and we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run and we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2, and house number 3 are our real world entities, which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name, and after this I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object, right? And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard, right? So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created 2 get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly, I'll create another method which would be put age and I'll pass in self inside this. So for this, it would be print of your age is. Let me again put in double quotes over here. Right. So your age is, it would be self.age. So we have created our class where we have 2 variables, name and age, and I've created 4 methods. And out of those, from those 2 methods, I'll be getting the name and age of the person. And the rest of the 2 methods would help me to print the name and age of the person. Right, I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the getName and getAge methods. So person1 dot get name. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right. So now it's time to get the age of the person. So I'll type in person1 dot get age. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right, so we have successfully created our class which would print out the name of the person and the age of the person. Right, so next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method. Right, so we have created our init method, which is basically a constructor, and going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this, we have age. So let me change this to be age over here. And this would be self.age. After this, we'll have to print in the branch. So let me just put in branch over here. And this would be self.branch. Right, so we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now, since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use the super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3. And the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 NumPy array comprising of all the zeros. So there's a 5 cross 5 NumPy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the NumPy library. Let me just type in import NumPy as np, and inside A, I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out A. So we have successfully created our 5 cross 5 NumPy array where all of the values are just zeros. Now let's say we have two NumPy arrays like this. So this is our first NumPy array, this is our second NumPy array. First NumPy array comprises of 1, 2 and 3. Second NumPy array comprises of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7 and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the NumPy library, import NumPy as np. I will go ahead and create my first NumPy array, A equals np.array. And the values are 1, 2 and 3. Similarly, I'll create my second NumPy array, which is B. I'll change this variable to be equal to B, and the values are 4, 5 and 6. Now, to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the NumPy arrays which I'd have to add. So I want to add A and B. And I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a NumPy array. So this is our NumPy array over here. and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68, and I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X, and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this, and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this numpy array. So 100 and 68 are the two highest values from this numpy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as pd. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4 and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24 and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango and orange, and the count of the fruits is 12, 24 and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width and species. Now out of this we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as PD. And after this, to load a CSV file, I'd have to use the pd.readcsv function. And I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this data set. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3, right? So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal.width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we give in the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be Pandas and Numpy. So import Pandas as PD and import Numpy as NP. After this, I'll load the iris dataset. So iris equal to pd dot read CSV, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column. And the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame. And with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the Pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readCSV function. And I'll give in the name of the file, which is enhance.csv, and I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right, so we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here, right? So this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in two parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function, and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda, and then you'll give in all of your arguments. After that, you'll put in a colon, and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda, and I'll give the name of the variable to be a. I'll give a colon, and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x axis, y label is y axis. So a simple line plot, and we can create this line plot with the help of the matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the numpy package. So I'll type in import numpy as np, and I would also need the matplotlib package. So I'll type in from matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x, and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here, and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, Now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt dot plot, and I'll pass in x comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt dot x label. So the label would be x-axis. Similarly, plt dot y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt dot title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange, and we've got the cost of the fruits on the y-axis.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So let me start off by loading the required library. From matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right, so now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list. Right. So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string, it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1. Right, so this is our numpy array which comprises of the numbers from 0 to 9. And we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the numpy library, import numpy as np. After this, what I have to do is create my numpy array. So arr equals np.arange and it will go from 0 to 10. Let me just print out this numpy array over here. This is my numpy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So arr percentage 2 and if it is equal to 1. So what I'll do is I will divide 0 with 2. I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1 and 9 with -1. Now we'll have to perform an operation so that we get the common items between two numpy arrays. This is our first numpy array. This is our second numpy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays. And I'd want to extract these two. Right, so we have created our arrays over here. This is the first numpy array and I'm storing it in A. This is my second numpy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two numpy arrays inside this as the parameters. So a comma b, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb, so we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as pd. Now I'll create the series pd.series, and I'll pass in the values, which are basically Mary had little lamb. Right, so this is done, and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now. Right, so this is my pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital. Right, and as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here. Right, so all of these elements have been converted into title case. So now we have the same pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3 and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this pandas series. Import pandas as pd. Let me again create the series. Ser equals pd.series, and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this pandas series, I'll have to use the map method. So ser.map, and inside this I'll again create a new lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In had there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s_length. Let me load the package. Import pandas as pd, and I'll also load the file. So pd.read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s_length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here. I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s_length. So it'll be s_length. So this is how it goes. So iris.rename and the original column name is sepal.length, and I'd have to change it to s_length. And I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1.head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the Pandas library, import Pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in Xtrain, Xtest, Ytrain, and Ytest. So Xtrain would comprise of all of the training values or all of the training records for the features. And Xtest is basically the test set for the features. Ytrain is the train set for the target and Ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of Xtrain and Ytrain, or in other words, I'm fitting the model on top of the train set. Right. So now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length, and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start off by loading the requisite packages, which are NumPy and Pandas. So import NumPy as NP and import Pandas as PD. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv, and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these 4 columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first 4 columns. So I'll just extract sepal length, sepal width, and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame, and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'd have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set, and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain, and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics, and we'll also get the accuracy score. Right. So this is my confusion metrics, and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly, and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly, and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same, and it comes out to be 91.11.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.